23.
23.
Yep.
This one, right?
Yes.
Okay. What's your approach? What have you done for solving this?
If you multiply by ln, you can get rid of the denominator. But
yes, these are personal approaches for this. The most useful idea is what for solving a problem?
small example.
Exactly. If you use that, then you can understand what happens and you can solve the problem. Okay. Have you tried the small examples?
No.
Okay. So always when you couldn't solve a problem at home or in the exam, check a small example. So check a small example first and you will see can you find the idea. Okay.
Okay. I found that it works if n equals 6, 7, or 8, but haven't tested for anything else.
Okay, so let's
I mean
try.
past 8.
Okay, so it's for 1 over 1, we know Kn is equal to Ln, right?
Yeah.
1 over 2, it's 1 over 1 plus 1 over 2, and it's same, it's 3 over 2, right? 1 over 1 plus 1
Yeah.
over 2 plus 1 over 3, it would be what over 6?
11.
Exactly. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 is what? 11 over 6 plus 1 over 4, which is what?
25. 25 over 12.
45. 12, 22 plus 3, 25. Again, it is, for this one, it is not LCM, right?
Yeah.
Oh, so let's see what happens. Here, when we consider 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. When we consider common denominator is 24. It's 24 plus 12 plus 8 plus 6. No. LCM is 12, right? Sorry, LCM is 12. And it is 12. So again, 4 doesn't work, right?
Yeah.
Agreed? Okay, so 1 plus 1 half plus 1. We want to find first number in the beginning, first number that works. So if you check this one, I want to say this one again is LCM. Why? LCM is what? 5 times 4 times 3, 60, right?
Yeah.
And it is 60 plus 30 plus 20 plus 15 plus 12. If you want to be, when it says Kn is less than Ln, means that you can simplify, right?
Yeah.
Okay, if you want to simplify, this one should be multiple of 2 or 3 or 5, right? To be able to simplify. Agreed?
Yeah.
This one is not 2 because it is odd and all of them are even, right?
Yeah.
Is not multiple of 3 because look, all other denominators are multiple of 3 only except this one, right?
Yeah.
And also it's not multiple of 5 because all of them are multiple of 5 except only numerator of this, right?
Yeah.
So that's the reason. Now if we check 1 over 1 over 2, 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6, here it is again 60, right? But it is 60 plus 30 plus 20 plus 15 plus 12 plus 10, right?
Yes.
Okay. Now, for 3, this one is not multiple of 3. This one also is not multiple of 3. So the sum is multiple of 3, right?
Yeah.
And do you agree it causes to be able to simplify because numerator is also multiple of 3, so it is the first one that works, right?
Yeah.
So only because of this proof n6 works, and what are the other n's that work?
I know n7 and 8
7
work.
and 8, because again for 1 over 7, numerator of this is multiple of 3. Also for 1 over 8, multiple of 3. So, and this sum is multiple of 3. For all of them, we can simplify by 3, right?
Yeah.
Okay, now if you check for 9, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 9. The denominator, if you check the denominator, it is 9 times 8 times 7 times 5 times 3, right?
Yeah.
Okay. Now, if we can simplify, the numerator should be multiple of 2 or 3 or 5 or 7 or only, we don't have 3, sorry. We don't have 3, 5, okay. So the numerator should be multiple of 3 or 2 or 7 or 5, right?
Yeah.
The numerator is multiple of 2 or not?
I think
It is A. You should check 2 divides A or not. The reason is what? It's not hard. Pay attention.
no.
Why not?
I think for all the terms you'd multiply by some 2, except for 1 over 8.
Exactly. Because for 1 over 8, it is 9 times 7 times 5, right? But for the other,
Yeah.
it is multiple of 2. So 2 doesn't divide 8. What about 3? 3 divides A or not?
I think also no.
Why not?
So for 1 over 3, it would be 1. And for 1 over 9, it would be, for 1 over 3, you'd multiply by 3. And for 9, you multiply by 1.
For all of them, it would
So
be multiple of 3. Only for 9, it is not multiple of 3, right?
Yeah.
Only because of 9. Here, only because of the denominator 8. Because when all of them are multiple of something and only one of them is not, so the sum is not multiple of that number, right?
Yeah.
And for 7, we can say same thing, and also for 5. For this one over 7, this one over 5, right?
Yeah.
Okay, so like this, for example, if you want to check 1 over 1, 1 over 2 to 1 over 10, you need to check only what?
2 and 5.
Not 2, because look, the denominator is 8.
Oh, 8 and...
No, you don't need, because look, all of them are even except this, because only we have one number that has the maximum power of 2, right?
Oh, yeah.
So here we only need to check 5, because we want to see 5 divides A or not. So we should check only this one and this one, right?
Yeah.
Okay, so this one again is A. You can say again 9 times 8 times 7 times 5. So we should check what plus what to see is it multiple of 5 or not.
So for 1 over 5, multiplied by... multiplied by 5. And then...
9
So it
times
would be
8
no.
times
It's
7
not
is
divisible
numerator
by
of 5, right?
Yeah.
Numerator of 10 would be what?
9 times 4. No. 9 times 4 times 7, yeah.
Exactly. So if you want to check is it multiple of 5 or not, it is 2 plus 1, 3. It's not multiple of 5, right? So again, n10 doesn't work, right? Obviously, n11 doesn't work, right? because we have same thing
Yeah.
for powers of 2, powers of 3 for all of them. And 12 also doesn't work, right? Because it is not maximum, for example, a prime to the maximum power, right? Understood why
Yeah.
for 12 doesn't work, or want me to explain more?
I understand.
Okay. Because if you want to check 2, only 8 is important. If you want to check 3, only 9 is important. For 5, we check 5 and it is, we don't have any good thing, right?
Yeah.
For 12 also we have 9, so 13 also doesn't work. 14 doesn't. No. For 14, because of 7, we should check 2. Not, it shouldn't be multiple of 7, right? Otherwise, it's a good number. So for n14, 1 over 1 to 1 over 14. LCM of the denominators would be what? Would be 9. Again, would be same thing, right? But sorry, we have
About
also
11
11 and 13, right?
Yeah.
Okay, so we should check, is it multiple of 7 or not? How can we check?
So for 7, you'd multiply by 9 times 8 times 5 times 11 times 13.
Yes.
And for 14, it'd be 9 times 4 times 5 times 11 times 13.
And the sum would be 9
You wouldn't
times 4
multiply
times
by, I mean,
11
wouldn't you
times
not
13
multiply by 7?
times 3. Oh, sorry, not. So it would be this, right?
Yeah.
And you multiply it by 3. It is exactly like the thing that we did for 5, right?
Yeah.
So 14 is bad. 7 doesn't divide A. 15 similarly is bad because For 15 we should check what?
5.
5. 5 divides A or not. So we should check what?
5, 10, and 15.
Yes, we can check what? Let me tell you. Look, do you agree the LCM is 11 times 13? And we should check 1 over 5 plus 1 over 10 plus 1 over 15, right? I think it's easier to
Yeah.
check. So, and if you check this, it would be 15, 3. Oh, no. Common denominator is what? 30, right?
Yeah.
And it would be 6 plus 3 plus 2. 6, 9, 11. It is 11 over 30, right? And it is not multiple of 5.
Yeah.
We cancel 5, so 15 doesn't work. For 16, obviously doesn't work. 17 doesn't work. What about 18? For 18, we should check what?
3 and 9. And actually, no, just 18, I think. 18
3
and 9,
divides,
maybe.
because of which 2? We should consider which 2 denominators?
9 and 18.
Yes, and if we check 9 and 18 like this, we have a multiple of 3 like this, and it would be good. It would be multiple of 3. Agreed?
Yeah.
Okay. So 18 is good. 19 is good or not?
No.
Why not?
All the primes aren't good.
No, but do you agree because of when 18 is good? Look, the LCM times 1 over 9 plus 1 over 18, right? It would be
Yeah.
LCM over 18 times 3, which is multiple of 3, because LCM is multiple of 18, right? LCM of 1 to 18.
Yeah.
So because it is multiple of 3 for 19, if you check also it is multiple of 3, right?
Yeah.
For 20, can you tell me until which number the numerator is multiple of 3?
I think 26.
Exactly, because until 26, for 3 only we should check 9 and 18. But when we reach 27, it's not multiple of 3, because the only denominator that is multiple of 3 is for 27, right?
Yeah.
Okay, so which numbers? What the problem is until 22 check. So which numbers were good?
6, 7, 8, and then 18, 19, 20, 21,
Yeah.
22.
20, 21, 22. So how the answer is what?
8.
Exactly. Understood completely how we solve this?
Yeah.
Again, do you agree small example helps us to find the key point here?
Yeah. Yeah.
See, for example, which numbers work. Something like that. Okay. So what's your next question?
Um, let's see.
We solved 24 before, right?
Yeah, we did.
25 is hard. Have you solved 25?
Oh yeah, 25.
It is hard to understand the problem, right? So
Yeah.
when you see a problem it's hard to understand, check some small examples. Understand it better. Because it says m is satisfied, so we can consider m is 5, okay?
Yeah.
And it says odd integer, so then d of m, these things. So d of 5 is a1, a2, a3, a4, such that which of them is between what and what?
1 and 5.
Exactly. For all of them, such that 5 divides some of them. So now agree that we are understanding the problem better.
Yeah.
Because 5 divides this, there is a polynomial. This one such that dm is qm. Okay. So it says d5 is equal to q of 5. Q of 5 is what? Is c3, 5 cubed plus c2. 5 squared plus c1, 5 plus c0. And then it says for all odd integers m. It says this is correct for 5, this is correct for 7, this is correct for 9, right?
Yeah.
And then it wants us to find C1. So probably from 5 we can reach some good result. From 7, from 9, if you check some of them, then we can find C1, okay?
Yeah.
And because we have 4 variables, probably we can find, if we write 4 equations, we can find. So first, we should calculate D5 is what, right?
Yeah.
Okay, so let's forget about polynomial because it's after that. And try to calculate D5. For finding D5, want hints or want to try on your own?
I can try.
Okay, try.
Here I is from 1 to 4, right?
Yes. I mean, A1, this one,
Yeah.
all of them are from 1 to 5. If you think it is hard, try to solve N1. N1 is easy.
I can solve
Try
it.
to check
I can solve
N1.
it. I was just confused. Okay.
Calculate D of 1. We won't apply D1 for this because it says M at least 5, but for only understand the approach is
okay.
what. D1 is easier. Try to find D1.
Yeah. Is it just 1?
Exactly, because it is unique and 1 divides some of them, right? Now
Yeah.
calculate M3. D3 is what. Try. So look, A1 to A4 again, because 4 is not related to M. AI is from what to what?
1, 2, 3.
And what divides what?
3 divides the A1 plus A2 plus A3 plus A4.
Exactly. Try to solve this.
Okay. Is it even possible?
Why it's
Do
not
they not have to be
possible?
like distinct?
Look, for example, A1 can be 1, this one can be 2, this one can be 3, this one can be... it says
But even
distinct
if it's distinct.
integers. Wow. So, geometry. So again, it's 0. So also previous one is 0. That's the reason it should be at least 5, right? Because they are
Yeah.
different, so it will be easier to check M5, right? They are different.
Yeah.
So check M5, find Z5.
Okay. I get 0.
0,
Yeah.
for example, 1, 2, 3, 4. 1, 2, 3, 4 is good.
Oh, it divides. Oh, never mind. Yeah.
Okay, try.
It's just gonna be the permutation of 1, 2, 3, and 4, right?
Exactly. So it is what?
How do I find it then? Is it
4
isn't
factorial.
4 times 4 16? Oh, 4
Why
factorial?
6? You said permutation of 1 to 4. So permutation. So the first element A1 has 4 cases, A2 3 cases. 2 cases, 1 cases, 4 factorial.
Oh yeah, 4 factorial. Yeah.
And the reason it is only this case 1, 2, 3, 4, because when you have 1, 2, 3, 4, 5, A1 to A4 is sum of them is what? 1 to 5 is 15. It's
15.
15 minus x, the number that is not here, right? Because it is
Yeah.
multiple of 5, 5 divides this, 5 divides 15, so you can subtract 5 divides x. The only number here is multiple of 5, right?
Yeah.
So because this is 24, you can plug in here 24 and you can find one equation in terms of these things, right?
Yeah.
Okay, now let's try to calculate M7 to see it is what. And then if you can find general form of M, then it will be easier to find C. So try to find this 7 is what, okay?
Okay. I get a permutation of 3, 5, 6, and 7.
Yes, but we should see, we should prove we don't have any other case.
Yes, so like you said there, like so the sum is gonna be 28 minus 3 numbers. I left them
The
like
sum of
B1,
those 3 numbers should
B2,
be
B3,
multiple of 7, right?
7. Yeah, yeah.
So there
So
are
I
a
just
lot of
found that it's gonna
cases
be
to check to reach 3 numbers that are multiple of
it's,
7.
yeah, but they have to be distinct, so I just get 4, 2, and 1.
Also, you can say
Like these are the
7,
only
1,
two.
and 6, right?
Sorry?
7, 1,
7, 1, and 6.
6. If you remove these 3 numbers, also the left will be multiple of 7.
Oh yeah, that's true.
Okay, so try to see, can you find all of the cases? This is a good problem in case work. Then I will tell you how to solve for general M. But for M7, it's a good problem in counting problems and case work. Try to see, can you
Yeah,
find all of the cases? Yes.
it's just 7, 6, 1, and 4, 2, 1. Like these two cases, I think.
7, 5,
That's
2.
all I get. Yeah, because I started from 6, that's why I could not.
7, 6, 1, 7, 5, 2, 7, 4, 3. Okay.
Oh yeah, that's also
6,
true.
5, 3. There are a lot of cases. Try to check all of them and try to not ignore any of them, okay?
Okay. I think I get so 7, 5, 2, 7, 6, 1, 7, 3, 4, 6, 5, 3. I think
So
those
how many
should be the
cases you
cases.
found?
Like 4.
But let me tell you how you can check to not miss any of them. As I said, you should say, okay, 1 to 7 minus 3 numbers, right? And because 7 divides that, so 7 divides sum of x, y, z, right?
Yeah.
So x plus y plus z can be what numbers?
7, 14, and
Cannot be 21 because we don't have
yeah,
3.
20. Yeah.
You should select
Yeah.
3, 7. So for 14, again, if we select 7, it will be what if we select 7? What are the cases?
5 and 2, 6 and 1,
6, 1,
3 and 4.
5, 2, 3. Okay.
Yeah.
Now suppose that we don't select 7. Okay. Then in this case, if we select 6, then it will be what?
5 and 3.
Yes, we need 8 to reach. So only 5 and 3 and what and what? 4 and 4. 4 and 4 are the same. So if you don't have 6, 5, 4, 3 is 12. You cannot reach 14, right?
Yeah. Yeah.
Now suppose the sum is 7, okay? When the sum is 7, we cannot select 7 and 6, right?
Yeah.
So we cannot also select 5 because then 5, 1, 1, right?
Yeah.
So if we don't select 4 also, it won't reach 7, it's 6. So we have to select 4.
Yeah.
So you need 3, 4, 2, 1 only, right?
Yeah.
So now can you tell me this 7 is what then?
We have 5 cases, and is it 5 times 4 factorial?
Exactly 5 times 4. Okay. So we can find another equation, but if you want to continue, you can do this. You can calculate 9 and exactly like this, 9 and 11, and use casework. And without any idea, you can solve it, but it takes time, right?
Yeah.
Okay. The idea of this is usually these ideas are more useful in full solutions exam, like BMO, British Mathematical Olympiad, or for example, AMO, JMO. Let me tell you the idea as well. Again, the idea of this is famous. Let me tell you a problem that I saw in a book for the first time that I found this idea. It is this. For example, suppose that we have A1, again like this, A1, A2, A3, A4, A5, and the sum should be multiple of 5, and A1, there are A1 to A5 are distinct numbers, and AI are from 1 to 100. And let me check it again. We had 6 numbers, so A5 to A6. And 5 divides some of them to A6. And okay, A1 to A6 are distinct. And AI are 1 to 100. And it says what? How many A1 to A6 are there? Okay.
Yeah.
So for this one, want to try a bit on your own or one thing from the beginning?
I can try.
Okay, try a bit.
Yeah, I need a hint.
Okay, sure. So here theoretically we can consider we want to find different cases and then multiply it by 6 factorial, right?
Yeah.
Okay, can you tell me only one case? It is not important that the sum is multiple of 5 or not. Only one case. 6 numbers, any 6 numbers from 1 to 100 that are distinct. Tell me an example.
100, 99, 98, 97 to 95.
98, then what?
97, 96, 95.
97, 96, 95. We can check, for example, some more, for example, general, because it is a specific. For example, we can say this one 95, for example. We can write it in increasing order or decreasing order. For example, we can also write, for example, 25, 1, 2, 3, 4, 5, and 2, okay? Okay, then I add 1 to, so it has a sum, right?
Yeah.
And consider sum mod 5, okay, because we want.
Okay.
Now add 1 to each element, and if you reach 100, we consider 1. So it will be 1, 100, 99, 91, 26, and 3, right? So the sum is
Yeah.
what mod 5?
S.
Yes, S, no, it's not S. Pay attention,
Is it S plus 5 now?
S plus 1, because we have 6 elements.
Oh, yeah, that's true.
And also look, when 100 goes to 1 again, it will be added by 1 mod 5. So S plus 6, which is S plus 1. So do you agree again, if we continue this, 2, 100 plus 1 is 1, 100, 92, 27, 4. Again, it will be S plus 2.
Yeah.
All the way to last set is what? 99. Next one is what?
100.
100. Next one.
90. Yeah. Then 98.
No. Not the 100. Look at 100 is here.
Oh. So this is 98, right?
Yes. Next one is what?
97.
Yes. Next one.
92.
No. 92 is here. It is first part. It is second part. It is third part. It is 100th part.
Is it 89?
Exactly. 89. What's the for next one?
76.
No, it's not 76, right?
Oh, 24.
Exactly. And the next one is what?
Is it 4?
Yeah, it's 4. No, it's not 4. Look, 4 is here.
Is it 2 then?
It's what?
2?
No, it's not. 1 pin?
Yeah, sure.
Oh. But as you can see, directly after one step, we reach 2. If you consider 100 first step, we agree all of them will be same.
Yeah.
So these numbers are 1 before that. That's less than 199, 99.
That's 1.
Exactly.
That's 1, yeah.
So this one is S plus what?
99.
Is what?
99.
Exactly. And can you tell me how many of these summations are multiple of 5?
Multiples, 99 over 5.
100 over
4.
5.
Oh,
Because
yeah.
S plus 0.
Oh, yeah.
This
That's true.
what?
20.
Yes, because in each 5 of them, we have one multiple of 5, right?
Yeah.
And do you agree each 6 numbers will be in exactly one of these groups?
Yeah.
Okay, so, and do you agree there are some groups? Like, for example, this one. The first one is S, next one S plus 1 to S plus 99. And all of them are related to each other. And then next one, for example, the sum is S1. S1 plus 1 to S1 plus 99, right?
Yeah.
So, and in each of them, we have 100 numbers, but 20 are good, right?
Yeah.
80 are bad, 20 are good, 80 are bad. So in general, if we answer all of them, and we can split all subsets of 1 to 100 with 6 elements to these circles, right?
I don't get it.
How many subsets with 6 elements are there from 1 to 100?
100 to 6.
Yes, and do you agree each of them is in exactly one cycle like this? We can write.
Yeah.
Okay. So, how many of these subsets are multiple of 5?
20.
20 in each cycle in total.
20 times 100 to 6.
All subsets are these. How we multiply it by 20? I want to see how many good subsets do we have, okay?
Okay.
Total number of subsets is this. You say the answer is 20. It is greater than total number of subsets. I want to find now good subsets, okay? Number of good subsets. It is what? This one is total number of subsets. So good subsets are what?
Is it 20?
Let me explain this with small numbers on the topic. For example, suppose we have A1, A2, A3, A4, and we want that 3 divides A1, A2, A3, A4, and our subset is 1, 2, 3, 3 is obvious, 4, 5, what else can we say? 4, 5, 4, 1, 3, 1, 5, after 5. Okay, 6. Okay, now we want to see how many good subsets are there. Okay.
Yeah.
Okay, 6 choose 4, 6 choose 2. Okay. So the first one, you can say 1, 2, 3, 4.
Yeah.
Then it goes to what? 2, 3, 4, 5, right?
Yeah.
Then it goes to what? 3, 4, 5,
6.
6. Then it goes to what?
4, 5, 6, 7.
We don't have 7, so
1,
it
I
is
meant.
1, right?
Yeah.
1, 2, 3, 4. Next one is what? 5, 6, 1, 2, right?
5, 6, 1, 2. Yeah.
Next one is what?
6, 1, 2, 3.
Yes, and this, right?
Yeah.
And in this subset, we have 6 numbers. 2 of them are good, right? Exactly like previous one, because it is S.
Yeah.
Sum is S plus 1, right? We agree it's S plus 1 because we add 4,
Yeah.
right?
Yeah.
Look, when we from 6 we go 1, it is again plus 1 mod 3, right? For all cases. If we answer
Yeah.
mod 3, S plus 3, S plus 4, S plus 1. So how many subsets here in this cycle are good?
Uh, 2. 6 over 2.
Yes, 6 over 2. And
So
we can also
yeah,
find them.
3.
We can find them. The first one is 1 mod 3, 2 mod 3, so this one is good, right?
Yeah.
Which one is good? What's the next subset that is good?
S plus 5.
Which one?
S plus 5.
Ah, yes, exactly. This, right?
Yeah.
Okay. Now, 6, 2, 6, 5. Okay. So if you consider next subset, it will be what? For example, 1, 2, 4. Okay, so 1, 2. Can you hear me?
Yeah, I can.
Okay, so let's take for example 1, 2, 3, 5, right?
Yeah.
How many subsets do we have? It's 6 choose 4, right? It's 6
Yeah.
choose 2, which is 15, right?
Yeah.
But in each group we have this. Okay, so let's check. 1, 2, 3, 5. We don't have 1, 2, 3, 5 here, right?
Yeah.
Okay, so the next one is what? 2, 3,
2,
4,
3,
6, right?
4, 6.
Next one is
Yeah.
what?
3, 4, 5, 1.
Next one is what?
4, 5, 6, 2.
Next one is what?
5, 6, 1, 3.
Next one? 6, 1, 2.
6, 1, 2. Yeah.
Oh. And they are disjoint subsets, okay? Because if one of them is same, then the whole cycle is same, right?
Yeah.
Because from one of them, we can determine all other elements of the subset, right? Here, which of them are good? The first one is 1, 2, 3, 3, 6, 5. This one is good. 1, 2, 3. This one is good, right?
Yeah.
Okay. What is left here? 1, 2, 3, 5. 1, 2, 3, 6. 1, 2, 4, 5. 1, 2, 4, 5. We don't have 1, 2, 4, 5. Do we have? Look, 1, 2, 4, 5. 1, 2, 4, 5.
No.
1, 2, 4, 5. 1, 2, 4, 5. No, we don't have. 1, 2, 4, 5 will be what?
2, 3, 5, 6.
This one goes to what?
3, 4, 6, 1.
This one is what?
4, 5, 1, 2.
It goes here, right?
Yeah.
Okay. Now, do you agree here? How many of them is good? 1, 2, 4, 5 is what? Is 9, 3. This one is good, right?
Yeah.
So now, can you tell me how many good subsets are there?
5.
Yeah, do you agree here 1/3, 1/3, 1/3? In each cycle, 1/3 of them are good, right?
Yeah.
So do you agree you can say 6 choose 4 over 3? Which is 15 over 3, 5.
Yeah.
Okay, and the loop is multiple of 3 because it is s plus 1, s plus 2. If the loop is 3 or 6 or 9, right? So here also
Yeah.
we have some cycle. The length of the loop can be 100 or multiple of 5, right?
Yeah.
And the agree in each of these cycles, we have 1/5 that are good, right?
Yeah.
So can you tell me how many good subsets are there?
6 choose 5 over 5.
100 choose 6 over 5, right?
Total. Yeah.
Exact, total over 5. Okay, understand completely why we divided by this and how it
Yeah.
works?
Yeah.
Okay,
Yeah.
now I want to solve exactly this problem. And this problem, we calculated number of subsets, 100. Choose 6 over 5. But because we should consider the permutation, we should multiply it by what?
6 factorial.
Okay, understand?
Yeah.
Okay. Now we want to calculate D7 with the same way, okay?
Okay.
So for D7, It says again A1, A2, A3, A4. I say, okay, let's add 1 to each of them. A1 plus 1, A2 plus 1. And we consider all of them mod 7, okay? And because it
Okay.
says the numbers are from 1 to 7, after 7 we go to 1 again, and it's good. It's next one after that, right?
Yeah.
A3 plus 1, A4 plus 1. So it is S plus 1. We go all the way to A1 plus 6, A2 plus 6, to A7 plus 6, okay?
Yeah.
If you add 7, they will be same, right?
Yeah.
So how many of them are multiple of 7?
3.
And one thing. If we add, how many numbers do we have? 4 numbers. Wow. So, no. It is not S plus 1. It is S plus what? S plus 4, right?
Yeah.
S plus 4 times 2, S plus 4 times 6, right?
Yeah.
I want to prove all these 7 numbers are different mod 7, okay?
Okay.
Try to prove it. We want to find a general way to prove also for any m. Try to prove all these 7 numbers are different mod 7. Try.
How do I even prove it? Because I just see that there's going to be S and then S plus 4, S plus 8, S plus 6, 12, S plus 16, S plus 20, S plus 24. So they're just different from one
Yes,
another.
you can say if S plus 4i is congruent to S plus 4j, you want to see, okay, what can we conclude, right?
Yeah, sure.
Let me ask you this to see you remember. I told you in modular arithmetic, if you have this, if you divide both sides by a, then b is congruent to c mod what?
M over C. GCD of M and C.
M and a, because we divided by 8, right?
Oh, yeah. Divide by, yeah.
Okay, so do you agree we can subtract both sides, s from both sides, right?
Yeah.
Then 4i is equal to 4j. Now we can divide both sides by what?
4.
Then I is congruent to j mod what?
7.
Exactly, because GCD of 7 and 4 is 1. And do you agree here it is s plus 4 times 0. It is s plus 4 times
Yeah.
1. So I and j are at this 0 at most 6, right?
Yeah.
So do you agree when they are equal mod 7? They are equal. Because they have different remainders mod 7. So
Yeah.
none of this one is different. These 7 numbers are different, agreed?
Yeah.
So exactly one of them is multiple of 7, right?
Yeah.
So 1/7 of that is 7. Like here that we said 1/5, and here we said 1/3, right?
Yeah.
So 1/7 of the cases are multiple of 7. So you can say 7 choose. We have 7 numbers. 7 choose 4 over 7, right?
Oh, yeah. Then we get it.
We have 7
4
choose 4
factorial.
subsets, right?
Yeah.
And
Yeah.
we know we should divide it by 7 to find number of good subsets, right? Exactly like
Yeah.
previous. Now we want to find quadruple. We should calculate the arrangements, right? Each
Yeah.
subset has how many arrangements, how many permutations?
4 factorial.
Yes. So if we simplify, it is 7. Let's write 7 times 6 times 5 times 4 over 4 factorial. Let's write 4 factorial times 4 over 7, right?
Yeah.
We can cancel 4 factorial, 4 factorial, 7, 7. So it will be 6 times 5 times 4, okay? Now let's check it with our answer here. 5 times 4 factorial, 5 times 4 factorial. It is exactly the same because 4 times 6 is 5 times 4 factorial, right?
Yeah.
Now by the same approach, we want to find dm is what? Exactly, m is odd. M is odd. By the same approach, calculate dm, okay?
Okay. Isn't it m-1 times m-2 times m-3?
m-1 times m-2 times what? m-3?
m-3.
Okay, let's check. Here, if you want to solve it like this, again, do you agree we can prove that they are different? Like this,
Yeah.
1/mth of the number, because m is odd, right? And when you divide by
Oh, yeah.
4, GCD of m and 4 is 1. That's the reason the problem says m is odd. So m choose 4 exactly like this over m times 4 factorial, right?
Yeah.
So it is m minus 1 times m minus 2 times m minus 3, right?
Yeah.
For 5 also it is same, 4 times 3 times 2, right?
Yeah.
So it is this one. Now we can understand that this one is m minus 1 times m minus 2 times m minus 3. So now calculate, and because it says qx, so you can say x minus 1, right? Because here qm equals dm for all of them, for all of odd integers. So for all x odd integers, you can say this. So they should be equal.
Yeah.
Okay, because look, if these two are equal for more than 4 values, then all coefficients are equal. Do you know why?
Wait, why did you write x minus 4?
I'm sorry, explain. Look, these two polynomials are equal for more than 3 values, right? Because it says for all odd integers.
Yeah.
If two polynomials with degree 3 are equal for more than 3, if the degree is 3, if they are equal for more than 3 values, then always they are equal and all coefficients are equal. Do you know why?
No.
Because the reason is this. So suppose, for example, it's a famous problem. At first you should know this. Suppose P(x) is a polynomial and the degree is n, okay?
Okay.
How many roots do we have?
N.
Yes, exactly n roots in complex numbers, right?
Yeah.
P of x is n. But if it is 0 for more than n values, suppose, for example, if P of R1 is 0, P of R2 is 0, and they are different for more than P of Rn is 0, P of Rn plus 1 is 0. All of them are 0, and R1, they are different numbers. R1, R2 to Rn plus 1 are distinct. Then what can we conclude if it has n plus 1 roots? Can you guess?
Wait, what's Ri? Like, what's R1?
There are
Are
roots
they
of this, roots of
Okay.
this. We know it has n roots, right? At
Yeah.
most, exactly n roots in complex numbers with considering repeated roots. But suppose, for example, for n plus 1 different values, p of them are 0. We have n plus 1 different roots. Then what can we conclude?
P of x equals 0 for all
Exactly.
x.
We can calculate p of x 0 for all x. It means that all
Constant
coefficients
function.
are 0. an equals an minus 1 is equal to a1 is equal to 0, right?
Yeah.
Okay. Now, let me tell you a problem. Suppose x cubed plus, for example, 3x squared minus 5x plus a is equal to, for example, bx cubed plus cx squared plus dx plus 2, okay? And they are equal for more than 2 values. For more than 3 values, 3 different values, okay? It means different values of x, okay? It means that, for example, for x1, if you plug in x1, they are equal. If you plug in x2, they are equal. x3, they are equal. And x4, equal. More than 3 different values means at least 4 different values, okay?
Yeah.
Then can you guess we can conclude what?
B is equal to 1, C is
Yeah.
equal to 3, d is equal to -5 and 2 is equal to a.
And how can we conclude this from previous theorem?
We consider the roots. Let's say the roots are like R1, R2, R3, and then we just write x minus R1.
Yeah, you can take all of them to one side, right? So minus of this.
Yeah.
So the degree of this polynomial is at most 3, right?
Yeah.
But more than the degree, we have roots. So all coefficients are 0. So 1 minus b is 0. So b is 1, right?
Yeah.
Now, here we can use same thing. It says these two are equal. We know d of m. Here. When d of m is equal to q of m, so d of x is also equal to q of x for odd integers x at least 5, right?
Yeah.
It is only a variable. It's not important. It's x or m, right?
Yeah.
So we can say these two polynomials are equal for infinitely many values, right?
Yeah.
We know if they are equal for at least 4 different values of x, all coefficients, related coefficients, corresponding coefficients are equal, right?
Yeah.
So here we have infinite. So obviously all corresponding coefficients are equal, right?
Yeah.
So we can easily find all Ci. C3 is what?
1.
C2 is what?
-3.
No.
Plus 2 plus 6 plus 3.
This is what?
11.
No, you have careless mistake. The thing you found is C1, not C2. Right?
Yeah.
Because look, when you say 1 times 2 times x, 83 times 2 times x, you found coefficient of x. So the answer is 11.
Yeah.
Also, we can find C0 is what?
6, -6.
C1, C2 is what?
-6.
Exactly. Okay. Understand completely how we solve this?
Yeah, I did.
Can you see, for example, a column that is special?
1, 1, 1, 1.
Exactly. Do you agree? We always have exactly one column with 4 ones. Always. Agreed?
Yeah.
Because if we permute the columns, we have again that column. If we permute the rows, again, we have exactly one column, right?
Yeah.
So do you agree? In how many ways can we place that column?
4 ways?
Yes, 4 places. And then do you agree? After that, you can ignore that column to see
Yeah.
the rest of the table has how many cases?
Yeah.
Okay.
Yeah.
So then we have this. We can remove that. In each step, you should see, okay, which column is special or which row is special, okay?
Yeah.
Now here, can you tell me what thing is special here?
We did 3 ones or maybe 3
Exactly.
zeros.
Yes, one of them. For example, 3 1 or 0. It's not. For example, this 3. How many cases do we have?
4 cases again.
Yes, then for 3 ones, how many cases?
Also 4 cases.
No. Look, when you place
No, is
this,
it
you
3?
cannot.
3, yeah.
3.
3 cases.
Then you can remove these 2, right?
Yeah.
Want to try the rest on your own?
I can try.
Then you should see in how many tables can you create with these. So try this one.
576.
Exactly, 576. Because here, for this one, you have 2, 2, right?
Yeah.
Sorry. You have 3, 2.
3, and then 2 twos.
Yes, 3, 2. And then when you remove it, 1, 0 is left, which has 2 cases, right?
Yeah.
Yes, you can say 24 squared or 576.
How do I like develop this like intuition? Because I tried it for like so much time, and just I could not solve it. It just demotivated me a lot. Like I just can like you just saw the problem and then just somehow just thought of this. I don't know.
Look, I saw similar problems. Look, some ideas like this. It is famous idea, okay? If you saw, for example, some counting problems, you will see problems like this, okay? That, for example, a spatial row. If we don't have a spatial row, a spatial column, it will be so much harder, okay?
Yeah.
So in these types of problem, I saw exactly in a book. I don't remember 10 years ago, some years ago, exactly a problem like this. And in that one, it says, okay, some number of ones. But look, for example, for previous problem, I tried to solve. Let me save this one because. Okay. For previous problem, look, we checked the small example, right?
Yeah.
And for example, for this one, it's a number of good cases. And this part, that you say 7 to the 3 or 3 to the 7, it is a common mistake. Okay?
Yeah.
Many students in the beginning have this problem that 3 to the 7, 7 to the 3. After solving some problems, you will get good at it. Okay?
Okay.
Okay. And for example, some other problems like this. For example, look, here I told you these things. And then we solved this AMC problem. It was 12/8/2022. And as you can see, exactly 1 year before that, we had exactly similar problem. Okay?
Yeah.
If you saw, for example, 10 past papers, you will see 90% of the ideas are repeated. Okay? That's the reason when I see a problem, because 90% I saw a similar problem before. Okay? If I, for example, I've not seen any problem similar to that before, then I use a small example. When I use a small example, again, 90% of the cases I can find the idea. Okay?
Okay.
Okay.
Yeah.
So, is there any other question that you were stuck on?
One more thing.
Yes.
Like I saw like the AOPS solution.
Yeah.
Like solution 1, I saw it. It just made 0 sense to me. Could you like explain it to me? Like they just said like the number of arrays in some like 1-to-1 correspondence or something. Just made 0 sense.
1-to-1 correspondence. Note that the arrays and some configurations have 1-to-1 correspondence, and the arrays and the some configurations have 1-to-1 correspondence. I found. Okay, furthermore. Okay, I understand. So look, it says if you consider copy. Look, let me tell you, for example, why usually solutions are not good. Because, for example, look, for example, it is a famous problem, okay? For example,
Yeah.
many students, many teachers worked on it before, and maybe, for example, someone found a tricky solution, okay? Maybe also in, for example, 10 minutes, maybe in 1 hour, okay? And they write those tricky solutions, and when you see that, you think, oh, for example, that tricky solution should come to your mind, right?
Yeah, I think like that, but
Yes, but usually it causes that only when you see a problem, you think, okay, it must be some tricky things that you should work on. But usually it's not, because if a problem is tricky, if the solution, for example, the only solution was that, maybe, for example, 1%, or maybe, for example, 0.1% of the students can solve this, and maybe a student can solve this but cannot solve the other problem with that tricky way, okay? But if a problem has a logical solution, many students can solve. So this logical solution, you say, okay, we have 4 ones like this, you can remove. Let me tell you, this first solution says what? It says this summation is what? Summation of the first row.
3.
3. This one is what?
2.
This one is what?
4.
This one is 1, right? Also for the column 2, 4, 3. It says if we arrange these, then the table will be unique. Okay, there is a do you know 1-to-1 correspondence means what?
I know what it means, but like in this case, I could not understand what it means.
Okay, so look, this is, for example, column 1, sum of elements of column 1, column 2, column 3, column 4. R1, R2, R3, R4. It says if we determine R1, R2, R3, R4, C1, C2, C3, C4, sum of each of them, then we can determine the table. So it means that for each R1, R2 to C4, there exists exactly one unique square.
Okay.
So because
it.
R1, R2, R3, R4 are always 1 to 4, C1, C2, C3, C4 are always 1 to 4. So here we have 4 factorial cases, here we have 4 factorial cases. So it will be 4 factorial squared cases. Okay? Here because we have 4.
I get it.
And we should prove it that why it is unique. So, for example, without lots of generality, suppose C1, C2, C3, the sum is 1, 2, 3, 4, this one is 1, 2, 3, 4. We want to prove the table is unique, right?
Yeah.
So can you tell me how can we find out the table is what?
Maybe we fix a good case, and then
You can determine
see,
now. You can determine here. Look, you can determine here all of the cells of this table. So you should tell me they are what? Tell me to write down.
Just 0 and 1.
Yes. For example, you should tell me in first row, for example, in second row, it has to be 1, something like this. Okay, to prove that it's
the sums.
Yes, it is sum. This 1 means sum of the first row is 1. Sum of the second row is 2. Sum of the third row is 3. Okay. We can also permute this. It's not important. Look, for example, suppose I can say 3, 1, 2, 4, or this one, for example, first one is, for example, 4, 2, 3, 1. Okay, now you should tell me in the first row or second row, for example, these cells are what?
Like arbitrarily choose one?
No, look. No. It's not arbitrary. You should determine. You should find. Do you remember? But you solved a SUMaC problem.
Yeah, I do.
Okay, we determine this cell has to be 0. This cell has to be 1. Exactly like that.
So one of the rows has to be 1, like 4 ones.
Let me tell you a hint. For example, this column, all of them should be 1 because the sum is 4. Right?
Yeah.
Okay, what else?
Okay. The fourth row has
Exactly. 3. Then what?
Then the third column must have 2 more ones, but so it's gonna be on the third row and the second row. In this case, the ones.
Look. Let's do something. Do you agree here? We can remove this and write new numbers.
Yeah.
If we remove this here, it will be 1, 2, 0. This one will be 2, 0, 1. Now it's easier to determine here which cells are 1. Determine.
So it's gonna be there's gonna be a 1 on 2 and 2.
Here?
No, not the diagonal one to it.
This one. Look, when you say 2
no,
to
no.
second row, second column. Which row, which column?
I meant the sum of the thing.
On 2, 2, This one?
No. I meant the red ones.
New sum, this one?
Yeah, new. Yeah. There's
This
gonna be
one is 1. How can we? Maybe it's 0. Why it has to be 1?
Because if it's a 0, then the other 2 has to be 1.
Yes,
and then that violates the second. There's this it cannot be 1.
Yeah, because it is 0, right?
0.
So easier than that because it is 0. Do you agree? All of them should be 0, and this one is 0. All of them.
Yeah.
What else?
We can put the ones.
Yes, because this one is 3, we can place 2 ones here, right? We have to place. Because of these 3, we have to place 1. And this cell will be what?
There's going to be 0.
Yes, so the table is determined. So if we consider, we have always a unit circle, right?
Yeah.
Unit table. So we proved one-to-one correspondence exactly like this we can prove, right?
Yeah, I get it.
Okay, that's another proof. It was 17. Okay. Do you have any other question that you were stuck on?
Yeah. Yeah, just a second.
Okay.
I tried to find Q first. I got confused. So I
This
tried
one,
like
Q is this one, right?
yeah, I tried Q first. I was confused on the probability of one bin getting
So
4
when
balls
a
each.
problem is hard, we can try what?
Small examples.
Exactly. So here we can use a small example on what?
The probability of one bin getting 4 balls.
Yes, one. No, for example, look, we have balls and beans. We can use a small example on balls or beans, okay?
Yeah.
So
Okay.
if we instead of, for example, n is 5 here, suppose n is 2, okay? And for example, we want to find probability that each of them is. So what's the probability of this? If this one is harder, we can also make the numbers smaller. C, can you calculate this probability?
Is it 1/4?
Why?
I said like for the first bin, the probability of getting 10 balls is gonna be 1/2 times 1/2,
Hmm,
and then
because we should
is it
determine. Yes.
gonna be 1/16 then? Because we're gonna multiply the
Well,
like
let's
I'm
check
like
something.
confused on
Suppose
this.
n is 2, but instead of 4, 10 be 20 balls, we have 4 balls. Let's consider 2 balls. What's the probability of this? 1 ball here, 1 ball here.
So do we consider like the
We have 2
probability
balls.
of one bin?
Suppose for some number of balls is equal to, here is equal to 20, but here it is equal to 2. Okay? So what's the probability of this? 1, 1.
Um, is it now? Is it 1/4?
No, it's not 1. Try again. You can check all of the cases and you can calculate. That's the reason I told you this is small case.
I get 1/3.
No, it is not 1/3. Want hint or want to try again?
Yeah, I like it.
Okay. So suppose we have 2 balls and there are, for example, a and for example x and y. Okay.
Yeah.
So the first case is x, y, right? 2 here.
Yeah.
The second case is we want to write down all of the cases. That's the reason I told this one. X, y, and one more case. What's the next one?
X- Y
One.
and X.
Y, x. Probability of each of them is 1/4 because it says independently and at random. Okay, so the probability to go, for example, to this one, both of them is 1/2 for each ball, right? So each of them is 1/4,
Yeah.
1/4, 1/4, 1/4. So the answer is what for this case?
1.
The probability is 1.
No, the 1/4 to the 4th.
1. What over what?
1 over. Wait, what's the probability? Of
The
each
probability
getting
that in the first one we have 1 ball, in the second one also we have 1 ball.
1/2.
Yes, 2/4 because these two cases, right?
Yeah.
Is 1. What's the probability? Suppose n is 2, p is 2. The probability this one is 2, this one is 0 is what?
1/4.
1/4. Now the probability, suppose here we have again 2 beans and 3 balls. The probability of 2, 1 is what?
Is it one? Is it? Wait. I get 1/4. Not sure.
Okay, can you tell me first total number of cases is what?
Six. Is it 4 choose 1? So 4 cases.
How many cases in total?
4.
No, look, we have 3 balls. Each ball has 2 cases to go to this one or this. So how many cases do we have?
Oh, 9. No, 3 3. So 27.
Let me ask you this. For the first ball, ball number 1, how many cases do we have?
2.
2. For the second ball, how many cases do we have?
Oh, 2.
For the third ball, how many cases do we have?
2 cases.
So it will be what?
8.
8. Like previous one was 2 squared 4, right? Okay. Now we want to calculate number of good cases. So we should have 2 balls here, 1 ball here, right?
Yeah.
So we should select 2 balls for this one. In how many ways can we select 2 balls here for this one? For the first bean.
3 choose 2.
Exactly. 3 choose 2. And last one is 1 choose 1, right? So it's 3.
Yeah.
It's 3/8. Understand?
Okay. Yeah.
For the previous one, for example, if you wanted to solve 1, 1, you say, okay, the denominator is 2 choose 2. You say 2 choose 1 times 1 choose 1 is 2/4, which is 1/2, right?
Yeah.
Okay, now let me ask you another one. Suppose, for example, we have 3 beams. And now we want to find the probability that this one is 2, this one is 3, this one is, for example, 2 again. In this case, total number of cases. So how many balls are there? 5, 7. How many beans are there? 3. Total number of cases is what in this case?
7 cubed.
Look, when you say 7 cubed, it means that this one has 7 cases, but in general. But this one doesn't have 7 cases. It can have ball number 1 or ball number 2 or ball 1 and ball 2. There are a lot of cases, and this one has effect on the next beam, right? You select all of them here. So with this way, you cannot solve. See how we calculated in previous case? Do the same.
Is it 3 to the 7 then? Wait, no. Yeah.
Yes, 3 to the 7. Total number of cases, 3 to the 7. And number of good cases will be what?
Mm. 7 choose 2 times 7 choose 3 times
No,
7 choose
7
2.
choose 2 times what? Choose what?
Oh, 5 choose 3.
Yes, times what?
And then 3 choose 2.
2 choose 2. Look, 5 choose 3 when you select 3 of them.
Yeah,
2.
yeah.
So you should divide this by this. Finished, right?
Yeah.
Okay, now that you've learned this, do you agree you can calculate P and Q?
I can try.
Okay, sure, try.
I get 4/5 for some reason.
4/5?
Yeah, I think I made a mistake somewhere.
Okay, can you tell me for this one, total number of cases is what?
5 to D20.
It's 20?
5 to D20.
Exactly. Number of good cases will be what?
20 choose 3 times 17 choose 5 times 12 times 12 choose 4,
Yes.
and 8 choose 4, and then 4 choose 4.
Yes. For not having careless mistake, in the end we should reach 4 choose 4. Okay.
Yeah. Okay.
For this one, total number of cases is what?
5 to the 20 as well.
And this one?
And then 20 choose 4, 16 choose 4, 12 choose 4, 8 choose 4, 4 choose 4. Times
Yes.
of them. Like,
It says P is this. 12, 8 and 4, right?
yeah.
And the problem wants P over Q. So do you agree we can only divide number of good cases?
Yeah.
Okay. So let's divide it. Can you tell me 20 choose 3 is what?
20 times 19 times 18 over 6.
Yes, over 3 times 2 or 6. Next one is what?
17 to 13, and then over 120.
Over what?
5 factorial.
Yes.
120.
What's that? Next one.
Can we not cancel them?
Yes, let's cancel them in the end, okay?
Okay. So 12 to 9.
12,
So
11,
12,
10,
11,
9.
10, and
Yes,
9.
over 430, right?
Yeah.
And last one is what?
1.
No. It's second last one.
Yeah.
5 over
Okay.
430, right?
Yeah. Over 432.
Exactly. So then when we calculate these, yeah, in the numerator here, again, we have 220 to 5.
Yeah.
So we can cancel all these terms together, right?
Yeah.
Over 4 factorial, let's write 4 factorial, 4 factorial, 4 factorial, right?
Yeah.
Again, we can cancel a lot of terms here, right?
Yeah.
That's the reason I didn't cancel here, okay? Because they are similar. You can cancel like this. This one, 4 factorial, then 3 factorial, 4 is left. So the answer is what? You
4 over
reach
5
4
is
over
what I get.
5, right?
Yeah.
Okay, let's see the cases. P over Q. Some bean ends up with 3 balls. It didn't say only one, this bean 3 balls 5, okay? So we can multiply this P because which being 3 balls? Because it says sum, not only 3 balls. If we consider this case and this case, that's correct. But because we have this, we should multiply this by what? Because this 3 5 can be any. For Q, it is correct because all of them are 4. Yeah. Arrangement, you don't know, right? For this one, how many cases are there?
Is it 5? So for some bin to get 3, is it going to be 5 choose 1?
Yes, and then for 5, 4 choose 1, right? Then the others will be unique. So 20, we should multiply it by 20, right?
Yeah.
Then it will be what? Because this one we should.
16. Yeah.
Exactly. 16. We were lucky that it was not in the choice. Okay, that's the reason we should read the problem context. Okay.
Why? I had a question. So for the P case, if we want to get like the bin with 3 balls, it's gonna be 5 choose 1, right? If we want the bin with 5 balls, why is it 4 choose 1?
Because one of them, look for P. You want to
One
select
affects
which
another?
you want to select which bin has 3 balls, right? So you say 5 choose 1. For example, this one. Now 1 win should be 5, right?
Yeah.
So you say 4 choose 1. For example, this one is 5. Then the rest is unique, right?
Yeah.
Okay. What's your next question? This is AMC 12-2023. It says U is this, V is this, then we define this binary operation. U and V will be AC. You multiply the real numbers and also the complex numbers. Then it says suppose Z is a complex numbers and Z, for example, Z circle Z is Z squared plus 4. The absolute value or length of Z is what? Calculate this first on your own. It's not hard.
Alright. Okay, I got 5 root 2.
Got what? 5
root 2.
5 root 2. Okay, so let's check this one with the problem. Let's check it. A plus bi is a squared plus b squared I is equal to a squared minus b squared plus 2abi plus 40. So a squared is equal to a squared minus b squared plus 40. B squared is equal to 2ab. From here, is root 40 is plus minus root 40. And if you cancel b, is 2a, so a is b over 2. And length
So root 40. So you get root 40. So you get just 40 plus 10.
Yes, b squared is 40, a squared is 10. So some of them is root 50, okay? So, because we didn't have time, I told you this easy problem of complex numbers. But next session we will solve on harder problems of complex, okay? Okay, any questions?
Next session I'll send
Yes.
you some more questions.
Yes, if you send me problems that you can solve like this, we can solve them step by step together, and it will be so much great. Good job for today. Let's check some examples. For example, if we have 1, 1, 1, it's better to reroll how many dice?
Okay, if you have 1, 1, 1, then it's better to reroll 1 dice.
So let's check. If you reroll 1 dice, what's the probability to reach 7?
It's 1 in 6.
1 over 6,
then
because we should
get
only
5.
reach 5, yes. If we reroll 2 dice, then the probability to reach 7 is what?
So 1, 5, 1, 5, 2, 4, 3, 3, 3, 3, 4, 2, 5, 1. So 5 in 36. So not
So
enough.
which one is better, 2 or
So
1?
dice.
1 dice is better, okay? So like this, we should check some examples to understand how it works. So if we have A, B, C, okay, if we reroll 3 dice, what's the probability to reach 7?
If you reroll 3 dice, A plus B plus C is 7.
Yes, what's the probability? Look, we have A, B, C, and then we want to reroll 3 dice. I want to check. If we reroll 3 dice, what's the probability to reach 7, okay? If we reroll all of them, what's the probability to reach 7?
So 1, 1, 5, 1, 2, 4, 1, 3, 3, 1, 4, 2, 1, 5, 1. We try to count all the cases and divide it by 2.
Yes, you should check all of them. And divide by 200. Calculate all of them. Okay, so you should calculate the numerator of this one, A's.
Let me calculate.
Okay, sure.
Okay, I got like 15.
You got 15. Okay, let's check. When some of them is 7, maximum one can be 5. 5, 1, 1, 3 cases here. Then you can say if you have 4, the sum is 3. So 1, 2, 6 cases. If you have 3, if maximum is 3, so 3 plus what is 7? 3 plus 4. So it can be 3, 1 and 3, 2, 2. So this one is 3, this one is 3. Maximum 2 is not possible. So 3, 3, 3, 9, 15. Good job. So the probability is 50. Now let's consider something. So if we reroll 2 dice, okay. So now let's consider first one is 1. Next terms are BC. This one is 1. If one of them is 2 and you want to reroll other 2 dice, if it is 3 BC is what? If you have 4 BC and you want to reroll 5 BC and 6 BC. So the probability of we should calculate probability of each of them. So if you have 1 and we want to reroll other 2 dice, it will be what the probability?
Wait, so in what case do you reroll BC?
No, we don't want to see in what case. We want to first calculate and then compare. Suppose we have 1 and then we want to reroll other 2 dice. The probability to reach some 7 is what? 1 hint, or want to keep trying?
Kind of a hint.
Okay, sure. So look, this one is 1. If you reroll these 2, so their sum should be 6. 6 plus 1 is 7. So 6 is 1, 5 to 5, 1 is 5 over 36, right? What about next one?
Okay, 2 is 2, 4? No. 2, 3. No, 1, 4, 2, 3.
So it's what?
So 4 over 36.
Exactly, 4 over 36. What about next one?
I think this is just 1, 2, 2, 1, and 3, 3. So 3 over 36.
Yeah, 3 over 36.
3 over
Next one.
36, 2 over 36, 1 over 36, and then 0.
0, because when one of them is 6, 1 is also 8. It will be great. So now if you want to reroll one of them, then if A plus B is less than 7, then the probability to reach 7 is what?
If you reroll 1 die, then it's just 1 and 6. 1 over
Yes,
6.
1 over 6. But it is for the case that sum of 2 of them be less than 7. For example, look, if you have 6, 5, 5. If you reroll 1 dice, you cannot reach 7, right?
Yeah.
Sum of 2 of them. Okay. And do you agree 1 over 6 is greater than all these numbers?
Yeah.
So if we have 2 numbers that sum of them less than 7, we reroll 1 die, not 2 dice or 3 dice, right?
Yeah.
And we reroll 0 die if sum of them is 7. 0 die if A plus B plus C is 7. Okay. Now it says, what's the probability that we reroll exactly 2 of the dice? Okay. So here, let's consider some cases. So each of them will roll how many dice? Suppose we have 1, 2, 5. Then we reroll how many dice?
How many dice? You have to reroll 1 dice.
1. If we have 2, 5, 6, then we reroll how many dice?
Okay, 2, 5, 6. You reroll 2 dice.
Okay, so 2 dice. And which 2 dice? 2, 5 or 2, 6 or 5, 6? So here, look, let's check with 3 dice. 15 over 200. Which one of these things are better than 15 over 216? Which are greater, which are less than this?
Like 3, 5, 6, you have to reroll 3 dice. I mean 2 dice.
No, I said I want to, yes, if you have to reroll 2 dice, I said I want to compare these numbers with 3 dice. Which of these fractions are greater than this? Which are smaller than this?
I'm not sure.
You don't know how to compare these two fractions? For example, this one is greater or this one? Here, which one is greater? Check this one.
If you add them all up, you get like.
No, you cannot add all of them. Look, you can compare one by one because, for example, you can reroll all. You cannot reroll simultaneously. I want to see if you have one and reroll other two. Is it better or reroll 3 dice is better? Which one is greater? Each of these fractions.
Well, you have to multiply 3 over 6 to get the 15 over 16.
Okay, so this fraction is greater or this fraction?
So you multiply 1/2 by 1/2 by everything.
Okay, so if you do that, which one is greater? This fraction 5 over 36 or 15 over 260?
Wait, sorry, say that again. It was kind of.
I said which fraction is greater, 5 over 36 or 15 over 216?
5 over 36.
Yes, because we can multiply both sides by 216. It will be 30, it will be 15. 30 is greater, this one is greater. What about next fraction? This is greater or this one is greater?
4 over 16.
What about next one?
3 over 36.
Next one.
15 over 216.
Next one.
18 over
Obviously this
216.
one. Because if you multiply by 6, 24, 15, 18 greater than 15, 12 less than 15, 6 less than 15. Okay. So, if we have 1 or 2 or 3, if there exists 1 or 2 or 3, we prefer to reroll 2 dice, okay? Except 1 die. If not, we reroll. So, let's write. If sum is 7, we don't reroll, right? Okay, then we prefer to reroll 1 die. So if sum is not 7 and sum of 2 of them is less than 7, then we reroll 1 die, right? So here, look, we have these options. Sum 7, we reroll 0 dice. Answer is 0. If otherwise, if sum is not 7, now again we have 2 cases. If there exists 2 of them that the sum is less than 7, then answer is 1. We reroll 1. Otherwise, means sum of each 2 of them is greater than 7. Then we have 2 cases. If there exists 1 or 2 or 3, we reroll 2 dice. If there exists 1 or 2 or 3, answer is 2. Otherwise, answer is 3. So it is the things that we found. Okay? So by these things, let's check some of them. For example, suppose that we have 3, 5, 6. So answer is what in this case? How many? We reroll how many dice?
2.
2. If we have 4, 5, 5, then we reroll how many dice?
3.
If we have 3, 3, 6, then we reroll how many dice?
3.
No, 1. Because look, sum of these two is less than 7, so you reroll this one. And 1 is always better. Okay, so here, if sum is not 7, and there exist 2 of them that the sum is less than 7, so you reroll 1 dice. Okay.
Yeah.
Now 3, 4, 6. This one is what the answer.
2.
2. You reroll these 2. If you have 4, 5, 6, you reroll how many dice?
3.
3. And if you have 1, 2, 4, you reroll how many dice?
1. No, 0.
0.
You already
Because
got
the sum is 7. Yes. Now, if someone say for some 3 numbers, now you know you should reroll how many dice. It says what's the probability that you reroll exactly 2 dice. Okay, so this one 0. So the denominator is what? The probability that you reroll 2 dice. The denominator is what?
2 over 6.
The denominator.
The denominator is I don't know.
The denominator is 6.
6 cubed.
It's 6 cubed because all cases, right? At first we roll 3 dice, and total number of cases is 6 cubed, right? Okay, now you should see, okay, in how many of the cases we reroll 2 dice? Calculate the numerator by considering these things.
So you only roll 2 if it's like greater than 7. Okay, so there's like 6, right?
You should use casework to calculate. Look, because it should be 2, sum of each 2 of them. So we should calculate when we reroll 2 dice. Let's consider we have what conditions? Sum is not 7, because if sum is 7, we reroll 1 dice. Sum of each 2 is at least 7. Sum of each 2 is greater than or equal to 7, and we should have 1 or 2 or 3. We should have these conditions to reroll 2 dice. Now, we should calculate all of these cases. So, let me check one of them with you. Suppose we have, and we cannot have both 1 and 2, because then their sum is less than 7. It says sum of each 2 at least 7. So, let me calculate for you case 1. If you have 1, because sum of each 2 is at least 7, so 6, 6, we should have only 1, 6, 6, right?
Yeah.
So how many cases do we have here?
2. 3.
3. If we have 2, now calculate for this case. When we have 2, how many cases are there?
2, 5, 6, and 2, 6, 6.
Exactly. 2, 5, 6, 2, 6, 6, and one more case. 2 what?
2, 5, 5.
2, 5, 5. So here, how many cases?
6, 3, 3.
It's 6, 3, 3. Now let's consider if we have 3. What are the cases?
3, 3, no, 3, 4, 3, 4, 4, 3, 4, 5, 3, 4, 6.
Yes, what else?
3, 5, 5, 3, 5, 6.
And
3, 6.
Exactly. So this one is what?
3, 6, 6, 3, 6, 3.
Yes, so how many cases? This one 3, okay, 6, 6, 3, 6, 3. So the numerator is what then?
Now 4, but 4 can't work. So this is, if we add all these up, we get 1, 2, 3, 4, 5, 6. So 18 plus 24.
Which is what?
You get 42.
42. So 42 over 6 cubed. If we simplify it, would be what? So 42 over 6 cubed, if you simplify this, what over what?
7 over 36.
Exactly. 7 over 36. Which choice here?
A.
Okay. Understand completely how we solve this?
Yeah.
Okay. So here let's use some small examples. Can you tell me the first number after 100 that is good is what?
110. Oh, 101. 101.
101. Because you can permute, right? So 100 is bad. 101 is good. 102 and on. Do you know we have a rule for finding remainder when divided by 11? For example, let me ask you a number. 25321. The remainder, this one mod 11 is what? It has a rule. Do you know it is what?
It's 2 plus, no, it's 2 minus 5 plus 3 minus 2 plus 1.
From here, you should concept plus, minus, plus, minus, plus. So 1 plus 3, 4. 4 plus 2, 6. 6 minus 7, negative 1, which is 10, right?
So not divisible.
So it's 6 minus 7. It's negative 1, which is 10. Agreed? So if it is multiple of 11, sum of these digits should be equal to sum of these digits, okay? For example, 101 is good because you can say, okay, 110 plus minus plus, it will be 0. So 102 is bad, 103 is bad, right? Because 3 minus 1, 3, or 1 minus 3, they are bad. 110 is good. 111 is good or not?
No.
No. Next number that is good is what?
112.
Yes. Why 112 is good? Because look, 2 is sum of 1 plus 1. So you can say 2, 1, 1. It is plus, minus, plus. So 112 is good, right? 113, it's not good because 3, if you add also these two numbers, we cannot reach. 114 is bad. Again, all the way. So next number that is good is what?
I think 121.
Yes. So can you tell me the numbers that are good have what form?
I'm not sure.
Look, if we have ABC plus, plus, minus, B, or A plus C minus B should become equal to 0 mod 11, right?
Yeah.
So A plus C minus B can be what numbers?
0, 11, 22.
Can it be 22? Can you tell me one example? Because they are at most 9, right? 18. It cannot be greater than 18. Also, this one 0, 18. So it can be 11 or 0, one more case. Or what?
Or I think that's it.
Negative 11.
Oh, yeah.
Okay, so let's consider these 3 cases. And look, you can permute these numbers. So let's first focus on this 0. A plus C is equal to B. For example, like 1, 2, 121, or 1, 112. Sum of two of them is equal to the third one. How many numbers do we have here?
What do you mean?
Okay, so look, it means sum of two digits is equal to third one, like 121, 112, 211, right? These types of numbers. I want to see how many numbers do we have that one digit is equal to the sum of the two others. So try to find how many numbers do we have like this.
So we could do 1 plus 1 minus 2, 2 plus 2 minus 4, 3 plus 3 minus 6, 4 plus 4 minus 8.
Yes, so look, you can say, for example, B can be 1, B cannot be 0, then 0, 0, 0 is one digit number. And B can be 1, then this one is 1, 0, right? And then we will calculate all permutations, okay? If it is 2, it is 2, 0 or 2, 1, or 1, 1, right? Or 1, 1, 2. If it is 3, then we have what cases? 3, 0 and 2, 1, right? If you have 4, 4, 0 and 3, 1, 2, 2, 4. If you have 5, then 5, 0, 4, 1, 3, 2, and all of them 5. And if you have 6, it will be 6, 0, 5, 1, 4, 2, 3, 3, right? If you have 7, 7, 0, 6, 1, 5, 2, you should calculate all of them, 4, 3. And if you have 8, then you have 8, 0, 7, 1, right? 6, 2, 5, 3, 4, 4. And last one is 9. If it is 9, then you can say 9, 0, 8, 1, 7, 2, 6, 3, 5, 4, right? Okay.
Yeah.
So here, how many good permutations do we have in the first one?
There's 3. No, there's 2.
2, 110 and 101. 2 cases. What about this one?
2.
2 again. What about this case?
And 6. Uh, 2, 6, 2, 6, 3.
2, this one is 3. Because look, 3 factorial over 2 factorial. Permutation with repetition. You have 2 ones, okay? So it's not this. Next one is what?
Next one would be
This one is what?
3. 2, sorry.
2, yes. This one?
6,
6. This one?
2,
This one?
6,
Exactly. This one?
3.
3. This one?
2, 6, 2,
6 again.
6, sorry. 2, 6, 6, 3, 2, 6, 6, 6, 2, 6, 6.
This one?
6, 3, 2, 6, 6, 6, 6.
2, 6, 6, 6, 6. Okay. Now, if you add, okay, so let's first consider next is on. Negative 11 is not possible because it is 0. If it is 0, 0, this one also 9 is negative 9. So we should only check 11, okay? So a plus c minus b is 11. Case 2. A plus c minus b is 11. So a plus c is b plus 11. So if b is 1, this one is 12. For reaching 12, you can say 9, 3, 8, 4, 7, 5, and 6, 6, 1. If it is 2, then it is 13. So 9, 4, 8, 5, 7, 6, 13. And if you check 3, it's 14. 9, 5, 8, 6, 7, 7, 3, 3. If it is 4, it's 15. It's 9, 6, 8, 7. And if this one is 5, then it's 16. It's 9, 7, and 8, 8. And if this one is 6, it's 17. And 9, 8. If this one is 7, it's 18, 9, 9. Now we should calculate this. And in this case, sum of two of them cannot be the third one. 3 plus 1 is not 4, 5, 6, 7. 4 plus 2, 6. 2 plus 5, 7, 8. 3 plus 5, 8. 3 plus 6, 9. 3 plus 7, 4 plus 6, 10. 11, 12. These are larger. Okay. So for the first one, how many cases are there?
6, 6, 6.
6. Let's write 6. This one, next
3,
one. 3,
3.
next one.
6, 6, 6, 6, 6, 3, 6, 6, 6, 3, 6, 3.
Okay, so let's add these numbers. How many 3's are there? 1, 2, 3, 4. So 4 times 3. Now, how many 6?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 sixes.
It's 12 times 6. 12 times 6 is what? 72.
72 plus 12, so 84.
Exactly. Now here, let's see how many 2's are there, how many 3's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 2. How many 3's are there? 1, 2, 3, 4. 4 times 3. How many 6 do we have? 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 6. So if you don't have any careless mistake here, 2, 18. 18 plus 20, 30. 30 plus 96, 126, right? 126 plus 84 is what?
84, 210.
Okay, so let's see here. 84. This one, 210. So let's see. Have we considered all cases? We have near 210. So let's check here. In these cases, have we ignored any of the numbers? This one, 11. Here we consider 126 and these numbers. So let me check now. we should consider from 100 to 999. So if one number is sum of the two other digits, or if sum of the two is equal to 11 plus the next. So consider 11. Let me see how I consider all cases. Here 0, 0, 0. We did not consider 0. B can be 0. So when B is 0, it's 11. So it's 9, 2. Obvious.
9283 774
Yes.
65.
Yes. So 0, 0, 0. So what?
So
How many cases do we have here?
2,
No, it's not 2.
4, 4, 4, 4.
No, it's not 2.
It's 4.
It's 4, yes. 0, 2 cases, it's 4. For all of them, 4, right?
4.
So how many 4s? 16 4s. 16, so
No, 4.
4 times 4, 16. Yes, so this one is this plus 84 plus 16. So here, you said 210 plus 16, it's 226, right? Which choice? Which choice is correct then?
So adding all of them up, let me see real quick. Sorry.
Okay, so we added all of them here. So the last answer is which choice?
226.
Which is choice?
A.
Exactly. Okay, now let's check next problem. Okay, if we change them to base 10, it would be what? At first, because we in the digits we have 1, 2, 0. B is at least what?
Wait, what did you say?
I said in the digits we have 1, 2, 0. So we can conclude that B is at least what?
3.
Exactly, because the digits should be less than B. And now if you write them in base 10, it would be what?
2. B. 3. Plus B. Wait, plus 1.
So it is 2, 2, 2, 2, 0, 2, 1 in base B and 2, 2, 1 in base B. So the first one, this one is 1. Next one is 2b plus 0b squared plus 2b cubed, right? Minus what?
Minus 1 minus 2b minus b squared.
2b plus 2b squared, right?
Oh.
So we can cancel 1 and 2b. So it would be 2b cubed minus 2b squared, right?
Yeah.
Want more hint or that's enough?
That's enough, probably.
Okay, try.
Is it 8?
You said 8?
No, 8 as an E.
No,
not A, like E.
You said 8, choice E?
8. Yeah.
Okay, so let's check. 2b squared times b minus 1. Because it is not 0 mod 3, so b should be what mod 3?
1 or 2.
No, if it is 1, this one multiple of 3. If it is 0, this one is multiple of 3. So b should be what mod 3?
I thought you meant like okay.
B should be multiple of 3. Look, b should be what mod 3? Can you hear me?
1.
1. So if b is 1, then b minus 1 is multiple of 3 and it's bad, right?
Yeah.
So b should be what? Mod 3.
Should be 2 mod 3.
Exactly. And the only choice that is 2 mod 3 is 8. Also, you can check choices one by one, right? And you see only 8 is not multiple, right? Good job, you reached 8. What's your next question? So, if, for example, we consider first element, second element, third element, fourth element, fifth element. If first one, if we have less than that, here we have less or greater?
Greater.
Greater, because if it is less than next one, these are increasing, right? So it would be like this. Or this one, this one, this one, this one, right? Agreed?
Yeah.
Okay, now we should use casework for solving this. Want more hint or that's enough?
That's enough.
Enough or more hint, you said?
I'm gonna try.
Okay, sure, try. So it doesn't have any special formula. You should use casework, okay? And solve it. Try first on your own. Want hint or wanna keep trying?
Keep trying.
Okay, sure.
Is it 32?
It's 32. Okay, let's check. Look, for example, I told you when you want to use casework, priority is what?
Most
Priority.
limited case.
Yes, the most restricted cases. So here, for example, this one is more restricted, or this, right? For example, these two maximums, okay? So yeah, with this one should be greater than two of them, so it cannot be one or two. It is at least three, right? And for A and B, do you agree it is not, for example, 3, 4, and 4, 3 would be same, right? Do you agree? Because it is from left to right and right to left, it is symmetry. So if we check 3 and 4, we don't need to check 4, 3 again, right? Multiplied by 2.
Yeah.
So 2 times number of cases that A is less than B. So we should check 3, 4 for A and B. We should check 3, 5, and 4 and 5. So for this case, at least 5 should be in one of them, because if 5 is here or here or here, we have mistake, right? So 3, 4 is not possible. Only 3, 5, and 4, 5, right? Agreed?
Yeah.
Okay, so when we have 3 here, like this one, so we can conclude in this case 4 shouldn't be here, 4 shouldn't be here, so 4 should be here, right? And then 1 and 2, 2 cases, so this one 2 cases. Here 1, 2, 3 can be in any of these 3 places, 3 factorial, 6. 6 plus 2, 8, 2 times 8, 16, right? Okay, so for this one, do you agree it would be 16 again? Because look, they are smaller than this. So instead of, for example, 4, 5, we can say all these things with 1, 2, right? From increasing and decreasing, it would be symmetry. So similarly, it would be 16. So 16 plus 16, 30. Good job. So here, look, we have 1, 2, 3, 4, and so on. It says from some part means, for example, 2k plus 1, 2k plus 2, 2k plus 3, 2k plus 4, and so on. 2, for example, 2m plus 1, 2m plus 2, and 4950, right? For example, it means that we remove these pages, okay? So let's do something to make it better. So 1, 2, 3, 4. So this one and Let's make them a bit smaller. So we have dot, dot, dot. 2k minus 1 and 2k. We have these pages and 2m plus 3 and 2m plus 4, right? Okay. So the average of this part and this part, why I wrote this one is have this. So this one is okay. The average is, so how many pages do we have here? 2k plus 1, 2k plus 3 to 2m plus 1. You can say 2m plus 1 minus 2k plus 1 over 2 plus 1. So it will be m minus k plus 1, right? We remove this number of pages.
But why doesn't it start from 2m plus 2?
What's your question? Can you say it again?
But why doesn't it start from 2m plus 2?
I said, look, do you agree that each page starts with an odd number and ends in an even number?
Yeah.
Page 1, 1, 2. It's sheet 1, page 1, page 2. And like this. So it says some consecutive numbers here. Okay. So the problem is exactly what? I said, okay, k is a general number. From this part to m, we remove them. K and m are an arbitrary integers from 1 to, from 0 to the last. Okay.
Yeah.
Now, but one thing, it says how many sheets were borrowed. Because it says these, so let's do something. Instead of m, I want that this one be variable. It's better that the thing that the problem wants be a single variable. But here, you should find m minus k plus 1, right? So I decide to do what? If I want to remove, I decide to remove 2k plus 1, 2k plus 3, for example, 2k plus, let's consider m as, let's remove this. So 2k plus 2m plus 1, 2k plus 2m plus 2. Suppose these pages, these sheets are the sheets that we remove, okay? Now it will be what? How many pages do we have then? 2m and m. Can you tell me how many pages do we have here? It is our first page, second page that we remove, and it is which page?
Wait, how many pages is sheet?
In terms of m and k, you can say.
Wait, but I don't have a k. I just have m plus 1.
How many pages do we have here? First page, second page, and this page is what? Which page?
I said we have like m
Oh, you said it is m plus 1, right?
Yeah.
Exactly, because it is 2 times m, it is 2 times 0. So, because I want to reach m, so I say 2m minus 1 and 2m. So if I write 2m minus 1, it would be mth page, right?
Oh,
right?
yeah.
Then we should find m, right? And the problem wants m. I tried to define variables such that to have one variable m. So in previous case, we should find m minus k, and then when we have m minus k, maybe we cannot find m and k separately. Okay? And then the problem would be hard to focus on finding m minus k, difference of the. But here, we know that we have to find m. Okay, so it says the average is 19. The average is what? sum over. Can you tell me number of pages that are left? Number of pages that are left, not sheets. Number of pages that are left is what? We said we remove m sheets. So how many pages do we remove?
Plus 2m plus 2.
We have m sheets.
Wait, no, 2m.
2m, good job, 2m pages. So when we want to calculate average of other pages, so the denominator is what? How many pages are left?
50 minus 2m.
Good job, 50 minus 12. So look, I've not used any idea or any formula so far. I just want to write it in mathematics, right? Okay, so some of the other terms, one way to use, we can use complement rule. One way is to use this one plus this one. You can use both of them. I prefer to use complement rule. I said 25 times 51. It is 1 to 50, right? Minus this summation. This summation, there are consecutive numbers. So can you tell me the summation? We should write what? First one plus last one, right? First one plus last one times number of them. Means last one minus first one plus 1. Because the common difference is 1, you don't need to divide by anything. And at the end, we divide it by what?
2.
Exactly. We divide it by 2. And it is equal to what? From the assumption of the problem, it should be equal to what?
19.
19. Let me just check. First one plus last. First one plus 1. Okay. Now we should cross multiply, simplify, and try to find m. Want to try the rest on your own?
Yeah.
Okay, sure, try.
Is it 13?
The answer is 13. Okay, let's check.
Yeah.
Okay, 25 times 51. We can multiply this one by 2, this one by 2. Let me think. No. We don't need to divide. It is minus 2m plus 4k plus 1. 2k, 2k will cancel each other out. Which is equal to 19 times this, right? Then we try to factorize. If we take this one to this side, 19 times 50 is greater, or this one, if we multiply by 2, this one is greater. Okay, so 25 times 51, 90 times 50 is equal to m times 2m plus 4k plus 1 plus 38 minus 38. So here 25 times 51 minus 38 is equal to m times 2m plus 4k minus 37, right? 51 minus 38 is what?
30.
Is 30. So 25 times 13 is equal to m times 2m plus 4k minus 37. So we should consider cases, right? So let's see. Let's consider this part that we said we have m pages, 2m pages, and what happened for this part. Let's see. And let's consider this side. Okay. Because we have 2m pages, so m can be 1 or 5, right? Or 13 or 25. It cannot be greater than 25, right?
Yeah.
But 25 also is not possible because the rest over 0. The average is undefined, right? Because look, if m is 25, then we have 50 pages. It says remove them. The average of the rest is something, 19. But if all pages are here, the rest is 0. So we have 0 pages. So you should divide by 0 for the average, and it's undefined, right? Okay, so we need to only calculate these 3 cases. If it is 1, it is 25 times 13. If it is 5, it is 5 times 13. If it is 13, it is 25. Okay, for the first case, okay, it is 25. It is 65. This one is 5 times 65. Is 5 times 5, 25, 2, 5 times 6, 30, plus 2, 3, 2. Okay, so we want to find k for each of them for this one. 2 times m is 2. 2 minus 37 is minus 35. So 4k is 35 plus this. 35 plus this is 360. So k is 90, but it's not possible, right? Because 2k plus 1 then would be 190 something, right? In this case, 2 times 5 is 10. 10 minus 37 is minus 27. Then if you take it to right hand side, 27. 27 plus 65, 85, 92. So 4k is 92. And k would be what is 223. 2 times 23, okay, so we should check. Last one, 2k plus 2m. In this case, 2k plus 2m is 46 plus 2 times m, 10 is 56. But we don't have this page, right? Okay, and last part, m is 13. So 4k is 2 times 13 is 26. 26 minus 37 is minus 11. Plus 11 plus 25, 36, okay, is 9, right? And if you want to find the pages, 2k plus 1 is what? 18 plus 1, 19, 20, and 21, 22 is first page, second page, and 13th page. 2k plus 2m, which is m is 13. 13 plus 9, 22. 22 times 2, 44, 43, and 44, right? And we don't have any contradiction. Also, we can check. Because it is our only answer, it will be correct. So it says what? M is what? M is 13. Good job. And if you want to check to make sure, we should prove that the average of 1 to 18 and then 46, 45 to 50 is 19. So how many numbers do we have here? 18 numbers. And here 50 minus 44 is 6, right? So over 24. And 1 to 18 is what? Is 18 times 19 over 2. Plus 45 plus 50, 95 times. How many numbers are there? 6. Over 2 over 24. We should reach 19 at the end. It is 9. This one is 3. So do you agree 15 is now 5 times 19? So if you factor from 19, it would be 9 plus 5 times 3, 15 over 24, and we can cancel. So it's 9, right? Okay. It was problem 22. What's your next question? And good job. Look, the only thing I did here was only translate it to a mathematics equation. I can say 20% was this, and you could solve 80% was solving this part. Why you couldn't solve? You didn't write it in mathematics equation?
No, like my mathematics equation, like mine was like kind of different. Like there were like a lot of variables. It was, like, not-
You had more than 2 variables, right?
Yeah.
Yes. Try to use variables as less as you can. Okay. Okay. Well, good job. You could reach 30. What's your next question? Let's consider. Again, we should use casework. Do you agree for the first step it can go up or down or left or right, but all of them are similar, right?
Yeah.
So do you agree we can say without loss of generality we can say it goes up and only we need to calculate this?
Yeah.
And because it is probability we shouldn't multiply it by 4. Do you know why? Or want me to explain? Let me tell you an easy proof for this. For example, you go up with probability of 1/4, right? So suppose we calculate the probability is p after that, for example, probability of the solution. Then, for example, you go up, then down 1/4 times p. Then for example, left 1/4 times p. Then for right, again 1/4 times p. So the answer is what? Is p over 4 plus p over 4 plus p over 4 plus p over 4, which is p again, right?
Yeah.
So we don't need to multiply it by 4, right? Because we have 4p also, we should multiply by 1/4. So we can consider up, and all of them are similar, so we need to only calculate this. Agreed?
Yeah.
Okay, then we should do what?
Like choose another direction.
There we have 4 directions to choose. So the first one said is up. If we go up left, it will be good. Now, right? Because we don't need to continue. We go to the corner, right? So the probability of this one is what?
1/4.
We said we don't consider this 1/4. Okay, we calculate this p and all of them will be p. So we ignore this, right? So it is 1/2. Sorry. 1/4 because we have 4 directions, exactly. UR is what? The probability.
Wait, can you repeat that?
I said.
You're cutting out.
Okay. What about now? Is my audio clear now? So do you agree? Is my audio good? Is it clear now?
Yeah.
Okay, so here it is our first movement up. We don't need to calculate this. Now, second movement, if it is L, so we reach the corner 1/4. If we go right, the probability is what?
1/4.
Exactly, 1/4. Now, if we go up and then go down, then what's the probability that you reach to one of the corners? So for UD, your answer is what?
1/8.
1/8. Okay, let's check. The probability to go down is 1/4 times. Now, you have two movements. And you can say 4/4. But how many of them are good? 1, 2, 1, 2. For each of them, 2 ways to reach. So 8 ways. So 8/16, which is 1/2 times 1/4, which is 1/8. Completely correct. Good job. And if you go up and up, calculate this one.
5/32.
5/30, you said?
32.
5/32. Okay, let's check. 5/32. For this one, let me copy this page, this figure. So we should go up and up again. So we reach this, and by probability of 1/4. Then we have 4 times 4 actions. What? No. We cannot say this. Let me tell you, we should calculate the rest. If we go for the next step to L and R, it would be good. And 1/4 for U, 1/4 for L, 1/4 for right. If we go up again, then we cannot reach any corner because one step is left. If we go down, then the probability is 1/4 for going down. So one step is left. You should go left or right. So 2/4 will be good. So it would be 1/8. 1/4 plus 1/4 plus 1/8. Let's calculate this. So it would be 1/4 times 8, 1 plus 2 plus 2, 5/8, 5/32. Good job. Okay, now the correct answer is what then?
25/32.
25/32. Okay, let's check. Here, if we use common denominator 32, it would be 8 plus 8 plus 4 plus 5. 9, 8, 17 plus 8, 25/32, which is 25/32. So which choice is correct?
D.
Exactly. Good job. What's your next question? This is the figure is constructed from 11 line segments. So look 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Each of length 2. The area of pentagon ABCDE can be written as root m plus root m. Okay, so we should calculate the area, okay? And the side length is 2. So here, let's do something instead of this. Let's copy. We know side length is 2, and we want to calculate the area. So let me make it larger. And this one is 2. This one is 2. This one is 2. All side lengths are 2. Can you tell me this angle is what? Let me say, look, it says all of these 11, or yes, all of them are 2. So This angle is what?
60.
Yes, and we can say, okay, it is 60. This angle is what?
60.
This angle is what? Let me check. Is it
60.
regular pentagon or not? No, it's because it was not possible to be a regular pentagon, because then it is 120, and in regular pentagon, each angle is not 120, right? Okay, this one is 60, this one is 60, this one is... No, not this one, 60, because it's not in a triangle. This one 60, this one 60, this one 60, and this one 60, this one 60. But we don't know each of them is what so far. Okay, so what can we say? We can calculate area of each of these triangles, right? So, for example, we can calculate area of this triangle, area of this triangle. Then what is left? For example, this triangle, if we connect, for example, this part, something like this, and this triangle, right? So, can we find any of these angles? For example, if we connect this one, is 2, we can also consider this one, and it is 2, it is 2. Can you say anything about these angles? Let's see only the conditions. 11, length 2, there. Okay, can you say anything about those angles? Let me tell you, look, do you agree? We can consider this one as a rhombus, right? Such that each of them is 2, right? This one 2, this one 2. So, as you can see, if I color this one by pink, then one of them is this one, and the other one is this one. We can color it with green, or we can color it with red. This one, this one, this one, this one. There are 2 equal shapes, right? And for example, you can rotate it around A, right? About A. Agreed? Pink one and red one. And you can rotate them such that these 2 endpoints, the distance of these 2 endpoints is equal to 2. So this part is important, right? Agreed?
Yeah.
So first, we can understand that we should focus on these 2. And by using these 2, we should try to find, for example, some equal things, right? So this length is 2, this length is 2. We have these shapes.
Wait,
So let's consider this triangle, okay? Because look, we know that ACD. Okay, so we can solve this. They are not necessarily collinear. A, C, and D. Do you agree area of this triangle, this pentagon, is area of ABC plus area of ACD plus area of ADE? Agreed?
Yeah.
So, and do you agree area of ABC and ADE are equal? And do you agree area of ABC plus area of ADE is area of whole part? Area of ABC, for example, F.
Yeah.
And area of ABCF is equal to 2 times area of ABF. So it will be 2 times area of ABF plus area of ACD. And the rest is not hard. Want to try the rest on your own? Or want it? Okay, sure, try.
Is it 23?
23. Okay, let's check. ABF is a squared root 3 over 4. A squared is 4. Root 3 over 4, so it is root 3. It says it is root m plus root. ACD, we know this length is root 60, root 3 over 2, it is root 3. It is root 3. So for this triangle, we can say there are 2 root 3 and something like, let's calculate. 2 root 3, 2 root 3, it is 1, because it is isosceles. So 4 times 3, 12 minus 1, root 11. So root 11 times 2 over 2, root 11. So it is root 12 plus root 11. So n plus n, yes, is 23. Okay, what's your next question? Let's consider. First one has 5 blocks. So R1, blue one, yellow one, W1, G1. And we have R2, B2, Y2, W2, G2. And we have R3, B3, Y3, W3, G3. And we have 5 empty boxes. 1, 2, 3, 4, 5. And we have a permutation for this one, right? Permutation for this one, permutation for this, right? For placing. It says the probability, for example, look, we can say like this. For example, R1, you place R1 in second one, B1 in first one, for example, fourth one, third one, fifth one, right? And the probability that all, for example, 3 blocks all of the same color in one box, it says at least. So it means that, for example, all of them are 2, right? Something like this. Agreed? So, but maybe one box is good, maybe 2 boxes are good, right? If we want to calculate this, then we will double count something. So we should use what to prevent double counting?
Complementary.
Use what?
Like complementary, I'd say.
Like we can use pi, principle of inclusion and exclusion, okay? Do you know pi is what?
Kind of.
Okay, so let me ask you to make sure. For example, A union B is what? Number of elements of A union B. It is A plus B, then what?
Oh, and then minus the intersection of the 2.
Yes. Because it is A, it is B. You calculate A, you calculate B, so you're calculating intersection twice. So we subtract, right? An absolute value for subset means number of elements. Look, when we write absolute value for subset, means number of elements, okay? Now for 3 subsets, A union, B union, C, number of elements is what? If you use pi.
It's the 3 of them added together.
Yes.
Like A and then minus the intersections of 2 of ABC, like, and then plus the intersection of all 3.
Exactly. Usually we need to use at most for 3 subsets. We call it pi.
If it's more than 3, is it always like plus minus?
Exactly. If we have 4, you say a plus 1 subsets, then minus 2 subsets. Intersection plus intersection of 3 subsets, and minus intersection of 4 subsets. Okay, like this for all of them. For also n subsets, you can do the same thing. Okay. Now here, we have 5 cases that are good. A1 means box 1 has box 1 receives 3 blocks, all of the same color. Same color. Okay. A2 is box 2 receives the rest. Box 3, box 4, box 5. Okay. And do you agree the answer is number of elements of A1 union, A2 union, A3 union, A4 union, A5? And we should use pi. Want to try the rest on your own? Or one hint? I can give you.
I can try.
Okay, sure, try.
Wait, is it 471?
Ah, you reached 471? Okay, so let's check. Let me copy this part. Calculate. And one thing that is good here is that A1 to A5 are symmetric, right? So for example, if you find A1, all of them are same, right? So we should find 5A1 minus 10A1 intersect A2, because it is 5 choose 2, plus 10 A1 intersect A2 intersect A3, minus 5 A1 to A4, A3, A4, and plus A1 to A5, right? Agreed?
Yeah.
A1 is what?
A1, oh, I have to get up. A1 is 1/25.
Okay, so it is A1, we should calculate the probability. So I want to calculate number of cases, then divided by, can you tell me total number of cases is what?
125. Wait,
5
or like,
factorial cube, right?
oh.
You should correct your answer.
Huh?
Okay, 5 factorial
I
cube.
just
Your
like did it
answer
in
is
a
still
way.
471.
Huh?
You did with a different way.
Yeah.
Okay, so let's calculate it this way. A1 is number of cases, not probability. Then at the end, I divide by this, okay?
Okay.
Okay, so 5 here. A1 for me. A1 is box 1 receives 3 blocks, all of the same color. So we have 5 choices to receive which color, then the rest will be 4 factorial cube, right? This one, A1 and A2 are good. So A1 has 5 cases, A2 has 4 cases. Then the rest will be 3 factorial cube. Then this one, 5 times 4 times 3 times 2 factorial cubed. Then here, all of them are good. 5, 4, 3, 2, 1 factorial cube. And this one again, 5 to 1. 5 factorial. So if we divide it, the probability is 5 times 5. 25 times 4 factorial cubed. plus minus 50. So we can say what? We can say minus 5 factorial times. Because we want to divide by 5 factorial, we can write 5 factorial squared, cancel 1 5 factorial. So 5 factorial then times 4 factorial squared times 5. Then here, if we cancel 5 factorial, then 10 is left times 3 factorial squared plus 10 times 2 factorial squared minus 5 times 5 factorial, we can cancel, plus 1. Okay? So if we calculate that, it would be what? So 5 factorial, it says the probability is m over n, m plus n is what? Here, we can do what? So let's cancel this one first. It is 5 factorial, 4 factorial. If you divide this by this, then minus 10 is what here? We can say 10 times 3 times 2 times 3 factorial. Again, you can say 2 times 2, 4. 2 times 10, 20 is 4 times 5. It's 5 factorial, so you can cancel 1 5 factorial, 3. Plus 10 times 2, so we can calculate the rest. So 5 factorial squared, 10 times 4, 40, minus 5 plus 1. So it would be what? It would be 35, 36, right? 36 over 5 factorial squared. You can cancel what? Let's see. 36 over 5 factorial times. Next one, 5, 4, 3, 2. 36 is... if we divide it by 4, 3, 12. It's 3. So it would be 4 factorial. We can cancel also more. We can say this one is 1 over 5. Next one is 1 over 2 times 4 times 5. And last one is 5 factorial. Or let's write like this. We can cancel also 3 from here. So it would be 2, 4, 5. So it would be 2 times 4 times 5 times 5 times 2 and 1 here. Okay. So if you use common denominator, 2 times 4 times 5. 2 times 4 is what? Is 8. 40 times 10, 400. 400 divided by 5 is 80. 400 divided by 40 is 10. And plus 1. So 71, 400. So it's 471, right? Okay, and good job. You could solve this.
I think I can do it. I think I did it. I forgot.
Okay.
I
So
think I
this
got, like,
one is
96 maybe.
with a small example, you can easily solve this one. Want to solve it or want to move on to the next?
I solved it. I think I got 96, but the thing is, I wouldn't know how to like solve it faster.
Okay. So look, if you use a small example, at first, f of 1 is what?
F of 1 is just gonna be 1.
Yes, and 2023 is what if you prime factorize?
2023 is 17 times 7 squared. Wait. First. 7 times 17 squared.
7 times 17 is squared. So it is pq squared. The form is a prime. Yeah. So if p is prime, f of p is what by using this?
1 minus p?
Yes. You can easily calculate. Now, f of p squared is what?
It's also 1 minus p.
Yes, you can easily calculate this. Look, you can say
Yeah.
1 times f of p squared plus pf of p, which is p times 1 minus p, plus p squared f of 1 is 1. So p squared, negative p squared, 1 minus, right?
Yeah.
Now we want to calculate pq squared, so f of pq is what? Calculate.
I got 1 minus p minus q plus pq.
Yes, you can say it is 1 minus p times 1 minus q, right?
Yeah.
And you can easily calculate this like f of pq plus pf of q, which is p1 minus q plus q times 1 minus p plus pq f of 1 is 1, right? You can say pq, pq, you can cancel, so f of pq, you can say is pq minus p minus q plus 1, which is this, right?
Yeah.
Okay, so look, in 20 seconds you can calculate this. And last step, f of p squared q. Calculate this exactly like this on previous things we calculated, right?
I got the same thing as f of pq.
Exactly. We can say it is p squared q times f of 1 plus pq times, so let's write like this, you can write p squared q times 1 times pq times f of p, which is 1 minus p, plus p squared times 1 minus q plus what? Plus q times 1 minus p. P squared q has how many divisors?
3. No, sorry, 6.
Yes, 3. So 1, 2, 3, 4. 1 times 1 minus p, 1 minus q. Plus what? Because we want to find this, we can write f of p squared q. So one more term is left. Plus what? Plus p, right?
Yeah, yeah.
pq is 1 minus p, 1 minus q is 1, right?
Yep.
Okay, so if we simplify p squared q, we can cancel them. Then negative p squared q, so this one, 1 minus p minus plus pq. So p squared q again, p squared q, we can cancel, right?
Yeah.
Then negative p squared, negative p plus p squared. And then what? We have pq here minus pq. So pq minus pq. So what else do we have? Q f of p squared q. We can say negative q plus pq, and this one minus p plus 1, which is 1 minus p, 1 minus p, right?
Yeah.
So f of 2023 is what?
6 times 16.
Yes, negative 6 times negative 16, which is 6 times 16, which is 96, right?
Yeah.
So look here, a small example is related to prime numbers, and we should prime factorize, right?
Yeah.
And there are some problems in SUMaC and also AMC that you can solve with the same idea that you should prime factorize. And by this a small example, you will find that one problem, I will copy them. One problem from SUMaC, another problem from AMC 12Q25, but I will find the year.
No, I tried so much, but I just could not solve it. I don't know why. So what I did, I found like small examples, like you said. I think I found a is equal to half and b is equal to 1, maybe. And I tried to like
But you
prove
couldn't
why
prove,
those
right?
are maybe. Yeah, I could not prove it.
Okay, by AMGM. AMGM is what for two variables? X plus y
Over 2.
over 2
Over
is
2 is
greater than equal what?
Yeah. The square root of xy.
Yes, and for x and y should be what?
Greater than or equal to 0.
Real numbers, positive real numbers.
Yeah, yeah.
Okay, so by AMGM, 1 plus 2a is at least what?
Plus 2 times the square root of 2a.
Yes, because they are positive, right? 2
Yep.
plus 2b is greater than or equal what?
So it's gonna be 2 times, so 4 times square root of b.
And 2a plus b is greater than or equal what?
2 times 2ab.
Yes. And if you multiply them, here let's consider this one is t. Left hand side is what? Is t, right?
Yeah.
Right hand side is what?
8 times the square root of 2a times 4b times 2ab.
2 times 4, 8 times 2, 16, a squared b squared.
Yeah.
Which is what?
Oh, it's just 32ab.
And we know 32ab is equal to t, right?
Yeah.
So because they are equal, so all these inequalities should be equality. Because if one of them is strictly greater than this, then when you multiply this one is strictly greater than this, right?
Yeah.
So we have equality. And in AMGM, equality holds this inequality. In this inequality, equality holds when what?
X equals y.
Exactly. X equals 1. So this part is important. Let me put the black part around.
Does equality hold if and only if x equals y?
Yes, if x equals y, these two are equal. If equality holds, x equals y. Yes,
That's the only case, right? Okay.
yes, that's the only case. Yes, if one of them is greater, here we have a strictly greater.
Yeah.
But pay attention for positive real numbers. Okay?
Yeah. Yeah.
Okay, so from here we can conclude what is, because we have equality for all of them, then what can we conclude?
So the first one is equal to itself.
What is equal to what?
So I think I got a is equal to 1/2, maybe.
Yes, 1 is equal to 2a, right? It is x here,
Yeah.
right? So a
Yeah.
is equal to, as you said, 1/2. What about next one?
B is equal to, so 1 plus b. Oh, so b is just 1, right?
Yes, b is 1 and it satisfies this one, right?
Yeah.
2a
Yeah.
is b, so it's satisfied. So the answer is what?
1.
Exactly, one solution. Suppose a is a subset of 1, 2, 3, okay, in general.
Yeah.
How many a's do we have? How many subsets are there for 1, 2, 3?
2 to the power of 3, so 8.
Yes, the reason is what?
And that's just the number of subsets. And
yes, and the reason is what?
Yeah.
That we have 2 cube
Yes.
subsets.
So the number of subsets for two elements in it is gonna be what? Like n choose 2. For 3 elements, n choose 3, and then
You use that. Okay, let me tell you an easier way. Look, tell me a subset from this, any subset, an example.
2, 3.
Is 2, 3. When you say 2, 3, you are doing what? You say 2, 3.
Yeah.
It means that
2,
1 cross, 2 check, 3 check, right?
Yeah.
So do you agree for each element you can select it or not? Cross check, cross check,
Yeah.
cross check. So 2 ways, 2 ways, 2 ways, 2 cubed, right?
Oh yeah, that's true.
Okay, it is a reason. It means that we consider from elements. Now suppose we have two subsets. A, B from 1 to 3. How many A and B are there? We want to select both A and B together. So one subset here, one subset. How many ways are there for selecting A and B?
For selecting A and B, so do they have to be distinct, right?
Do they what?
Distinct?
Not necessarily.
Okay. Is it 2 to the n choose 1 times 2?
Let's consider.
the
Look,
whole
we should
squared, I meant.
select both A and B. For A, how many options do we have? For B, how many options?
For A, we have 2 to the n options.
Yes, here 2
B,
cubed
we have
times
2 to the 3 as well. So whole squared.
what?
So it's 64.
Exactly, 2 to the 6 is 64. But let me tell you, this was solution 1. Let me tell you another solution. This solution is important. So here, look, we consider these from subsets, right? We said A2 cube, B2 cube. Now we want to consider from elements. We consider from the elements. For here, look, when we have one subset, we said, okay, for each element, we have cross-check, right?
Yeah.
Now we have two subsets. For each element, how many cases are there? For example, one case is cross-cross. What else?
What do you mean?
Look, for example, here, we said for one, we have check cross, right?
Yeah.
Two check cross, three check cross. Now here, we want to select two subsets, right?
Yeah.
So can you tell me one example? A is what, B is what?
Like elements?
Yes, an example. Like here you said A, 2, 3. Here we have two subsets. So A is what, B is what?
Let's say A is like 1.
B is what?
1, 2.
1. So now let's check. For 1, it is check, check, right? For
Yeah.
2, cross check. 2 is not in A, but is in B, right?
Yeah.
For 3, it's what?
Cross, cross.
Exactly. Now here, for each element, how many ways are there for going to A and B?
2.
Can you tell me 2? I said cross, cross. What else?
Wait.
For
What do
each
you mean
element,
by-
look, each element can be in none
Yeah.
of them. Or
Yeah.
only in A, right? What else?
Yeah. Could be in both.
Yes,
And could be in B,
in
could not be
only
in
B
A. Yeah.
or both. So each element has
Yeah.
how many cases for going to A and B?
4. 4
4.
cases.
So element 1 has 4 cases, element 2 4 cases, element 3 4 cases. Which is what?
4 to the 4 cubed. 64.
Exactly. Again, 64. Now maybe you say, okay, here also we could reach 64. Why we use all these things? Because in most of the problems like this, you have to use solution 2. With solution 1, we cannot solve. Okay, let me tell you an example. Suppose A is subset of B is subset of 1, 2, 3. So how many A and B are there? Try this one.
Is it 56?
Can you explain your solution?
So for B, since A has to be a subset of B, so
Yes.
first I just, like B, we can choose B 8 ways, right? There are 8 choices
For
for
B,
B.
8 ways, but there are
8
different. For example, if
Yeah.
B has 3 elements, then A has how many cases?
It can have either those 3 elements or the elements choose 2 and elements choose 1.
You can say 2 cubed. A has 2 cubed because
Yeah.
for each of them can be inside it or outside it, right?
Yeah. Yeah.
So for this case, we say 3 choose 3 for B, and for A 2
Yeah.
cubed, right?
Yeah.
Choose 2 cubed. If B has 2 cases, 2 elements, then A has how many cases?
That case 2 squared.
2 squared. So in this case, for B, how many cases are there?
So for B, 3 choose 2. 3
Yes,
ways.
good job. 3 choose 2 for A,
2 squares 4.
3 times 4, 12. For B, 1 case, A has how many cases?
2 cases.
Yes, so it will be what here?
So 6 ways for B.
6 ways. For B,
3 choose 1.
yes, ma'am. 3 choose 1. 1,
3,
3
just
ways
3.
for these and 2 and
3.
6 in total, right?
Yeah.
If B has
6,
no
yeah.
elements, then A,
1.
yes, 1 way or 2 cases. Here, 1 times 1, 1, right? Some of them
Yeah.
is what?
27.
Now look, and the idea if instead of 3 elements we had 4, 5, it was harder, right?
Yeah.
But let's solve with double counting, means changing viewing angle. We want to consider instead of the subsets from the elements. So can you tell me, we know A is a subset of B. For each element, how many ways are there for going to A and B? Cross, cross, check, check, like this. What are the cases?
to choose the elements.
Look like previous one. For example, previous one you said for each element for going to AB cross check, check, right? Now here we have a condition. So which of these 4 cases are acceptable here?
Whatever is in B has to be in A.
Yeah, so tell me, for example, one good case is check is. Tell me other good case.
So B check, A cross.
B check, A cross, yes, what else?
Cross.
Yes, only check cross is bad, right?
Yeah, that's bad.
So each element has 3 cases. So the answer is what?
3 times 3 is 9.
3 times 3 times 3, right?
Oh yeah.
Or 1, 3. Yeah, I think this solution is easier.
Yeah.
Exactly. So here now, similarly, for example, A subset of B subset of 1 to 10. Then how many A's? So this one was 27. Here, number of A and B are what?
The number of ways we can choose A
How
and
many?
B?
Yes, how many A and B's are there? Only I changed 3 to 10.
Yeah.
Same. So it will be what?
3 to D10.
Exactly. Now, again, we want to solve similar problem. Here, instead of 2 subsets, let's consider 3 subsets. 1 to 10. Now, here, number of ABC are. How many ABCs are there? Try this.
Okay. I got 4 to D10.
4 to the 10, you said, right?
Yeah.
Good job. I think it is something like this. If from here we have check. If it starts from here, it will be this, or starts from C, or none of them. So 4 to the 10, right? Okay, now you've learned this idea, and you are ready to solve problem 20. So let's consider. It says let K be the number of sequences A1, A2 to AN, such that n is a positive integer divisor, integer less than or equal to 10. So n is at least 1, at most 10. Each AI is a subset of 1 to 10. AI minus 1 is a subset of AI for each I between 2 and n. So let me ask you something. I told you the most useful idea is what?
For this problem?
In general, a small example, right?
Yeah.
Checking a small case. So here we can use a small example on what?
A1.
N. If
Oh,
n
for
is
n,
1,
so
the answer is what? It means we have only one subset from 1 to 10.
Yeah.
How many subsets are there?
And choose 1. 10.
No, A1. A1 is a subset of 1 to 10. How many subsets are there?
Oh, okay. So there's 2 to the 10th.
Exactly. For N2, it says AI minus 1 is subset of AI. So A1 is subset of A2, is subset of 1 to 10. How many ways are there?
3 to the 10th.
For N3, it is what?
Oh, so it's gonna be 4 to the 10th.
Yeah, similarly, all the way to N10 is what?
9 to the 10th.
Pay attention.
Sorry, 11 to the 10th.
Yes. And it says fine. K, so K is what? Sum of them, right?
Yeah.
2 to the 10 plus 3 to the 10, all the way to 11 to the 10. It says one's digit of K is what? So calculate one's digit of K.
Is it 5? I got 5.
Okay, let's check. I think it was 5. So because let's write all of them first. 2 to the 10, 3 to the 10, 4 to the 10, 5 to the 10, 6 to the 10, 7 to the 10, 8 to the 10, 9 to the 10, 11, 10, 10, 11 to the 10. Okay. And do you know if you want to find the remainder when it's divisible by 10, you should calculate mod what?
10.
Yes. This one is 0, this one is 1, right?
Yeah.
Okay. Now for 6 it is 6, right? For 5 it is 5. Let's write it here.
Yeah.
For 99981 is 1, right? Let me tell you something. For 2, do you agree because the power is 10? 2 to the 10 and 8 to the 10 are equal?
Yeah.
Because 8 is negative 2. So for 2, if you find this 2 for 8, 16. Which is 6, and again 2 for 8, 16. So it's 4.
Yeah.
So because this one is 4, this one also is 4.
Yeah.
For 3, it's, again the period is 4. So 3, 9. And this one, the period is 4, 6, 4, 6 is 6. 7 is similar to 3 is 9. So 1 plus 1, 2, 2 plus 4, 6. 6 plus 9, 15. So we can consider 5, 5 plus 6, 11, 1. 1 plus 5, 6, 6 plus 6, 12, 2, 2 plus 9, 11, 1, 1 plus 4, 5. Good job. So can you tell me tangent first? Tangent 2023x is what over what? Tangent is always what over what?
Sine of 2023x over cosine of 2023x.
Exactly. 2023x cosine of 2020. So now we want to use this. You say what? You say what? Cosine of 2023x plus I sine 2023x is what to the power of 2023?
E to the I 2023x.
It's cosine x plus I sine x to the power of 2023, or e to the I 2020.
Okay.
Agree?
Yeah.
Okay, now let me ask you something, an obvious question. If a plus bi is equal to c plus di, then what can we call?
A is equal to c and b is equal to d.
Exactly. And do you know binomial expansion, for example, when you raise it to the power of 2023?
Yeah.
Okay, so here, look, imaginary part is this. Imaginary part here will be a sigma, right?
Sigma?
Real part. Here, real part is something ... because you should expand this and find all real parts. And also, so for the denominator, for the numerator, you should consider imaginary part. For the denominator, you should consider the real part. Then you have a sigma, and you should make it similar to this. Okay? So try the rest. See, can you solve it? Let me know if you wanted more.
You need help?
Okay. Let's expand this. This one to the power of 2023 is what? Let's write few terms.
E to the I, or expand it?
Yes, let's expand this one. The first one is cosine x to 2023, right?
Yeah.
Then works.
And then 2023, choose 1. So 2023 times cosine 2022 power times I
Yes,
sine
we
x.
can say 2023 cosine x to 2022 plus I sine x. So let's write I here, right? The next term is what?
Yeah. 2023 choose 3
minus
times
2023 choose what?
Negative, 3. 2.
2 times what?
Cosine of 2021 times sine squared x.
Excellent. Next one is what?
So it's gonna be 2023 choose 3 cosine 2022 power and then sine cubed.
Sine cubed x and then what? Times what?
Negative x, negative I.
Yes. Next term is what?
Positive 1. So 2024. 2023 choose 3. Sorry,
Choose
4.
Plus
Cosine 2019.
x
And
sine what?
4.
6, right?
Yeah.
Okay, so let's write last two terms. Last term is what?
2023 to the 2023. So just 1 times cosine so just sine to the 2023 and I to the power 2023. So it's gonna be I believe it's -1.
-1?
I think.
No.
Yeah, let me just do it. So,
I to the 2023 is what?
yeah.
I to the 2023 is what?
I think it's -I.
Yes, it's I cubed, it's negative. But first you said -1, right?
Yeah.
Okay. So -I. Second last term is what?
2023 times cosine x times times -1 times sine to the 2022.
Exactly. Negative. Okay. Now let's write. Here you said tangent is sine over cosine. So
yeah.
Let's open this. And we know sine 2023x is imaginary part here, right? So it would be what? Plus what?
Sine 2023.
Sine 2023x is what if you consider this? They are equal to this.
So yeah, so all of this minus cosine of that divided by x. Divided by I.
Yeah, so let's write the terms that have I. So this part, right?
Yeah.
So 2023 cosine 2022 sine x. Next term is what?
The next term, -I.
We don't need to write I, right?
Negative.
It has I.
Yeah.
So negative.
So 2023 choose 3.
Exactly. Times what?
Cosine 2020 and sine cubed fx.
Exact sine cubed. Plus dot dot dot. Last term is what?
2023.
Yes, minus sine 2023x. What about the numerator, the denominator?
Just subtract all of them from I sine 2023x. So so just the real part.
So we want to write,
just
for
gonna be
example, the first
cosine.
term is cos 2023x plus what? Plus or minus?
And then 2023 choose 2 times cosine of 2021 sine squared x.
Yes, then what?
Then 2023, so all even ones.
2023 choose 4.
Yeah.
Cosine 2019.
Yeah.
Sine x to the 4th. Last term is what?
2022. 2023 choose 2022, I think.
Yes. So let's write
2023 times cosine times sine x to the 2022.
Yes, here dot 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 minus 2023 cosine x sine x to the power of 2022, right?
Yeah.
Okay, now we know this one. Let me move this here. And about 2022. Okay. This one is equal to this one. Tangent x, right?
Yeah.
Okay. So now I want to make this one similar to this one. So I should divide both numerator and the denominator by what?
Sine x to the power 2022.
Look, I want to, for example, make the first one to the
2023,
tangent x, this one to the 1.
Oh, so it's gonna be cosine of 2023.
Yes, if you divide by this, it means that we are dividing by 1, right?
Yeah.
So the numerator will be what? Will be 2023 what?
Tangent x.
Yes, minus 2023. Choose 3 times what?
Tangent cubed. The same.
Exactly. And then last one is what? Minus what?
Last one is gonna be tangent of 2023.
Exactly. And the denominator would be what?
1.
Yes.
Minus tangent squared x is 2023. Choose 3 tangent squared x.
Yes, next term is what?
Then 2023 choose 4 tangent 4 to the 4th power of x.
Yes. And last term is what?
2023 times tangent to the tangent x to the power of 2022.
Yes, minus. Okay. So the problem wants a what?
I forgot.
A 2023. A 2023 is what?
-1.
Yes, finished. Okay.
Just the amount of weights.
Yes, one way is that you consider amount of weights. You can say number of weights or what? Number of steps, right? Because in steps you can solve this, right? You should place them. So, and each of them reach one solution, okay? Then you consider first or last weight or step, right? Now, first weight is the easiest one, okay? First weight is what?
Just 2.
It's 2.
Oh, maybe 1.
1, yes. 2 to the 0 or 1. To the 0 or 1. Okay? Now, consider cases of this and you will reach an easy solution, okay?
Okay. Can I get a hint?
Suppose we place 2 to the 0 in first step, then how many ways are there?
Then we have to place the next one also on the left.
Yes, in terms of AN, okay?
So,
You place AN, if you place 2 to the 0 in first step, you have nth step.
Next one. Oh, because it's on 11. So then next one, it could be basically everyone. So an minus 1. Wait.
Exactly.
Yeah.
Yes, an minus 1, right? Because 2 to the 0 has no effect, right?
Yeah.
Then otherwise, other cases are similar. One more hint or that's enough? Okay, sure.
Would it be an minus 1 for all of them?
No. Careless mistake. Because when we place 2 to the 0 in first position, we should place it on which pan?
The pan with the least weight. I mean the most weight. Well,
No, we should place on right on. It says always left pan should be greater than equal right pan, right?
I see. So for 2 to the 1, 2 to the 0 pan can go on either if it's the first.
Yes, if it is not first, right?
Yeah.
If it is first, it should go to left pan. So otherwise, it will be what then?
2 minus 1.
Yes, for each of them to an minus 1, but we should multiply by what? How many cases are there?
N minus 2.
Why n minus 2?
Because, I mean N minus 1. Because,
Exactly. Finished.
Yeah.
We solved our problem.
Okay.
Okay. So as you can see, by asking only this question, we solved the problem, and it is 2n minus 1 times an minus 1. Agreed?
Yeah.
Now calculate closed form for an, okay?
Okay.
Okay, I think I finished.
Okay, can you tell me it will be what?
An equals constitute 2n minus 1 times 2n minus 3 times 2n minus 5 until 1 times a0.
Exactly. A0 is, we can say 1, right? We can define that as 1.
Yeah.
And can you tell me if you want to write it without dot dot dot? In terms of factorials,
Isn't it like double factorial?
Yes, also if you want to write it without double factorial, only factorial, it will be what?
Let's see. 2n minus 1 factorial over 2 times n factorial.
This one?
Yeah.
Has a careless mistake. Try to correct it.
N minus 1 factorial.
Yes.
At the bottom.
It has 2 careless mistakes. One of them was this, and good job. You correct this. One more careless mistake it has.
I don't know.
2 to the n minus 1. Because
2.
Agree? Because denominator. Because look, when you say this, you should divide 2 times 4 to 6 to 2n minus 2, right?
Yeah.
So you should factor from each of them 2. It is not summation to say only 1, 2. It is product.
Oh, yeah.
So 2n minus 1, because usually we have these careless mistake. That was the reason I told you. So it is this, right?
Okay.
Do you know double counting is what? Have you heard?
Like principle of inclusion and exclusion.
No. Sometimes.
N is a multiple of 3.
Yes, what else? Focus on n plus 120. N plus 120 is multiple of 3, right? What else?
It's also multiple of 7.
No, focus on only 3, power of 3. We have 2 conditions.
It only says
yes, means 9 doesn't divide this, right?
Yeah.
And here it is equivalent that we say V3. Do you know V3 means what?
Oh yeah, the guardians.
Power of 3 in n plus 120, right? So V3 of n plus 120 is what?
So the
1, exactly. So by this part we can say, because V3 is 1, n plus 120 is 0 mod 3, right?
yeah.
N plus 120 is what mod 9? Can be what mod 9? Then exact 3 or 6. So M120 is what mod 9?
Mm, 3.
Exact. So we can conclude N is what mod 9?
0 or 3.
Exactly. It is the first result that is useful, okay? Now let's focus on 7. For 7, what can we say?
7 divides n plus 120, but 49 is not.
7 divides n plus 120, then what?
49 does not.
Why 49 does not?
Because the GCD should have only one power of 7 in it. So.
But here power of 7 is 1.
Oh wait.
Exactly. We have only this, right?
Yeah.
So and we can conclude V7 of when we can conclude what about V7 of n plus 120?
It's what?
At least 1.
Actually, this one.
Yes, we don't need to consider this in this case, but I just wanted to check with you, okay, to pay attention to these things. So we can change it to modulo n plus 120 is what mod 7?
0.
Yes, 120 is what mod 7?
1.
1. So n is what mod 7?
6.
Exactly. So it is second result, right?
Yeah.
Now we've completely considered this, right?
Yeah.
Now let's focus on second part, okay? On second part, you should change it to something like this. That, for example, look, previous part, this part is equivalent. That n mod 7 should be this, and n mod 7 should be this, right?
Yeah.
Here, you should reach similar results. So try this part first on your own. Find all modulos that are to find that they are equivalent to this GCD, okay? So try.
Okay, so I'm getting n is congruent to 1 mod 4, n is congruent to 0 mod 3, and n is congruent to mod 5.
N is. Let me write your results. Can you say it again?
Yeah. 1 mod.
Okay. What else?
0 mod 3.
0 mod 3. What else?
2 mod 5.
2 mod 5. Okay, let's check. GCD of n plus 63. And 120 is 2 cubed times 3 times 5 is 60. Which is 2 squared times 3 times 5, right?
Yeah.
Okay. When we consider power of 2, we can conclude that V2 of n plus 63 is what?
It should be 2.
Yes. So you should pay attention to one more thing. We should have one in one mod that I cannot see. Here. You should add one more mod only by checking this. Try to find that mod, okay?
Would it be n plus 63 is congruent to 0 over 4 mod 8?
n plus 63 is congruent to what mod? 0 mod 4. What else?
And 4 mod 8.
Exactly. Do you agree when we consider it is 4 mod 8, it is also 0 mod 4, right?
Yeah.
So we need to only consider this, right?
Yeah.
63 mod 8 is what?
7.
7 or negative 1, right?
Yeah.
So let me correct it. N mod 8 is what then?
So n mod 8 is 5.
Yeah.
I mean, n is 5 mod 8.
Exactly. Now let's consider 3. Okay, 3, 3. From 3, we can conclude this one is multiple of 3, right? Then it's correct. For 5, it is 5, it is 5, right? So this one should be multiple of 5, that's correct. It's 2. So let's consider all modulos that we've reached so far. Let me write them here. We've reached this. We've reached this one. And we've reached this one, right?
Yes.
Okay. If we consider these 5 mods, one of them is useless. Can you tell me which one is useless?
9 mod 8. 9 mod 9.
Mod 9 is useless. Let me check something. Why you said 0 or 9? Mine is 0 or 3, right?
Oh, yeah.
Okay. Because 9 is 0 again. So mod 9, 0 or 3. In these 5 mods, okay, it is not guessing. Try to check all of them. One mod is useless. You can ignore that. Which mod, okay? Try to find that mod. One hint?
Yeah.
Do you agree when mod 9 is 0 or 3? Then it is multiple of 3. So from here we can conclude this one, right?
Yes.
So do you agree we can ignore mod 3?
Oh, yeah.
Okay, so let's erase mod 3. So we have these mods, right?
Yeah.
Okay. And the problem says what? The problem says find the least positive integer less than greater than 1000. Okay. So I want to solve one by one, for example, from these two. Because here we have two options for 9, let's check it in the last step. So from here, because we know mod 8, mod 5, we can find mod what?
Mod 40.
Okay, so try to find n mod 40 is what, okay? I told you last session, right, how to solve these types of problems, right?
Yeah.
Okay, try.
I'm getting mod. It's
Congruent to 37 mod 40.
37?
Yeah.
Okay. 37, which is mod 8, 5, mod 5 2. Good job. Now, by these two things, we can find n mod what?
And then we can find mod 280.
Exactly. Find mod 280 is what?
I'm getting 237.
237, you said?
Yeah.
Okay, so let's check. 237. 237 mod 40 is -3, that's correct. Mod 7 is 6, 327. Yes. What was your approach? You said 40k plus 37?
Yeah.
Exactly.
Yeah.
Now for this one, because mod 9 is 03, we should consider two cases, right?
Yeah.
N is 237 mod 280, and N is 0 mod 9, right?
Yeah.
So we can find N mod what?
2520.
Exactly, 9, 8, 72, 7, 25. So, in this case 1, case 2 is that n is 237 mod 280, and n is 3 mod 9, right?
Yeah.
So in this case also we can find n mod 2520, right?
Yeah.
Okay, if you find these two question marks, then we can solve the problem, right? Okay,
Yeah.
find first this question mark, okay?
I'm getting 1917 mod 2520.
1917, exact. 1917. And now solve this question mark.
237 mod 2520.
23, you said 237.
Yeah.
Okay, 237. Let me write. Yes, 237 mod 9. But it says for this case, minimum n, because n should be at least 1000, right?
Yeah.
It says n is at least, I think, 1000, right? Yes. Greater, strictly greater. Okay, it's not important here because 1000 is not possible. So minimum n is 1917. For this case, minimum n is what?
2757.
Exactly. So answer will be what then? Minimum n will be what then?
917.
1917. And so answer is what sum of the digits?
18.
18, exactly. So the correct choice is C. Okay?
Okay.
Your solution was different, I think, completely, right?
Yeah.
If you have a line, for example, like this one, and this angle is alpha, and this one is x-axis, okay? For example, this one is x, this one is y. The slope of this line is what?
Slope?
Slope in terms of alpha is what?
I'm not sure.
Okay, so this is important in many problems of AMC 10 and 12. This one is useful, let me tell you. And you agree, for example, when you want to calculate this slope, you say, okay, y2 minus y1, x2 minus x1, right? So you say, okay, if this one is a, this one is b, the slope is y2 minus y1 over x2 minus x1, right?
Yeah.
So it's y2 y1, for example, and this one, this one is x2 y2, this one is x1 y1. So you say y2 minus y1 over x2 minus x1. Can you tell me y2 minus y1 is what in terms of a and b?
Okay. Y2 is just
No,
B
y2 minus y1 is what? This difference is what in terms of a and b?
A minus
A. Because y2 minus y1 is this one, a, right?
A over B.
A over b. A over b is what of alpha in this triangle?
Sine alpha.
Sine of alpha is opposite over hypotenuse. B is not hypotenuse. Tangent alpha. So look, if you want to find a slope of a line and you had this angle, tangent of this is the slope of the line, okay? Now let me check another point. Do you know the formula of tangent alpha plus beta is what?
Tangent alpha plus beta is, I think, tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta.
Yes, good job. Okay. Now that you know this, tangent alpha, tangent beta. So let me draw a black box around these things. So you should memorize this one. It's so much important. In many problems of AMC, I saw this idea. And this one. Now you are ready to solve this problem of AMC 12. This one. AMC 12A 2022. 12A 2020. Try this one. 2020.
I'm not sure.
Okay, so let's try this one. It says this is a line. And if we draw this line, can you tell me the slope of this line is what?
Okay. Let me see. 3/5.
Is a 3/5. Okay. And 2020 lies on this line or not? Check it.
So 2020 lies on the line.
2020 lies on this line, right?
Yeah.
Okay, so if I consider this line, the slope is 3/5, is something like this. And let's consider x-axis like this. And okay, so it is x-axis. And 2020 is something like this, 2020. And it says we rotate it counterclockwise. So this one clockwise, counterclockwise. 45, right? So it will be something like this. Now, let me remove this. Okay, so this one is 45. This one is 2020. And this is what's the x coordinate. So suppose this angle is alpha, this angle is beta.
Mm-hmm.
You want to find x-intercept of this pink line, right?
Yeah.
Do you agree if we have equation of this pink line, then we can find x-intercept if we have equation of that?
Yeah.
So we have 1 point of this pink line. If we have what of this pink line, then with 1 point we can find equation of that.
Yeah.
Look, for this pink point, you have 1 point. If you have what of these pink points, then you can find equation of that.
Oh, so like y minus 20 is equal to tangent beta.
Exactly. Y minus 20 is equal to tangent beta, x minus 20. So if we find tangent beta, the problem will be solved, right?
Yeah.
Tangent alpha is what?
Tangent alpha. Let me see.
Yes.
Let me think. So tangent alpha is. How do we find that?
Well, tangent alpha is the slope of this green line, right?
Oh, so tangent alpha 3/5. Negative 3. Yeah, just 3/5.
3/5. And beta is what in terms of alpha?
And then beta is alpha plus 45.
Alpha plus 45. Okay, now calculate the rest.
So tangent alpha. What's tangent 45?
Tangent 45 is 1. Yes.
So tangent beta is 4.
Beta is 4. Let's check. Tangent beta. Tangent alpha 3/5 plus 1. 1 minus 3/5. Right?
Yeah.
So if you multiply by 5, 5 plus 3, 8, 5 minus 3, 2, which is 4. Yes. Okay, now calculate x-intercept.
Okay. So our answer is wait, the x coordinate is when y is 0, right? Okay, so
Yes, you should consider y equals 0.
so it's 15.
15, okay, let's check. Y minus 20 is 4 times x minus 20. So y is equal to 4x minus 80 plus 20. Y is equal to 4x minus 60. So y is 0, so x is equal to 50, which B. Okay, this was AMC 12, this was AMC 10. Now let's try an Amy problem.
17.
17, okay. So it says how many 3-digit positive integers ABC are there with non-zero digits ABC? So non-zero digits satisfy this. The bar indicates repetition. Okay, so let me ask you this, because we have 0.8 bar. Let me ask you one. Right. Okay, so for example,
I wrote
0.1. You said what?
like I wrote the equation for this problem, but eventually like I just got to a place where like I just couldn't solve it.
So for example, do you know how we can change them to fractions?
Yeah.
Okay, so can
Maybe
you
like
tell me 0. For example, 1 bar is what? What over what?
1 over 9.
And how you reach 1 over 9?
I mean, I just if it's like repeating generally, I just do like the number over 9 because there's like only one decimal place right after the point. But I could also do like geometric series. If I did like
On geometric series, yes, you can use this, but let me tell you another approach. For example, if it is x, you can say 10x is what?
is 1.111.
Yes,
But it's
10x.
not like
And if you subtract 9x is 1, x is 1 over 9. You said what?
no,
Look,
like,
10x is this, x is this. If you subtract 10x minus x, 9x. If you subtract these parts, will cancel each other out. So it is 1. 9x is 1, x is 1 over 9. Okay?
But can you just like generalize that like if the bar is above one number, then it's over 9. And if the bar is like over 2 numbers,
Yes.
then it's like
When we have 0.a, you can say, okay, 0.a, and so on. Then 10x is a. If a is a one-digit number, okay? If a is a one-digit,
99 or like 999.
yes, 9x is a, x is a over 9, right?
Yeah.
But what about 0.abc bar? It is what
Just
over
like
what?
ABC over 999.
Exactly. Again, you can say it is x, it is equal to 0.abc, and so on. Then 1000x is equal to ABC, and so on. So if you subtract 999x is equal to ABC, so x is equal to ABC over 999. Okay? Now it says how many 3-digit positive integers satisfy this. So let's copy this part. So it would be, as you said, ABC over 999, right? And let me write like this. Over 999 is equal to 1/3 times A over 9 plus B over 9 plus C over 9, right? Okay, we can cancel. If we multiply by 3, this one will be what? 333. Then if we multiply both sides by 9, then 333 would be what?
37.
Exactly. So we can conclude A, B, C is equal to 37 times A plus B plus C, right? We can write left hand side as what?
100A plus 10B plus C.
100A plus 10B plus C, right? is equal to this. So if you simplify, it would be what?
63a plus 9b.
63a is equal to
No,
what?
no. Wait, I did that wrong. 27b plus 36c.
Yes, then we should do what?
Oh, divide by 9.
Yes, so what is equal to what?
7a is equal to 3b plus 4c.
A, B, C are from what to what?
There is 0 to 9.
But the problem says they are non-zero digits.
Oh, okay, 1 to 9.
Yes, we should pay attention to all words of the problem. Because for example, we saw all these things, but if you consider from 0 to 9, maybe we reach wrong choice, okay? We should be lucky that our answer is not in the choice. Okay, so, but also it takes time. You calculate something that is not correct. So A is from 1 to 9, and we want to find all answers for this, okay? So one way is to use, for example, modular arithmetic. One way is to use a small examples. So we can consider cases of which of them, A or B or C. I want to consider cases of one of them and then calculate the rest. It's good to calculate cases of A or B or C.
Of A.
Yes, so A can be, so the first thing we should check is A is equal to what?
1.
Yes, A is 1, 7. So what can we say is 3B plus 4C is 7. So what can we say about BC?
They're 1 and 1.
Yes, 1, 1. Do you agree if A, B, C be equal all of them, then this equation is satisfied? Because, for example, 7x is equal to 3x plus 4x, right?
Yeah.
So I can say 1, 1, 1, 2, 2, 2, 2, 9, 9, 9. Here we have 9 answers, right?
Yeah.
Let's see, we can reject which choice. No choice. Okay, so we should calculate the rest. So for A1, do you agree we don't have any other answer except 1, 1, 1? Because if one of them be greater than 1, then this part will be greater than 7, right? Because they are from 1 to 9. So for A1, we don't have any other answer. For A2, 14 is equal to 3B plus 4C. So we can say what? If C is 1, then 14 minus 4 is... Well, let's do something. Do you agree that we can consider mod 4, for example? Mod 4, can you say what can we conclude if we write this equation in mod 4?
3A. Wait, no. A. A is like congruent to B mod 4.
7 is what mod 4?
3.
Yes, or negative 1, right?
Oh,
So
yeah.
negative A is congruent to negative B, so if you multiply by negative 1, A is congruent to B mod 4, right?
Yeah.
So when you want to check B, B should be congruent to 2 mod 4. So B can be 2, or next number is 6, right? 2 plus 4, 6. And 3 times 6 is large. For 2, we know 2, 2. We have 1. We don't have any new answer, right? So like this, because you can use this, you can easily check the choices. So check A3 to 9 and see do we have any other answer except these 9 answers, okay? Try to figure out all of them.
I got that there's 13 in total.
13 in total. What are the other answers that you found?
481, 592.
Can you say it again from the beginning? What?
481,
Yes. What else?
592,
What else?
518,
518. What else?
629.
5. Okay, let's check. For A3, we know 21 is equal to 3b plus 4c. So b, if b is equal to 3, then all of them should be 3. So let's consider 7. Again, this one doesn't work for A4. 28 is 3b plus 4c. B should be multiple of 4. It cannot be 4. It's 8. So 481. Okay, good job. A5. 35 is 3b plus 4c. So B should be 5 minus 4, 1. 5 plus 4, 9. If it is this 3, 3, 32, 8. And if it is 9, 27, it's 35 minus 27. 35 minus 9 is 20. Oh, sorry. 27, 3, 8. It's 2. So it's 592. 518. Good job. For A6. 7 times 6, 42 is equal to 3b plus 4c. So 6 minus 4 is 2. 6 plus 4, 10. So 6, 36, 9. So 629. If A is 7, then 49 is equal to 3b plus 4c. So 7 minus 4 is 3. 9, 40, 10. Okay, from here, it's not good. You can check A. 8. 7 times 8, 56 is equal to 3b plus 4c. B can be 4. 12, 56 minus 12, 44, 11. It's not good. And last one, A. 9. 7 times 9, 63 is equal to 3b plus 4c. B maximum B, if it is not 9, is 5. 15, it's 53, 48, 12. Okay, so we found 4 answers, 9 answers, so good job, 13. Okay, understood completely how we solve this?
Yeah.
Okay, what's your next question? After 17.
Oh, 18.
I'm not sure how to do it.
Look, do you agree we can find AG, equation of AG, because we have 2 points of that?
Yeah.
AG, Q is AG intersect what?
Q is AG. Yeah.
Yes, and P is what intersect what?
P is EF intersect AC.
Yes. So look, for example, for AG, you have AG. So you can find a slope of this and equation of this line. And you can find the equation of this line and this line. And then you can find intersection of these 2 lines after finding equation of them. So you can find Q and P and then PQ. Understand?
Yeah.
Okay, so try.
Wait, but how do we find intersections?
Look, when you have 2 lines, then you should solve 2 equations, 2 variables to find intersection. Understand?
Oh, okay. I got 40 over 13 and 28 over 13.
For which one? P or Q?
For Q.
48 over 30 and 28 over 30, right?
Yeah.
Yes. And now find P.
Okay, I got P is equal to 20 over 7, comma 5 over 7.
20 over 7, comma what over 7?
5. Oh
Okay,
no,
let's-
not 5. You're wrong. 40 minus 28 is. I got 12.
12 over 7, yes. So now that you found this, calculate PQ is what?
So PQ is equal to. I got 20 over 90. 20 root 5 over 91.
Yes, 20 root 5 over 91. So the answer is what?
Okay, so PQ of EF. So what's EF? EF is 2 root 5. 10 over 91 is D.
Yes. And let me check something. Do you know shoelace theorem or not?
Yeah, I think so. Cause I think you told me before.
Yes. I told you a formula for in perpendicular bisector. Do you remember R was what?
R of for what? Like the circumradius?
Circumradius in a triangle. Do you remember it was what?
4 ABC over area.
No. A over what? That formula. Yes. ABC over 4 area. A over what?
Sin
The sine A.
Sine.
And if you consider these, when it was A over 2 sine A, this length was A. This arc was what?
This arc is angle A.
Is 2A.
Or
Because
2A,
look, when
2A.
inscribed angle is A, this one is 2A, right?
Yeah.
So in general, circumradius or radius of a circle is length of a chord over 2 times sine of half of the arc, okay?
Mm-hmm.
And it's not important you consider this arc or this arc because half of this plus this is 180 and sine of them are equal, okay?
Okay.
Now it says we have unit circle here, right?
Mm-hmm.
Then it says what is the sum of the fourth power of the length of all 21 of its edges and diagonals? Why 21? Because 7 choose 2 is 21, right?
Yeah.
Okay. So let's consider this length A, this length B. How many different lengths are there?
Different lengths over there's 1, just 3.
3, right? Because look, 1 arc, 2 arcs, 3 arcs. 4 arcs is similar to 3 arcs, right?
Mm-hmm.
Okay, and can you tell me, because it says fourth power, so we should calculate 7. We have 7 A's, right?
Mm-hmm.
How many B's are there?
7, 8 of 4 plus B. Also 7.
What about C?
Also 7.
Yes. Because if you consider each vertex clockwise, it is connected to a unique vertex. So we have 7. And A is what? Each arc is what at first term? Each arc is what?
Like the angle?
No, arc. Length of this arc.
Oh.
Length, I mean, in radians, it is what?
2 pi over 7.
Yes, 2 pi over 7. So can you tell me A is what?
Well, it's like law of cosines, I guess. It's like 1 squared plus 1 squared minus 2 cosine 2 pi over 7 and the square root of that. So
Use this formula. Use this one. Use this.
Oh. So A equals 2 sine 2 pi over 7.
A is equal to 2 sine what?
2 sine 2 pi over 7.
No, 2 sine.
Oh, well, and this is pi over 7. And
Yes.
got it. Cool.
As I said, this arc is 2A. You should divide it by 2, right?
Yeah.
B is what?
B. Okay. The angle is, this is 2 pi over 7. So B, so 1 equals B over 2 sine 2 pi over 7.
Yes, B is
Which
2
equals
sine
2 sine
2 pi over 7. And C is what?
C is just 2 sine A. E is more. Okay, it's 2 sine 3 pi over 7.
2 sine 3 pi over 7. So if you raise to the power of 4, 2 to the 4 is 16. 7 times 16 is what?
7 times 16 is 112.
Yes. So we should calculate sine pi over 7 to the 4th plus sine 2 pi over 7 to the 4th plus sine 3 pi over 7 to the 4th, right?
Mm-hmm.
We saw the problem, I remember, similar to this, and we use complex numbers. Remember?
Yeah.
Okay,
Mhm,
can you tell me sine alpha in terms of complex numbers would be what?
Sine alpha in terms of complex numbers? So e to the I theta minus e to the I negative theta over 2i? Or, yeah. Or e to the I alpha
E to the I alpha, then what?
minus e to the I negative alpha
Uh-huh,
over 2i.
exactly. And cosine alpha is what? Here we don't need
The
cosine alpha, but in general you should know.
e to the I alpha plus e to the I negative alpha over 2.
Yes, good. Okay, for this part, so let's focus on this part. Let's call this one, for example, t. T is equal to, and let's consider here alpha is equal to pi over 7, okay?
Okay.
So the first one is what? Is e to the I alpha, right?
Mm-hmm.
Over 2i to the 4th, right?
Yeah.
Plus e to the I2 alpha minus e to the negative I2 alpha to the 4th. And plus what? Last bracket is what?
Is plus e to the I 3 alpha minus e to the negative I 3 alpha over 2i to the 4.
The denominators are what if you raise to the power of 4?
16.
16. So, if we answer 16 here and 16 here, we cancel each other out, right?
Yeah. So 7.
So we should calculate 7 times this part for 2 alpha and for 3 alpha, right?
Mm-hmm.
So let's call this one W, okay?
Okay.
Now you should raise to the power of 4 and try to simplify. Want more hint or that's enough?
I mean, I can try to simplify it now.
Okay.
I don't think I reached the correct answer, but it simplified a lot though.
Okay, so I want to try together.
Yeah. I ended up reaching that W was 3, which is not, can't be right. But...
W, look, if we raise e to the what alpha is 1.
E to the
I times what alpha is 1.
14.
Yes. And e to the I7 alpha is what?
E to the I7 alpha is -1.
Exactly. So, if we raise the first one to the power of 4, it is e to the I4 alpha, right?
Yeah, I wrote it as e to the I4 alpha minus 4e I to the 2 alpha plus 6 minus 4 over e to the I2 alpha plus 1 over e to the I4 alpha. I wrote it this way.
Yes, plus 4 ei2 alpha plus
Negative.
ei4 alpha, right?
Or should it be negative? And
Yeah, sorry, negative, right?
but shouldn't the negative sign also be on the right?
Yes, such. Minus plus, right?
Yeah.
Okay, ei, then for 2 alpha, you should consider 8 alpha, right?
Yeah, the same thing.
Yes, then you say 3, 6 minus 2, 4 alpha. Plus 6 minus 4 e to the negative I4 alpha plus e to the negative I8 alpha, right?
Mm-hmm. And same for the VA.
And then we should multiply these by 3. I times 12 alpha minus 4 times ei. 6 alpha plus 6 minus 4e negative I6 alpha plus e negative I12 alpha, right?
Yeah, and then I add these.
Okay, now let's change all of them to plus, okay? So at first let's simplify. E to the negative 4 alpha is equal to e to the 10 alpha, right?
Yeah, can I go over my solution to figure out where I went wrong?
Okay, sure. What's yours?
I mean, I just, when I have negative 3 e to the I4 alpha and negative 3 over e to the I4 alpha, and then,
Let me check. This one and this one?
Yeah, e to the...
You said negative 3e to the I4 alpha, and then what?
Minus 3 to the e, minus 3e I4, negative 4 I alpha.
Negative 3e to the negative I4 alpha, yes. Then what?
And then that's equal to 2 cosine 4 alpha, right?
You want to change it to cosine?
Yeah,
so
cosine.
It's negative 3 times 2, negative 6 cosine 4 alpha. You said this?
Yeah.
Okay, then what?
And then there's, I just keep doing this for all of these terms. So there's
and in the end, could you simplify these trigonometric terms?
Yeah, but in the end, I reach negative 6 cosine 2a plus cosine 4a plus cosine 6a, which is simplifiable, but I didn't get the right answer, so I'm trying to figure out where I went wrong.
So at the end, you couldn't simplify costs, right?
I could simplify it to a number, but it wasn't the correct number.
Okay, so let's check. This one then, what about next part is considered again 2 alpha?
Yeah, negative 4e I2 alpha, and there's a negative 4e to the negative I2 alpha.
Okay.
And that gives me...
E to the negative I2 alpha, right?
Yeah, so this is negative 8 cosine 2 alpha.
Yes. And what?
And there's e to the I 8 alpha plus 1 over e to the I alpha becomes 2 cosine 8 alpha.
Can you say again you consider which terms?
Oh, wait. There's an... Oh, I think I know why. Okay, wait, please give me a second. 18, 20. Oh, never mind. I did it correctly. Okay. It's because I forgot about the 18. Okay, yeah.
So we have 118 if we consider these 3 sixes,
yeah,
right?
okay, that's That's why I didn't get the right answer. If I consider the 18, I got the right answer. Okay, so
Then you reach the correct answer.
yes, I got the right answer.
Okay. So if you reach correct answer, so your solution is correct. Want me to tell you what's my solution for?
Sure. Yeah.
Okay. So here I tried. Let me copy this one. In these things, when we have some of, for example, some terms, you can use Vieta's formula. Okay. Usually Vieta's formula can be used. So here, if you want to change all of them to plus, we know e to the I 14 alpha is 1. So you have e to the I4 alpha is 2 alpha. This one is, do you agree we can change this to 12 alpha?
Yeah.
This one is I10 alpha, right? This one is I6 alpha. This one is I10 alpha again. And this one is I8 alpha. This one is I2 alpha, right?
Yeah.
Okay, how many I2? So let's consider similar terms. First one, so we have 18, 3 times 8, we consider all these terms. Then e to the I2 alpha. We have this part and this part, right?
Mm-hmm.
So negative 3 e to the I2 alpha, I agree.
Yeah.
Okay, then for 4 alpha, ei4 alpha, 6 alpha, 10 alpha, 4 alpha, and these two terms. So negative 3 e to the I4 alpha. Then for 6 alpha, we have what? We have this part and this part, right?
Mm-hmm.
So it's negative 3 e to the I6 alpha. What about 8 alpha? E to
alpha.
the 8 alpha
Negative.
and this one. Negative 3 e to the 8 I8 alpha, right?
Yeah.
What about e to the I10 alpha? We have this part
It's also negative 3.
and this part, negative 3. For all of them, as we can see, we have negative. For 12, let me write it 3. E to the I12, and this one again, negative 3. E to the I12 alpha, and finish, right? We consider all terms.
Mm-hmm.
So it's 18 minus 3, e to the I2 alpha, plus e to the I4 alpha, plus e to the I6 alpha, plus e to the I8 alpha, plus e to the I10 alpha, plus e to the I12 alpha. Okay, so
Yep.
here, because we have some of all, for example, most of the terms, except
The
e
unit
to the
circle.
I odd alpha, right?
Yeah, so then x plus 1 is equal to 0. So x equals negative 1.
What is equal to 0?
If I were to add 1 to this term, the sum would be 0.
Yes, why?
Because they're just the roots of unity, you know.
Look, these roots are, we know alpha was what? Pi over 7, right?
Yeah.
So 2 alpha, if you consider this, and we know x to the 14 equals 1, all these numbers are root of that, right?
Yeah.
But do you agree these numbers are also roots of x to the 7 minus equals 1? Because we know e to the I alpha is root of this. So e to the I2 alpha is root of this, right?
Yeah.
So how many roots do we have? 1, 2, 3, 4, 5, 6. So if you consider plus 1 by Vieta's formula, it will be 0, right?
Yeah.
Because
So-
here the roots are 1, e to the I2 alpha, to e to the I12 alpha. So sum of the roots is 0.
Yeah, so it's negative
So
1.
this part is negative 1, right?
Yeah, so it becomes 21.
So it's 21. And that will be 21. 7 times 21 is what?
147.
Right?
Yeah.
Have you heard pi?
No.
Pi is principle of inclusion and exclusion. So let's draw a Venn diagram. Suppose A3 are multiples of 3, A4 are multiples of 4, A5 multiples of 5. Let me show them with numbers 3, 4, 5, 6, 7. Can you tell me this means which regions here?
So, this means like 2, but not 5.
Yes, 2 is good. What else?
Oh, 1 and 3.
1 is good, 3 is good. So we should calculate these regions, right?
Mm-hmm.
Okay, so let's start from easier parts. First, let's solve this problem, but instead of at first, if we didn't have this, suppose it says, or let's concept 4. Only, for example, suppose the problem says find multiples of 4. So the answer is what?
So you would do like all the integers from 1 to 2001 that are multiples of 4.
Yes, it is equal to what?
500.
Yes, 2001 divided by 4. And you should round down this, okay? So, from 1 to n, number of multiples of a is equal to n over a, log of n over a, okay? Now, suppose that, let's make it harder. Suppose that we didn't have only this. Means how many numbers from 1 to 2001 are multiples of 3 or 4? Calculate this.
I got 1034.
1034. Okay, can you explain?
Yeah. So I found the multiples of 3 not exceeding and then multiples of 4 not exceeding. And because they overlapped the ones that are multiples of 12,
Exactly.
I did
So we should subtract 2001 over
12.
Exactly. Now it will be correct, right? Number of elements in A union B is number of elements of A plus number of elements of B minus what?
Minus the overlap.
Yes, intersection. Have you seen this formula before?
I think so, yeah.
Okay, we call it pi, principle of inclusion and exclusion. Okay, but this is for 2 subsets. For 3 subsets, 4 subsets also we have this. Okay, so if we calculate it, 2001 over 3 is what? 667, right? Plus
Yeah.
500, 2001 over 12 is what? Is 180, 672, 81, 6. Right? So 667 minus that is 1, 0, 6 minus 1, 5, plus 500, which is 1001. So I have careless mistake or you have careless mistake?
I think I did 2001 divided by 12 wrong.
So let's check it again. 82. Okay. Now, okay, in the next step, we want to subtract this. So, in the previous one, if you pay attention to the Venn diagram, it was A3 and A4. We've calculated this part. Then we've calculated this part. So we've calculated the intersection twice, so we subtracted this once. Then we've calculated all parts once, right?
Yep.
Okay. Now here, let's see how we can calculate this part. Okay. So we've learned here how we can calculate A3, A4, right?
Uh-huh.
If we use same formula, then we have these parts, right?
Yeah.
Agree. So we know the red part is 1001, right?
Mhm.
Now, if we subtract this part, so can you tell me green region is what? Is what over what?
It's it has the so it's divisible by 3
Yes.
and 5. The region where it's divisible by 3 and 5, which is 15.
Yeah, so what over what?
So 2001 over 15.
Exactly, over 15. Now, if we subtract this, then red parts will be cancelled here, right? Then we should subtract also this part. Can you tell me pink region is what? What over what?
2001 over 20.
Exactly. So we can say that the answer is 1001 minus green region. We want to reach this part at the end. Minus pink region, but we should do something else here. Can you tell me we should do what here?
Minus the intersection with all of them.
Plus intersection of all of them, right? Because look, we have this red region. We subtracted green, we subtracted pink. So we subtracted this region twice, right? We should subtract it only once. So we should add black region, right?
Mm-hmm.
Okay, can you tell me black region is what over what?
Is 2001 over 60.
Yes, so now you can calculate the answer, right?
Yeah.
Okay, so calculate.
I got 801.
801 districts. Okay, so let's calculate. 2001 over 15 is 153, 51, 3. For the pink one, you can say 2000 over 20, which is what? Which is 100. For the black part, you can say 200 over 6 or 100 over 3 is 33, right?
Yeah.
So 1001 minus 133 minus 100 plus 33, right?
Mm-hmm.
So 1001 minus 200, which is 801. Good job. It is choice. AB times CD is what in terms of x and y?
Just x times y.
Good job. Then we have trapezoid. It's good to draw what?
Like draw the trapezoid.
In trapezoid, it's good to draw altitudes. Okay.
Oh. Okay.
I can say in 90% of the problems related to trapezoid, also in AMC 2022, in all exams, most of the problems with trapezoid, we should draw perpendicular. We should draw altitudes. So can you tell me, let's call this one EBE is what?
E
is 7.
Good job. EC is what in terms of x and y?
It's y minus x.
Good job. Now want more hint or that's enough?
I think that's good.
Okay, so try the rest.
Can I use like the Pythagorean theorem to like?
Exactly, you should use Pythagorean theorem. Can you tell me what squared is equal to what squared plus what squared?
So 7 squared is equal to y minus x squared.
No.
No, 7 squared plus y minus x squared is equal to x plus y squared.
Exactly. So let's expand them. So 7 squared is what?
49.
Y minus x squared is what?
Y squared minus 2xy plus x squared.
Exactly. On the right hand side, x plus y whole squared is what?
X squared plus y squared plus 2xy.
Yes. Now we can cancel what from both sides?
X squared and y squared.
So 49 is equal to what?
49 is equal to also the 49 is equal to 4xy.
Then what?
Oh, then xy is equal to 49 over 4.
So which choice is correct?
B.
Yes. Because you can say 48 over 4 is 12, 1 is left, 1 over 4 is 2.2, right?
Mm-hmm.
Okay, understand completely how to solve this?
Yeah.
Okay, so let me put a black box around this, because you should do always in trapezoids. Okay, what's your next question?
Wait, like what are the equations that include W? Or
And look, because all rows and all columns, all diagonals are equal, we can use 2 of them to find W. You should see you should use which 2 of them.
So 25 plus W plus X is equal to V.
Yes, but in this case we have lots of variables, right?
Yeah.
So try to use 2 of them that you can calculate W quickly in one step. And as a hint, you shouldn't use diagonal, only use rows and columns. One hint?
Yeah, sure.
Okay, look, if we consider this row and this column, do you agree we can cancel V because V is in both of them?
Yeah.
So sum of these two should be equal to sum of these two, right?
Uh-huh.
So we can say W plus 24 is what plus what?
Is 18 plus 25.
Exactly, so W is what?
So W would be if you 17.
W is what?
17.
No. Try again. Yeah, careless.
Oh, 19.
Exactly. W is 19. So now we can plug in 19 for W. Okay, so let's see how we can find which of them quickly. Again, if you consider a good row and a good column, you can find x is what? So try to see exactly similar to the way that we found w. You can write one equation like this that contains only x and you can find x. Try.
Okay.
Want me to tell you which row and which column, or want to find it on your own?
Would it be like also including v? Like, is it 18 plus 25 is equal to x plus 21?
X plus?
X plus 21 is equal to 18 plus 25.
This one. Yes. My solution was different, but this one is correct. Yes, so x is what?
So x is 22.
X is what?
So x is 22.
Exactly. So, let me tell you, I wanted to consider what? Because we found w, I wanted to use this one and this one. Then x plus 18 is 19 plus 21, right? Understand what I consider this one? And this one. Then you can cancel y, and because we found w, so 19 plus 21, because we can cancel y in both of them. So 21 plus 19 is equal to x plus 18, right?
Yeah.
Okay, so x is 40 minus this, which is 20. Okay, good job. X is 22. Now let me check that we can calculate what here. Now try to find z is what, okay?
Okay. Is it 20?
Z is 20. Okay, let's check. You consider which two parts?
I did 25 plus 22 plus 19 is equal to z plus 22 plus 24.
You use this. Again, my solution is different. I consider this column and this row. No. This column and this row, then you will cancel z. Okay, so this part had problem. Yes. So it doesn't work. This one. So 19 plus 22 is equal to z plus 21. So it is 1, z is 20. Good job. Now we found z20. We want y plus z. Let's see, can we find y? Yes, we can find y. Try to find y.
I got 26.
26, okay. So look here, when we calculate this, for example, we can consider this column is, for example, equal to something, then you can calculate all of them. Or for finding y, we can say, okay, this one is equal to this one, right? You consider this or other things.
I did that one.
Okay, so y plus 18 is 24 plus 20, right? So you said y is what?
26.
So the answer is what?
46.
Good job. Now, so we solved this. We found also y is 26. We don't need to find v, but let's calculate. So v is what?
Five.
V is 5, yes. Because 5 plus 9. You said V is 5?
Yeah.
Why?
So I did V 8 plus 18 plus 25 is equal to 20. Wait, no. V plus 25 is equal to 22 plus 26.
Yes.
Wait, so it's 23.
So V is what?
23.
Exactly, 20. Or we can consider this one and this one. 22, 20, 19, and V, 23. So we solve this. What's your next question? Look, for this one, let's consider for the blue. If we consider, for example, H1 and R1, okay? And for this cone, H2, R2. What's the relationship? So let's work on this part. From this part, with its diameter, this what can we write in terms of an equation?
So 2R1 is equal to H2.
H1, right?
Oh, okay. Yeah.
Okay. Now it says a cone has diameter 10 and altitude 12. So R2 is what?
So R2 is 5 and H2 is 12.
Exactly. And it says find the radius of the cylinder. So we should find what?
R1.
Yes. Do you know cross section means what?
I think I've heard of it, but
Cross section, look, working with 3D is harder than working with 2 dimensions, right? Usually
yeah.
3D is harder than 2D. So if we want to change 3D to 2D, we should see, for example, from one side. We can see from top or we can see from the front. And then it will be a cross section because when you see from the front, it will be like 2D, right? The red figure will be what if you see from the front?
From the, like, this angle, it's like a triangle and then...
Exactly, it will be a triangle, right? And can you tell me the cylinder will be what if you see from the front?
Is it like a rectangle?
Exactly, good job. It will be a rectangle. Now that we know it's a rectangle, so this one is a rectangle. And okay, so let's calculate these things. If I draw a height from this one is A, for example, this one is B, this one is C, this one is D, this one is E. This one, for example, is F. AF is what?
AF is H2 is 12.
Exactly. BF is equal to FC is equal to what?
5.
5. So let's consider this one L. DL is equal to LE is equal to what?
Is equal to R1.
And LF is equal to what?
H1.
LF, this one.
LF is H1.
Exactly, it's equal to H1 and H1 is what in terms of R1?
2R1.
Exactly. Okay. So now you don't need to focus on this part, only focus on this 2D figure on this triangle. And you should find R1 is what, okay? One hint for finding R1 here or want to try on your own?
I'll try.
Okay, sure.
Would there be any other like relation between like H1? I mean,
You should use
H2
similar
and
triangles. If you use similar triangles, you can easily solve. Want more hint or that's enough?
I think that's good. Would N be half of BF? Like BN is half of BF?
And can you tell me which triangles here are similar?
Triangle DBN and triangle ECM.
DBN and ECM, yes, they are. We can say
And
that also. For example, ABC also, we can say similar to what larger triangle?
ADE.
Exactly, AD. So if you write the ratios, what over what is what over what is what over what?
So AB over BC is
AB over BC. No, look. AB over BC is all of them from one of them. It is only for when we have one equation useful. When we have two equations of three fractions, you should say, okay, from ABC, what corresponds to ADE? Okay. So, for example, AB corresponds to what? In AD. AD, good job. Then what over what?
Then BC over DE.
BC over DE, good job. What else?
And then AC and AE.
Oh. Now if you plug in, and also we can say another thing, what over what. Yeah, given two triangles are similar, the ratio of their heights are equal.
Yeah,
so the sides. And because here, look, we have AL and, for example, LF and these things, so it is what over what?
H1 over H2.
Exactly, AF over AL, or H2. No, not H2, because H2, look, is this one. It is AF H1 over H1 minus H2, this one, right?
Yeah.
Okay, so let's plug in all things that we have AB, AD, and this one. We don't have these things, but BC, we can plug in these things. BC is what?
BC is 12. No, it's 10.
Yes, it's 10. D is what?
Which DE is R 2R1.
Yes.
Which is equal to H1.
2R1 or H1. Because we want to find R1, let's write all things in terms of R1, okay?
Okay.
And then AF over AL. AF over AL is what over what? In terms of R1.
12 over 12 minus H1.
H1, yes. In terms of R1 will be what?
2R1?
Exactly. So these two fractions are equal. Now you can find R1, right? Okay, so calculate R1.
Is R1 equal to 30 over 11?
30 over 11 B. Okay, let's check. 10 over R1 is 5 over R. 10 over 2R1. 5 over these. 12 over that is 6 over 6 minus R1. If we cross multiply 30 minus 5 R1 is 6 R1. So 11 R1 is 30. So R1 is 30 over 11. Good job. What's your next question? Semicircle gamma has diameter AB of length 14. Circle omega lies tangent to AB at the point P and intersect gamma at point Q and R. Okay, so let's see. Semicircle, diameter AB. Length 14. Circle, omega, tangent to AB at point P and intersect gamma, points Q and R. Okay, so it will be something like this. It is A, it is B, it is Q, it is R, right?
Yeah.
QPR is this one. QPR is 60. And QR, it says also the length of QR. And then we should solve the problem. So let me minimize it. So this one is 60. And we should calculate area of PQR. Okay. So the diameter of this circle is 14. Is a 7, right? The radius, right?
The radius is 7.
Okay, so it is 60. We want to find, and this one we know is 3 root 3. So suppose, for example, let's consider this one R1, this one R2. We can easily say R2 is what I told you the formula before. Calculate R2.
Is R2 the small radius?
Yes, radius of this circle.
Yeah, okay, I'm just drawing the diagram. So the little radius is 3.
Radius is 3. Okay, let's check. Do you remember the formula was what? R is what over what?
I don't know what kind of like thing
I
this is.
told
though.
you A over 2 sine A. Do you remember these?
I know this, but I don't. I know this,
So
but this
3
is
root
like
3.
circles.
A was the side and 2 sine this angle. 2 sine 6. Okay? So 3 root 3 over root 3, which is 3. Okay?
Mm-hmm.
Understood?
Yeah.
Okay, so R2 is 3. Now it's good because we found the radius of these two circles. And both of these two, usually how I told you when we have two circles that intersect each other, draw this line always. I think I told you, right?
Yeah.
And this line, the name of this line is what?
The radical axis.
Exactly, radical axis. And this line has lots of properties. You can relate the angles. And one important thing is that O1, O2, what's the relationship between O1, O2 and this line?
It's a perpendicular bisector.
Exactly, perpendicular bisector. So if we consider this center and this center, because now we have radius, and these two centers lies on perpendicular bisector of this, and because it is tangent, if you consider center of this O2, can you tell me O2 lies on what?
O2 lies on what?
Look here, let me copy it.
I mean,
Okay.
so perpendicular to
So if we raise these things, we know that if we connect O1 and O2, perpendicular bisector O2 lies on it. And if we consider perpendicular to this, we reach O2. O2 is the intersection of these 2 points, right?
Yeah.
Okay, and now we know lots of things. O2P is what?
O2P is 3.
Exactly, O2P is 3. For example, here, MR is what?
MR is MR. MR is that point. Okay, yeah. MR is 3 root 3 over 2.
Exactly. So O1M, calculate. We want to calculate all lengths that we can. O1R is what?
O1R. Wait a second. Okay, O1R is Pythagorean theorem. So
No. O1R. You don't need to apply any theorem.
that O1. 7.
7. Let's calculate length as much as we can. O1M is what?
O1M is 7 squared minus MR squared. Pythagorean theorem.
927 over 4, right?
Yeah.
So it will be what?
But I can't hear you if you're saying something. So it's 13 over 2.
13 over 2. 4 times 49 is what?
196
minus 27 over 4. 196 minus 27 is 9. 169 over 4, which is 13 over 2, right?
Yeah.
Okay, so we found O1M. O1, O2 on. O1, O2 is what? Can we calculate O1, O2?
O1, O2.
We can calculate O1, O2. Try.
Yeah. It's 5.
Okay, let's check. First, we should calculate O2M, right?
Yeah.
For O2M, it is the square root of O2R squared, which is 3 squared, which is 9, minus 9 times 327 over 4, right? So 36 minus 27 is 3 over 2, O2M. So O1, O2. O1M is what? 13 over 2 minus 3 over 2, which is 10 over 2, 5, right?
Yeah.
Okay, so we found O1, O2, O2M, O2P, all these things. Now try to see area of QPR is what here, okay?
Okay.
Try.
Okay, I solved it with coordinates. I don't probably a better way to solve it.
And you've reached what?
99 root 3 over 20 is 122.
This one?
Yeah.
Okay, can you explain?
I just set P to the origin. I set O1 to 40. And
Yes.
then O2 to 03.
Okay, so let me
I
write. O1P is 0, right?
Yep.
Because O1P, have you calculated O1P? No, but we can calculate. It is O1, O2 squared 25 minus O2P squared 3, it is 4.
It's a 3,
So
4,
because
5,
this length is 4, O1 is 40. Then what? O2 you said is 0.3. What else?
So the slope of O1M is negative 3 over 4.
Let me write. The slope is negative 3 over 4. Yes. Then what?
And then the slope of QR is 4 over 3.
Yes.
So now I just want to find what M is. So I know that O1M is 13 over 2.
Yes.
So now I just do 3 over 4 and 4 over 5. So I find that M is negative 12 over 10, 39 over 10.
Negative 12 over 10, 39 over
10.
Okay.
That's
Yeah,
M.
we can write the equation of this line because we have O1 and this. And you can write also, we know this one is 13. One equation and also this slope is 4 over 2. Yes. Then what?
Yeah, So now I have a point and a slope of QR. So I write y equals 4 over 3.
And
X
you have
plus 12
also
over
this
10.
length, so you can find Q and R. Then you use shoelace theorem, right?
No, I didn't use shoelace theorem. I just found the distance from QR to P, and then I
Use this one. Because when you find equation of QR, you can use the distance on this one, right?
Yeah.
And when you find M, you have a slope, you can write the equation of this line, and you can only find the distance, right?
Yeah.
Okay, good job. And look, we can also do exactly the same thing because we know the distance of, we know this length QR, and because we want to find area, so we have to find this distance, right?
Mm-hmm.
P to this. So for example, PM, we want to find PM. Agreed?
Yeah.
But because we have O to M, so we can draw perpendicular because we have these parts, right? We can call it L. So we want to find Pn is what? Pn is equal to PL plus NL. NL is what?
MO2.
NL is MO2. MO2 is what?
3 over 2.
Yes, MO2 here we found is 3 over 2. So PL plus 3 over 2. So if you find PL, the problem will be solved, right?
Yeah.
So this one is 90, 90, 90, 90. So if this angle is alpha, this angle is what?
Which angle?
This angle. If this one is alpha, this one is what?
90 minus alpha.
So this angle is what?
Alpha.
Exactly. So do you agree these two triangles are similar?
Yeah.
So we can find PL. PL corresponds to what?
O2P.
Alpha O2P, and we know the radius. So here we know what O2L is better, or LP. LP we said O2P is good. O2P corresponds to what?
O1, O2.
Exactly. So we can find PL. O2P is what?
3.
And here O2P again 3. O1, O2 is what?
5.
So PL is what?
9 over 5.
So Pn is what?
9 over 5 plus 3 over 2 is 33 over 10.
Yeah, so the area is 33 over 10 times half of the base, right?
Times 3 with 3 over 2.
3 with 3 over 2. What is the area? It's 99 with 3 over 20, so 23, 1, 2. Okay.
25.
25 of this year.
Yeah. Of 12.
Okay.
Yeah.
So let me. The vertices V of a centrally symmetric hexagon in the complex plane are given by okay, this. Okay, it is not regular necessarily, but symmetric central. Okay. Now we have these vertices for each j from 1 to 12. The element zj is chosen from V at random, independently of the other choices. Let PVBs be the product of the 12 numbers selected. What's the probability that P is -1? Okay, so for each j, an element zj is chosen from V. Okay, so we should find some product, okay? This times this is what, for example, some products are good. And let's do something. Because we have product, look, in all complex numbers. When you see product, it's good to do what I think I told you this before.
When you see product,
When you see product in complex numbers, the first thing that you should think about is what?
Like e to the I theta?
Exactly, polar form, okay? Have you used polar form for this problem?
I tried.
Okay, so let's check. So let's write in polar form. First one is what?
Let's just go to square root of 2 e to the negative pi.
E to the negative pi? No.
Or e to the pi. Or e to the pi over 2.
I pi over 2, right?
Yeah, e to the I pi over 2.
Exactly. What about this one?
Square root of 2 e to the I
Negative
3
I
pi
pi
over
over 2. Okay.
Negative pi over 2.
What about this one?
So 1 over 4 times e to the I pi over 4.
Yes, it's what? E to the
I pi over 4 times divided by 4.
oh, divided by 4? No.
It's not square root of 8 and square root of 2. What?
Look, it is the square root of 8. This one is the square root of 2. When you divide, is the square root of 4 is 2. Okay.
What?
Understood or wrong?
Okay. Yeah. It's on the top. Okay.
Okay. What about this
one? 1 over 2 e to the 3 pi over 4.
E to the 3 pi I 3 pi 4 over 2, right?
Yeah.
This one is what?
It's like the same thing. So 1 over 2 e to the I negative pi over 4.
E to the negative I pi over 4 over 2, right?
Yeah.
And this one is what?
1 over 2 e to the 5 over or negative 3 pi 4 over 4i.
Over 2, right?
Mm-hmm.
Okay, so here we should see, okay, the product should be -1, right?
Yep.
So we have two parts to check. One part is the length, right? The product of the length should be what? These lengths.
Just 1.
It should be 1. So these two are same. So if we select, for example, A from here, B from here, how many A's do we have? How many B's do we have?
8 and 4.
A is what?
8.
A is 8, B is 4.
Yeah.
Okay, so because it's 2 root 2 to the 8, 2 to the 4 here, 2 to the 4 there, we cancel. So we should select 8 from here. When you want to find the probability, the denominator is what total number of cases?
6 to the 12.
6 to the 12. Now we want to calculate number of good cases, right?
Mm-hmm.
So for calculating number of good cases, we should select 8 from here. 4 from here, it is the length. Now you should focus on the angle. One more essay and then solve the problem. Want hint or want to try the rest on your own?
I will try it.
Okay, sure.
I got E.
You got E.
Yeah.
This one.
Yeah.
Okay, let's work on the angles. What can we say about these angles and how many from each of them?
Well, it's 8 and 4. So first thing I did was I kind of like simplified it by dividing by pi over 4. So it's like easier for me to know what's going on.
You've divided by pi over 4. So then
I'm like kind of like keeping
2,
it count
negative 2,
2, and then 1, negative
1, 1, negative 1, 3, negative.
Yeah.
So plus minus 1 plus minus 2, plus minus 3. Then what?
Yeah. So I reasoned that after you, so there's 12 choose 4 first of all for the, what's it called, like where like your A's will go and where your B's will go.
You can say 2 pi k over pi over 4 is what? What times k?
What? 8.
8k. So the sum should be multiple of 8, right?
Yeah.
So then what?
Okay, no, but what I said is that after you pick your 8 from the A's, so 2 to the 8, and then if you pick 3 from the 4 B's, so that's 4 to the 3. So then you have one more pick, but then this count will always be an odd number. So
We know we have 8 here and 4 here, right?
Yeah.
Okay. Then what you said?
So after you pick 8 from 8 A's and 3 B's, then there's one more that will result in either 4 or negative 4 as the final count. Because it will always be on an odd number, right?
4 here.
Also,
so here we have it is even.
Also, you didn't write it correctly. It's plus 2. Plus 2 is 8. 1 and 3 are 4.
Look, this one you agree. Sorry. For 2 and negative 2, we have 8, right?
Yeah.
Yeah.
So
sorry.
after
Plus
8 of those,
we have 8.
After 8 of those, it'll be an even number. And after 3 of 1 and 3, which are both odd numbers, you'll have an odd number now. So you'll either be a 1, 3, negative 1, or negative 3 on the unit circle, which means that either you can just add one more will bring it back to negative 4 or positive 4, which is what we want.
So how many cases?
2 to the 8 times 4 to the 3.
2 to the 8 times 4 to the 2. So here you say it is not important.
4 to the 3.
4 to the 3.
4 to the 3.
So you say it is not important that here we select plus 2 or negative 2, right?
Yeah.
After 8 steps, it will be multiple of 4, right?
I don't know about multiple. Yeah.
But it is not necessarily multiple of 8, right?
Yeah. Why did you saying multiple of 8?
Because 7 times 2.
Can you draw the unit circle on there? Can you draw the unit circle for me so I can explain this?
Unit circle?
Can you draw the unit circle so I can explain to you what I mean? And divide it into eighths. So like, yeah.
Look,
so
here, for example, if we select 7, positive 2, and 1, negative 2, it is 12. It is multiple of 4, but not multiple of 8, right?
Yeah, but it doesn't matter because, so I call the positive x-axis part 0, and then I go 1, 2, 3, and then 4, going around the unit circle that way. And on the bottom, it's negative 1, negative 2, negative 3, negative 4.
Let me just quickly check when it is multiple of 8. 1, 3, negative 1, negative 3.
The count needs to be
A minus B plus 3C minus 3B. For example, it should be multiple of 8. And A plus B plus C plus D is 4. So how many cases do we have?
I want to explain what I did.
Like, for example, this one is W plus minus 3 is T. We know that it should be multiple of 4. Because this one is multiple of 4. This one also should be multiple of 4.
Yeah, but I'm saying after you... So once you've picked 2 to the 8 and 4 to the 3, once you've picked those 11 terms, there's exactly one... The 12th term, there's exactly one term that will bring it to the negative pi, or to the pi place. To the pi part.
No, only work with the numbers. It will be so much easier to work with numbers than pi.
I'm trying to.
Right?
No, yeah, that's what I'm saying. I'm trying to explain to you. Can you label the?
Uh-huh.
Can you label
So,
the?
for example, do you agree
municipal
plus
coefficient?
1 and minus 3? They are congruent mod 4?
Yeah.
So
Wait, I
do you
want to
agree if
explain
we
what
have
I
C
did.
here, we have D here, they are same mod 4. And C minus D should be multiple of 4, right? So C and D should be equal mod 4. So because C and D should be congruent mod 4, we can say what? We can say, okay. So here, plus minus 1 minus 3, minus 1 plus 3. We select 4 from them. Do you agree that we can select 2 from here, 2 from here, or 0 from here, 4 from here, or 0 from here, 4 from here? Agree?
Okay. You're not like listening to me.
The thing you are saying, if this one is correct, I think you mean 2 to the 8 and 4 cubed, then one number is left. Then you say exactly, yes. You say exactly one of, because all of them are different mod 4. Let me check. Different mod 8. Why you say the last one is always good?
Because when you have 2 to the 8, the plus 2 minus 2, when you have 8 of them, that's will result in an even number.
It is
And
odd.
when you have
It is odd because it will be 8k plus 1, 8k plus 3, 8k plus 5, 8k plus 7. If it is 1, you add
after
negative
11 of
1.
them. After
If it
11
is
of them,
3,
it will be
negative
odd.
3,
Yeah.
if it is by plus 3, if it is 7 plus 1. So always you have exactly one case to select this. So last one is times 1. Yes, with this raise. Understood how I explain or want me to explain?
Yeah, that's what I've been saying.
Like you said for the first 8 cases, you said 2 to the 8, all of them. Then for the next 3 numbers, 4 cubed, then the result is odd. So mod 8, it can be 1, 3, 5, 7. If it is 1, you add negative 1. For all cases, you have exactly one choice. So the last choice is unique. It is 1, right?
That's what I was saying.
Okay, good job. Completely correct. So it will be 2 to the 8 times 4 cubed. If we divide, it will be 2 to the 6, 2 to the 14. And it will be 2 squared over 3 to the 12, right? Let me check. Do we have these in the choices? Oh, it says negative 1, negative 1. So it shouldn't be 8k. It should be 2 pi k plus pi, right? The angle should be here. So when you divide, it is 8k plus 4, right?
Yeah. What are you talking
So here I think it would be same again because when it is plus 1, you should change it to 8k plus 4. You add 3. For this one, you add 1. For this one, you add 8k plus 4, negative 1, negative 3, right? Again, do you agree you have one choice only for the last one?
Yeah. That was my whole reason.
So why the answer is not in the choices?
You have to divide it by 6 to the 12. You have to multiply by 12, choose 8, and then divide by 6 to the 12.
8 times this.
There's a 12 choose 4.
No, because we said 2. Let me check. We said 2. Yes. Multiply by 12, choose 8. Each of them, then 2 to the 8, 4 cubed, over 6 to the 12, right?
Yeah.
Then let's simplify this. Okay, 12 choose 8 is 12, 11, 10, 9, over 4, 3, 2, times 2 to the 14, 2 to the 12, 3 to the 12. So 2 to the 12 here, 2 squared, 2 squared 4, then 12 times 11 times 10 times 9, over 3 to the 13 times 2. Agreed?
Mm-hmm.
So 2 times, we can cancel these 2, it will be 6. So 1, 3, 3, 3, 3 to the 10.
Yeah.
Then 2 times 2 is 4 times 11 times 5, right?
Yeah.
4 times 11 times 5. 4 times 11 times 5, 3,000. Yes, good job, complete. Right. Okay, so what part was hard? You didn't solve these because you solved most of the parts on your own. Which part you had problem?
Probably I had problems with the angle parts, just like writing the angles and.
Have you considered polar form for the first time you wanted to solve?
I considered it, but I didn't think it all the way through.
Okay, so when you see product, you should consider only in polar form. E to the what? The length is what? Okay, it can be useful. 90% of the cases. So, what's your next question?
2017 12A 24.
2017 12A 24. Let me open. Okay, quadrilateral ABCD is inscribed in circle O and has side length AB3, this one, the 8. So 2, 3, 2, 6, 8. So 3, 2, 6, 8. Something like this. And A, B. Let X and Y be points on BD. Okay. dx over bd is 1/4. So let's consider this something like this. And by over bd 11 over 36 is around 1/3. So it will be something like this. Let E be the intersection of line AX and the line through Y. Okay. So this one, let me E be the intersection of line AX and the line through Y parallel to AD. Okay. So let's here. It is FB intersection of the CX. Okay. CX and the line through E parallel to AC. So it will be something like this. AC, AC. We call it F. And it says let G be the point on circle O other than C that lies on the line CX. It is G. What is XF? Okay, so look, this one is parallel to this one, right? This line is also parallel to this one. So here we want to find XF times XG. So when you see product in geometry, what are important rules that you can use?
Power of a point, because there's a
power of a point. What else?
Power of a point, maybe Siva's. No, Siva's.
The next case is a special case of power of point is a special case of that. The proof of power of point is by what?
I don't remember.
Similar triangle.
Oh, okay.
So if you want to prove power of a point, similar triangles, and when you cross multiply, you have product, right? At first, you have division, right?
Yeah.
Okay, so similar triangles is the background idea of also power of a point. So when you have product, 90% of the cases, triangles can be useful. And because we have parallel lines here, So we can write some similar triangles. Also, we have cyclic quadrilateral. So let's list all similar triangles, and let me call this one. We didn't have P, I think, the points. Okay, so let's call this. Can you tell me what are the similar triangles here?
Triangle AXC is similar to triangle FXE.
Exact. CA corresponds to what?
FE.
FE. CX corresponds to what?
XE.
Because this angle is equal to this angle, so you can say X. And AX corresponds to what?
FX.
Yeah. Another similar triangle. And look, XF we have here, it's good. But we don't have X, right? So also we should work on X. And so what else? What is the next similar triangle that we can write?
AXD. Similar to triangle.
D
EX.
similar to XYE, right?
Is that the right order? EXY.
Yes, XYE or EXY.
Right.
Then let's try it again. AD corresponds to what?
E corresponds to EY.
Yes. XD corresponds to what?
EXY.
And XA corresponds to what?
EX.
XA. Let me check it again. Here. This
You didn't write the angles in the right order, so
check here. CX. CX is opposite to this one. So opposite to this one, CX is X.
with the angle.
So here XF.
What?
Agreed.
Why?
Because look, CX is opposite to what? This angle, right? Because these two lines are parallel, this angle is equal to this angle. CX is opposite to this one is XF, not XC. Agreed?
AXC and oh, okay. XD over XY equals XA over XE. Yeah, okay.
So XA corresponds to what?
XE.
XA corresponds to, yes, XE. Okay, so here we found something for XF, but still we have problem for working with the other length, right?
Mm-hmm.
So what should we do here to find, for example, something for XG here? We have some relationship for XG. Can you tell me XG times what is what times what?
XG times XC is equal to XD times XB.
Exactly. So we have something for XG, for XF also. We can use this part is equal to this, or this part is equal to this, right?
Yeah.
Here we have CX, here we have XC. Oh, so much good, because XF over XC is equal to EX over AX, right?
Yeah.
So if we multiply, do you agree we can cancel XC?
Yeah.
So XF times XG is equal to what? XD, XB, EX, AX, right?
Yeah.
Okay, so now you said what?
Where did the X? Wait, what did you substitute? What was the substitution?
Look, do you agree this part?
Yeah.
Do you agree this equation?
Yeah.
Do you agree we can consider reciprocal on both sides?
Yeah.
So if we use reciprocal, do you agree we will reach this?
So you said xc equals
No, I didn't
AE
say
times-
xc equals. I consider only reciprocal of both sides. We will reach.
Okay. Yeah.
Then I multiply. Why I did this? Because I don't like xc. I said, okay, we have xc here, we have xc here. But if I consider reciprocal and then multiply, we can cancel xc. Then it will be xg, except the thing that we want, right?
Yeah.
Then you should multiply this xc, xb, ex, ax, right?
Yeah.
Okay, now we should calculate these parts. All things related to x, right? X, let's write xe, ax, xd, ex, and what else? xb. And one good thing. Do you agree xd, xd, and this one, and xb, they are related to each other, right? We can change these two variables to one variable, right? Because we should remove variables to reach the number, right?
Yeah.
And then we have xe and ax. Then, for example, we should see, okay, if we find ratio and, for example, similar triangles, one thing, do you agree here, for example, we have xt over xy. So we can find this is equal to what number, right?
XD and XY.
Yes, because look, it says the relationship here, the relationship here. You can find this one, right?
Yeah.
So try to find this and try to see, can you simplify this to reach a number? Try. If you couldn't, let me know to give you this, okay?
Okay. Okay, I got 17.
17 for what? For the question mark?
For the answer, yeah.
Okay, so because we know dx is equal to bd over 4, right?
Yeah.
And by
I called BD P.
is equal to bd over 4, so xy bd times 11 over 36, right?
Yeah, I just called BD equal to P.
Equal
for
to?
simplicity. P over 4. I just said it's equal to P over 4.
Okay, P over 4. So P over 4. So 11P over 36. Here we can also say 9P over 36, right?
Yeah.
And XY is what? Is 20, 16P over 36, right?
Yep.
Okay. So because here it says XD is 9 over 36 over 16 over 36. 9 over 16, right?
Yeah, so EX over X, 16 over 9.
Okay, so here we found this relationship. In these parts, CA, so we know AD, EY, XE, for example. XE, AX, right?
Mm-hmm.
So XA is better than XE, I agree, because E, you created this one, but AX is better. So XF times XG. So XE over AX is what? 16 over 9, right?
Yep.
XD, XB.
Yep.
So it is 16 over 9. XD is what? 9P over 36.
P over 4. Yeah, okay. P
Yes,
over
or
4
P over
times 3
4.
P
Yes,
over 4.
yes. P
Times
over
3P
4,
over 4.
XP is
3P over 4.
yes, 3P over 4.
Yep.
So
now you
it
got
will
P
be
squared.
4 for
P
this.
squared over 3.
P squared over 3. So the only thing you should find is length of BD, right?
Mm-hmm. Mm-hmm.
Okay, so here I think we can erase all these things, right?
Yeah.
So here, this one, BD is P. And this one is 3, this one is 2, this one is 6, 8, right?
Yeah.
3, 2, 6, 8. Okay, so and this one 11, 36. So you should find P is what, and then this. Want hint or want to try this on your own?
I already solved this.
Okay, so your answer, how you calculated this?
I use law of cosines.
For this one and this one, right?
Yeah.
Okay. So here you said this cosine is 2 squared plus 6 squared minus P squared over 2 times 2 times 6, right? Is equal to 3 squared plus 8 squared minus P squared over 2 times 3 times 8, right?
Yeah.
Then you can cancel 2, 2, 2, 6, 3, 4. Here is 2. 3, 3, right? So 4 plus 36 is what? Is 40. 9 plus 64 is what?
73.
Yes. So 2 times 40 is 80 minus 2p squared. Agreed.
Yeah.
Is equal to 73 minus p squared. So 80 minus 73 is 7. 2p squared minus p squared.
No, that's not right. What?
You said what?
That's not, no. Why is p squared? How'd you get p squared equals 7?
So let's check it again.
Can we just write it normally? So 73 minus 48 cosine theta is equal to 40 plus 24 cosine theta. Cosine theta equals 11 over 24. So 73 minus 48 times 11 over 24.
One thing. Sorry.
It's 51.
Here, negative of that because the cosine is negative.
Okay, yeah.
So if we cross multiply, it will be 80 minus 2p squared is equal to negative 73 plus p squared, right?
Okay.
So 153 is equal to 3p squared. Agreed?
Yeah.
So p squared is 51. So p squared over 3 is 7, right?
Yeah.
Okay, so the answer is 17 choice, right?
Yeah.
Okay, good job. This is this problem, right?
Yeah.
Okay, it says a set of n people participate in an online video basketball tournament. Each person may be a member of any number of 5-player teams, but no teams may have exactly the same 5 members. Okay, so you have n people. Team members 1, 2, for example, T. Each of them is connected to 5, 1, 2, 3, 4, 5, and no teams may have exactly the same 5 members. The site statistics show how previous fact the average over all subsets of size 9 of the set of n participants of the number of complete teams whose members are among those entities stroke of the average over. On this part, let's see, it means what? Over all subset of size 8 of the set of these of the number of complete teams whose members are among these 8. So how many? Okay, let's understand this 9 the average over all subsets of size 9 of the set of n participants.
Yeah.
Of the number of complete teams whose members are among those 9 people. Okay, so it says the average. So for each 9 elements here, you should see how many teams are connected to all these 9, right? So let's see here, from here to this part, this red part. How can we write it in terms of n? In terms of n and t, for example.
I'm not sure because I don't get this.
Look, it is double counting. So look, it says, for example, we can say all 9 people here. 1 to 9, then 1, 2, 3, 8, 10, right? 1, 2,
Okay.
3, for example, 8, 11, right?
Mhm.
All the way to, for example, n minus. It will be n minus, because 9, n minus 8, n minus 7, all the way to n, right?
Mhm.
And for each of them, do you agree? We see, okay, how many teams, all 5 members? For example, we calculate the teams that all 5 members are among these people, right?
Mhm.
So, for example, you say it is A1, A2, last one is A what? A sub what?
A's of and choose 9.
Exactly. And now can you tell me the average in terms of AI is what?
Wait, I don't get what it says average. The average of what?
So look, the average of these. Here, for example, we have 2 teams that all members are among these 9 people, okay? We have 2
Okay.
teams. So you say A1 is 2. A2, for example, is 0. A3 is 4. So you add all of them and divide by number of them, it will be the average. Understood?
Yeah. Okay.
Okay, so the average will be what here? Average 1.
A1 plus A2 all the way to A9 or A n choose 9 divided by n choose 9.
Exactly. And now you can say A1 to AN in terms of T and N. So try to see, can you figure out it is what in terms of T and N?
What is T equal to?
Number of teams. The problem says number of teams or what? It doesn't say, right?
No.
Because we don't know number of teams, so we call it T. Okay?
Mm-hmm. Oh, is it T times n minus 5 choose 4?
Okay, so can you say it again?
T multiplied by n minus 5 choose 4.
You
Is the
should
number of
multiply
sub
by. Let me just sorry, 1 second.
number of or this is average number.
Okay. Now
Or
let me write
divided by
something right. So the numerator is T times what choose what?
n minus 5 choose 4.
Exactly.
Divided
Over
by
and choose 9.
N choose 9.
Right?
Okay. Yep.
Okay, now that you found this, the next one is equal to the reciprocal of the average over all subsets of size 8 of the set of n participants of the number of complete teams. Okay, so the next one is exactly for 8, but you should consider reciprocal of that. And then you can solve it easily. Want hint or want to try the rest on your own?
I'll give it a try.
Okay, sure.
No, I got T is equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 2 to the 5 times 3 squared times 5 times 7, but I don't know how to solve, like figure out how many values of
Okay, so let's
there are.
check. Here we know that T times n minus 5 choose 4 over n choose 9 is equal to n choose 8 over what?
Over T times n minus 5 choose 3.
Exactly. So we can T squared, we can write this. Okay, so if we simplify T squared times n minus 5 factorial, or let's write this right here. T squared times n minus 5, n minus 6, n minus 7, n minus 8 over 4 factorial times n minus 5, n minus 6, n minus 7 over 3 factorial is equal to n times n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7, n minus 8, right? N minus for this one,
Yeah.
for n, you can write until this part, and we can say this whole square times n minus 8, right?
Yeah.
All over 9 factorial. Then you simplify this, right?
Yeah.
N minus 5, n minus 5, we can cancel. N minus 6, n minus 6, n minus 7, these we can cancel. And n minus 8 also, we can cancel these. So t squared is equal to 4 factorial, 3 factorial over 9 factorial times n minus 1 times n minus 2 times n minus 3 times n minus 4 whole squared, right? You reach this.
I had an 8 factorial on the denominator, so.
So then you've simplified this, the numerator
Well,
and the denominator.
Isn't there an n choose 8? So there should be an 8 factorial.
Sorry. We have also 8 factorial, right?
Yeah, and simplify. Yeah.
Okay, and it is exactly the thing you've reached.
Yeah, and I simplified the.
Okay.
I decomposed the fraction.
Okay, great. So because it is t squared, we can cancel these two, and if you simplify these, 4 factorial is 5, 6, 7, 8. 3 factorial is 4, 5, 6, 7, 8, 9, right?
I'm not sure what you're writing here.
Look, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9. So let's simplify. When we want to consider t, we can say 1 over 3. So we use this 8. So for 3, let's do something. Here,
I noticed.
let's prime factorize to make it easier.
Yeah, I prime factorized it.
2, you say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 to the 10. Times 3, it is the 3, 1, 2, 3, 4. 3 to the 4th. For 5, 5 squared, right? For 7, 7 squared, finished, right?
Yeah.
So t is 1 over, or let's write like this, n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 2 to the 5 times 3 squared times 5 times 7. I agree.
Yeah.
Okay, then what? You've reached until this part?
Yeah, this is what I reached. I don't know how to
Okay,
continue.
so look, pay attention to this one. It is n minus 1, n minus 2, n minus 3, n minus 4. It depends on let's see, the problem wants what? How many values of n from this can be the number of participants. So this one should be integer, right?
Yeah.
We should see for how many n it is integer, right? And let's see the choices. Okay. For how many values of n at least 92,070. Okay. So because look, we have 5 consecutive numbers. We can relate t to what?
Mods. Choose function. What is, I don't know.
We can relate it to what? Choose what?
N choose 5.
Yes, but the denominator of n choose 5 is what?
Well, it's n factorial over, or just so 5 factorial in this case.
It is n choose 5 over what?
Wait. Okay, wait, you're confusing me. So over 5, no, it should be times 5 factorial divided by 2 to the 5 times 3 squared times 5 times 7.
Yes. N choose 5. Because we have 4 times 2, 8. Right? 32 is 4. Times 3, right?
What happened to the 5?
Let me check. No. It is over 4.
Why are you dividing?
Because it has denominator, you want to reach this.
Okay. Take it one step at a time. Just n choose 5 is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 5 factorial.
Over this denominator. But we want to reach this denominator.
I know, but I'm taking it like one step at a time first. So so it's n times n minus 1 times n minus 2 times n minus 3 times n minus 4 is equal to n choose 5 times 5 factorial, right? So that we...
Yes, times 5 factorial over this. Now I want to simplify this one.
I know, but I'm writing it one step at a time.
Okay, so if we write 4 times 8, 32. It is 9, 3, 5, we have 7. Agreed?
Yeah.
Well, let's see. We have some denominators. So let's focus on these things. We know 32 divides n times n minus 1 times n minus 2 times n minus 3 times n minus 4, right?
Yeah.
Also, we can say, let me write it for 9, 5, 7. From here, n can be what mod 7?
0, 1, 2, 3, and 4.
For n mod 5 is what? All of them will be okay, always.
Yeah.
Right?
Yeah.
What about this one?
0, 1, 2, 3.
Let's say mod 9. Mod 9.
6, 7. 0, 1, 2, 3, 4, 6, 7.
Look, 0 to 4 is good, obviously. 5 is good because 5, 5 minus 1, 5 minus 2, 3. 5 is bad, right?
Yeah, that's what I said.
6 is good because this one has 1, 3, this one has 1, 3. 7.
7 is good.
7 minus 1, 6, 7 minus 4, 3. 7 is good. 8.
Not good.
Not good. Okay, 5 and 8 are bad. So let's write only bad numbers. Here also we can write bad numbers. 5 and 6, right? For this one, n mod 32 should be what?
First, I have to find, just like list out all the residues.
We should check it.
What do you mean? So I should look through all of them, you mean?
Yes, because if we calculate them, then we can find n mod what number?
32 times 9 times 5 times 7.
No, not times 5, because for 5 all of them are good, right? We don't need to focus on this,
Okay.
right? So 7 times 9 times 32 is what? 7 times this is what?
Yeah, I'm calculating it. It's 2016.
Yes, 2016, right? So the problem says n is from 9 to 2017, right?
Mm-hmm.
Right?
Yeah.
So each combination is a number from 0 to 2015, right?
2015?
2015, because we should calculate mod 26. Look, for example, if we select 0 here and 1 here and, for example, 2 here, then this combination is exactly a unique number from 1 to 2016. Agreed?
Yeah.
So if we find how many cases do we have, you should only multiply them, and only you should check 1 to 8 to see how many of them are in 1 to 8 and also 2017. Okay?
Okay.
And the agree 1 and 2017 are same.
Yeah.
So because we don't have 1 but we have 2017, so you need to only check 2 to 8 because we don't have these numbers. If these numbers satisfy these, then we should subtract it from number of cases. Okay?
Okay.
So the only thing you should do is now to see how many numbers from 0 to 31 are good. Okay? So
Just
for this
passing
one,
it.
how many good numbers are there for this one?
5
For this one,
and 7.
so the answer is 5 times 7 times the question mark minus number of cases from 2 to 8. Okay? That satisfied you. Understood?
Yeah.
Okay, so you should now find the question mark, how many cases do we have here? And then find this question mark. You should calculate these two question marks to find the answer. Try it.
So I got 557.
557?
Yeah.
This choice D, right? Let me erase this. Let me. Okay, so here for 32, the cases that are good, the 0, 1, 2, 3, 4 are good, right?
Yeah.
5 is good or not?
No.
Because here we have 4, here we have 2, only we have. So 6 is good or not?
No. I don't
6,
want to list out every
6
single one
minus
again.
2, 6 minus. So if you check, tell me the numbers that are good.
What'd you say?
Tell me all numbers that are good 0 to 4. Then next one is what?
0 to 4. Then it's 8, 10, 12, 16, 17, 18, 19, 20, 24, 26, 28, 32.
Okay. So 32 is 0, right?
Oh yeah, 32 is 0.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the first question mark is 16, right?
Mm-hmm.
And now we want to see from 2 to 8 how many numbers satisfy these things to subtract. 2, 3, 4, 5, 6, 7, 8. So let's use first this one. N shouldn't be 5 or 8 mod 9. So 5 is bad, 8 is bad, right?
Yeah.
N shouldn't be 5 or 6, so 6 is bad. Now they satisfy these. Then N is 2, 2 is good, 3, 3 is good, 4 is good, 7 is not good. So 3 numbers here satisfy this, right?
Yeah.
So we should subtract 3.
Mm-hmm.
Now 5 times
Wait, so
60, 80, 560 minus 3, 557. You said what?
why don't you need to subtract for 2017? Or do we need to consider the 2017 number itself?
Look here, when we multiply these, it means that from 1 to 2016, we have these numbers that are good, right?
Yeah.
560 from 1 to 2016. Okay?
Yeah.
Okay. But the range of the problem is not 1 to 2016. It says 9 to 2017. Okay?
Mm-hmm.
So 1 is similar to 2017. So that's okay. But from 2 to 8, we don't calculate 2 to 8.
What do you mean? What? Okay, yeah, 1 is similar to 2017, but we don't need to consider it.
So let me look. From 1 to 2016, we have 560 numbers that are good. Agreed here.
Yeah. Yeah.
But we shouldn't consider this range. Look, let me 1, 2, 3, 4.
So are you
5.
saying? Are you saying you like basically move 1 to you turn 1 into 2017, and you basically don't need to make a change then?
Yes, here when we have 560 numbers that are good, we agree here also we have 560 numbers that are good.
Is that
because 1 is exactly similar to 27.
Okay, yeah.
So here we have 270 numbers that are good. But the problem says consider only from 9 to 2070. We found that 2 is good, 3 is good, 4 is good. So when here we have 560 numbers that are good, here we have 3 less, 557 numbers that are good. Okay?
Okay.
Okay, so the answer. What's your next question?
Negative
2018 over 2019,
2018
right?
over 2019.
Okay, now try to see, for example, we can check 0 for all of them. For 0, it's for positive numbers, all of them are positive, right? Try to use this method, see can you find a better choice, okay?
Okay, so they all have a root between 0 and -1, but I don't know how to analyze it from there.
We should analyze which part?
From -1 to 0.
Yes, for example, for 0, all of them are positive, right? Positive 1.
Yeah.
What about -1?
Then they're all like negative. They're all what's it called? Negative numbers.
For negative, it's negative. For -1, it's negative. For -1, it's negative. For -1, it's negative. And for 0, it's positive, right?
Yeah.
Positive 1, positive 1, positive 1, positive 1. So for all of them, we have a root between 0 and 1, right?
Yeah.
Okay. Now, can you tell me in the next step we can check what?
Check what? I don't know.
Look, yeah, when we want to check negative 218 over 219 is near what number?
-1.
Yes, and larger than -1, right?
Yeah.
Okay, now we want to see the problem says maximum root. So we should check here, right?
Yeah.
Agreed. So if we check this number, for example, if we check 1/2, what can we say? So look, for negative, all of them are negative, and for this one, positive, right?
Mm-hmm.
If we check 1/2, it's what? This one is positive or negative for 1/2?
Which one?
First one.
Positive. For -1/2.
For -1/2.
Oh, positive.
It's positive.
Actually, yeah. It's 2048. I think it's still positive.
So if it is positive, then we have a better root. We have a better root or not, we don't know. Because he is still here, we have something, right?
Yeah.
For -1/2, can we say for any of them it's negative or not? But we agree if we increase -1/2, it is near 0, right?
Mm-hmm.
So if you want to find negative, if you make -1/2, for example, to the left, something like that, we agree for this. Let's consider this value, okay? So let me write this one as R. for R, can you say it's positive or negative? I said,
Right.
suppose this one is R. Can you tell me for the first one, R is what? For R, it's positive or negative?
Negative.
Yes. So if you consider choice A and choice E, which one has greater root?
A.
A. So we can reject E, right?
Yeah.
Okay. Now also we can check, for example, if they are increasing or decreasing. How can we check, for example, these choices are increasing or decreasing?
Well, we can look at, because B is similar to.
So for example, one way, if possible, you can check derivative. Or one way, look, we rejected E. Then you can, for example, check this one and this one, or this one, this one. Two choices. Try to see, can you reject any of the choices? Okay.
I think you can do like this. So A and B have the same x to 11 coefficient, but since A is x to 19 and x is between 0 and -1, A is going to be always above B in that interval. And if A is above B, that means when B has a root, A is above that. Yeah, so A has a lesser root than B.
A is less than. Why you said A? Okay, so here when we want to check A and B, we should see x to 19 is greater or x to 17, right? Because it is negative when you divide, for example, this has a sign. When you divide by x to the 17, it is 1, it is x squared, but this sign is different from this. You know, it is less than this, so it is greater than this, so A is greater than this. So we can reject which choice, A or B?
We can reject A.
Yes, because look, when it is above and you want to find x intersect, it is A, it is B. B is better. So you can reject A. You can reject another choice similar to this idea.
So now we reject C.
We can reject C exactly because again they are same, only x19, x is C. Now between B and D, you should find the choice, right?
So D is above B, so B is the answer.
B is above B. Okay, so let's check. For B and D, you should check 2018 x to the 11 and 2018 x to the 13. So if it has a sign, so we can switch this. And it would be 1x squared. This one is smaller, this one is greater. It is B, B is less than B. Here, here, E is better. Great. So the answer. Understand completely?
Yeah.
So degree at most 3. So we can say ax cubed plus bx squared plus cx plus e. It is p of x, right?
Yeah.
Yeah, -1 is negative a plus b minus c plus e. Or we can say b plus d minus a plus c is what? Is -9. So what part is hard that it plus? We should consider casework. This one is at most what?
18.
So if it is 18, this one should be what?
27.
And it's not possible, right?
Yeah.
So let's consider maximum of this one. If this one is 18, this one is what? Should be what?
Should be 9.
Exact. What's the next case that we should check?
10 and 17.
10, 17? Pay attention.
Or what's it called? 10 or 8 and 17.
8 and 17, right?
Yeah.
7 and 16. All the way to what?
All the way to 0 and 9.
Yes, I should calculate them. Want more hint or that's enough?
That's enough.
Okay.
It's 220. I don't know why I didn't know to do this.
You reached 220?
Yeah.
Okay. For this one, how many cases for 9 are there?
10.
10 times for 18.
1.
What about 17?
9 and 2.
7.
8 and 3.
And this one?
1 and 10.
Exactly. Okay, and you calculated all of them, right?
Yeah.
Okay, 10 times 1 is... Look, you can calculate all of them, but let me tell you, maybe instead of 10 it was 100, right?
Yeah.
Here it's good, you can calculate quickly, you don't need to use formula, but sometimes it's 100, you can write it as sigma I times what in terms of I from 10 to 1.
11 minus I.
Exactly, so you say 11I is 11 times 10 times 11 over 2, right? Minus I squared. The formula of 1 squared to 10 squared is what?
N times n plus 1 times 2n plus whatever 6. So
Exactly.
10 times 11 times 20.
So here we can say 5. Here we can say 7, 5. So we can factor from 55. It will be 11. In these things, usually you can factorize and make it smaller, okay? Like this. So 11 minus 7, it's 4. And it's 220, right?
Uh-huh.
If suppose we have 4 people, okay, or we have 4 students, you want to split them into 2 groups. One group with 1 member, one group with 3 members. How many ways are there?
4?
Exactly, 4. If you want to split them into 2 groups, each as 2 members, then it will be what?
Are the groups like distinct?
They don't have name.
So 3.
Exactly. 4 choose 2 over 2, right?
Yeah.
If we have 6 students and we want to split to 3 groups, each has 2 members, it will be what?
Is 6 choose 2 times 4 choose 2 over 3 factorial?
Exactly. Okay, so you know the idea. Now that you know this, if we split n squared students into n groups, each has n members. First one, second one to nth one. So, and let's try to write it only in terms of factorials. Okay, try to simplify at the end, and you can write it in terms of factorials only. Try.
I don't know if I'm doing this right. I go like n squared factorial over n factorial to the n times n factorial.
N factorial to the n. Can say it again. It's what over what?
I'm kind of confused. Wait, n squared factorial divided by n factorial to the n times n factorial.
So it will be n factorial to the n plus 1, right?
Yeah.
Let me say, explain for you how you can calculate quickly.
And there needs to be another n factorial.
Let me calculate to make sure. Over n times 2n choose n and then n choose n, right?
Yeah.
All over what?
N factorial. There should be another n I think there's there's another n factorial in the
We can
expression
check.
thing.
Let me check.
Okay.
I don't think, because look, for each of them, one n factorial, look, let me tell you another way. You say n squared factorial, n factorial because of permutation of this one, so n factorial to the n. Because of the order, also n factorial. I think this one is correct. So let's see. n squared factorial, n factorial, n squared minus n factorial, n squared minus n factorial, times n factorial, n squared minus 2n factorial, right? Times n squared minus 2n factorial, n factorial, n squared minus 3n factorial, 2n factorial, n factorial, n factorial, and n factorial, n factorial, 0 factorial, okay? So you can see that we can cancel terms like these, second term, this one. So the numerator is n squared factorial, and the denominator we have n fractions, and also we have 1 over n factorial for the denominator of here, right? So now do you agree it will be n factorial to the n plus? N factorial. So it is n squared factorial or n factorial to the n plus, right? So we can conclude n factorial to the n plus 1 divides n squared factorial because we are calculating something, right? Number of ways to split. So this one is integer. So we can conclude this one divides this, right?
Yeah.
The key point of this problem, let me now copy the main problem. The problem is this, that this divides this. So try the rest.
$34 D
E.
D 34.
Okay, let's check here. We can say n squared minus 1 factorial over n factorial to the n is equal to n squared factorial n factorial to the n plus 1 times what? N factorial over n
factorial
right?
over n squared.
Exactly. If this one is an integer, then the problem will be solved, right?
Yeah.
And then it is integer. So if we check for 1 it's good, right? For 2 it's not good. For 3 not good. Obviously for primes it's bad, right?
Yeah.
For 4 is good or not?
It's good.
24 over 16 it's not good, right?
Oh yeah, it's not good. What?
5 prime not good. 6 it's good because you can write 6 as 6 and 2 3, right? So we can have 2 6s. So 6 is good, 7 we know is bad. For 8 it's good. Why? Because we can write 2 4 8, right? And if n is a composite number, you can say n is this times n if n is a, b, and a and b are. Let's if we can write it like this, right? Agreed?
Yeah.
So in this case, it's good. So we can write which numbers in this form. So what numbers are left to check?
Angle A, B, so like numbers like 3 times 4? No.
No, look,
wait,
3 times 4 is
prime.
12. You can write that 3, 4, 12.
Yeah.
These numbers are good. But there are some numbers that are left and we've not checked them yet.
What do you mean n equals AB? What do you mean 3 times 4 times 12?
Look, for example, we want to see is it integer or not. For 8, look, 8 factorial over 8 squared, right?
Yeah.
So when you write 8 factorial, it is 1, 2, 3, 4, 5, 6, 7, 8, right?
Yeah.
Over 8 squared. So look, 1 8 is the last one, this one. Also, we can say 2 times 4 is 8. So in this case, we have 2 8s, and it is okay. It is integer, right? Okay, I said if we can write n as AB, that A is strictly less than B, so you can say we can write AB n, and over n squared, it will be integer, right?
Yeah.
Okay, so we proved prime numbers are not possible, and these composite numbers are possible that we can write them like that. So there are some numbers that we've not checked them yet. What numbers are left?
210.
10 is similar to this. Look, 10 is 2, 5, and 10, right?
So what do you what? The squares?
A squares, for example, look, 36 is 3 times 12, also 36. Not all the squares.
So 49, the prime square.
49, prime squared. You cannot write prime squared like this, right?
Yeah.
So for prime squared, prove that this one is integer. Or for which prime squared is integer? Check this one for. N is p squared. We want to see n factorial over n squared is integer or not. Check it.
I mean, yeah, all of them work.
Except p2, right?
Except for p2.
So you should prove it. If p is at least 3, why this is integer? Try to prove it.
So you can write it as p squared factorial over p to the 4, and you can simplify that to p squared minus 1 factorial over p squared. So then you just need to prove that p squared minus p and p squared minus 2p are terms that are greater than 0. So p squared greater than 2p gives p greater than 2. So for p greater than 2, it works.
Exactly. Or you can say p 2p, right?
Yeah.
P squared. If you prove p and 2p are strictly less than p squared, the problem will be solved, right?
Yeah.
2p less than p squared is equivalent and p is greater than 2, right?
Yeah.
So for all numbers except for n primes, it will be good, right?
Mm-hmm.
So the numbers that are bad are what? 2, 3, 4, 5, 7, 9, 11, 13, 15, 17, 19, 20, 25, 29, 31, 35, 37, 39, 41, 43, 45, 47, 49 until all the way to 50. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 15 minus 16, 34. Good. So here again, look, we have powers. So when you have powers, it's good to write it as polar form. Have you written this as polar form?
E to the I pi over 4.
The I. Now we have z to the this, z to the this. So this is not hard. What's the problem you couldn't solve? 1 squared, 2 squared, 3 squared. You should find what of these numbers. These numbers mod what?
4.
Mod 4. Look, can you tell me z is equal to z to the what? The first number for the question mark is what?
1.
Yes, 1 is obvious. After 1, what's the first number?
5.
No. Look, let me show you. 1 is here, pi over 4, right? 2 is here, 3 is here, 4 is here, 5 is here. They are not equal, right?
Yeah. What's for pi over 4? Okay, so 9. E to the I pi over 4 e to the.
So 9. Z to the what is 1?
Z to the 8.
Yeah, so z to the 8 is 1. It has no effect. So we should calculate these powers mod what?
Mod 8.
Yes. Want more hint or that's enough?
I'll try.
Okay.
Okay, is it just 36?
Yeah, answer 36. Okay, let's check. Look, we know odd squared mod 8 is 1, right?
Yeah.
Okay, so how many odd numbers? We have 6 odd numbers, right? So we see. Then 4, 2 squared is what? Is 4, right?
Yeah.
So if it comes to mod 4, we divide by 3. So some of them will be similar to c to the 4. So how many? What's the coefficient of c to the 4?
3.
3. What's the coefficient of constant term?
3.
Exactly. Now here we have negative of these numbers, right?
Yeah, so 6
So we have
over
6
z.
over z plus 3 over z to the 4 and plus 3 again. Then what?
Yeah. Then z to the 4 is -1.
Z to the 4th is -1, right?
Yeah.
Okay. So it is 6z, you can cancel, right?
Yeah.
Also, you can cancel these two terms. Times 6 over z. So 36. Right?
Yeah.
Okay. So when we have centroids, what do we know about centroids? Remember, AG over GM was what?
2 to 1.
Exactly. We know something. And length of medians, all these things. PG squared, do you not remember PG squared was what?
What is p?
P was any point, any arbitrary point, and G was centroid. Have I told you this before?
From any point? No, I don't
Yes,
remember
P
this.
can be any point. It's 1/3 of PA squared plus PB squared plus PC squared minus 1 over 9A squared plus. How have I told you this before?
No.
Okay, after this problem, we will prove this. There are some ideas, some formulas about centroids, so let's apply. Let's check this one. It says ABCD convex quadrilateral. Centroids of 3 of the triangles 4. The vertices of an equilateral triangle. What's the maximum possible value of the area? Okay, A, B, C2. If we consider something like this. Let me make this one. Okay, so it is C. This one is B. This one is B. This one is A. It is 2. It is 6. Centroids of A, B, C. Okay, let's check. All of them that are related to C. ABC, CBD, ADC. So all 3 triangles that are related to C form versions of equilateral triangle. Okay. So can you tell me what's the property of these 3 centroids? It's good to consider what?
Property of these 3 centroids.
We should draw which new line. If you want to draw all medians, then we have lots of lines, right? And it's
Yeah.
hard to work. So we can only draw which medians.
I don't know which median is good to draw.
Look, which medians have a common point?
I mean, ABC, BCD. No. I mean, maybe from B.
From
Draw
B?
both medians.
But look,
Or
ACD doesn't have B.
Or C.
Exactly. Connect C. All centroids lie on medians of C, right?
Yeah.
You can connect these 3 lines, right?
Mm-hmm.
And the centroids are on this line, and we know the ratio is 2 to 1, right?
Yeah.
So for each of them, we connect 2 to 1. And because here, consider 2 to 1, here it says it is an equilateral triangle, right?
Yeah.
Now we want to see if here we have equilateral triangle, if we connect these 3, again, they are equilateral or not. Understood what I mean?
Wait, what?
Look, it is, for example, M, N, L. This one is G1, G2, G3, right?
Mm-hmm.
Then we know G1, G2, G3 is an equilateral triangle, right?
Yes.
Triangle. We want to see, can we prove that from these that M and L also is an equilateral triangle or not, okay?
Okay.
So try to see it's correct or not. If it's correct, try to prove it, okay? M and L are midpoints of these two sides at this diagonal, okay?
Yeah.
So try to...
Wait, but M and L is just a homotopy of G1, G2, G3 around C.
Exactly. Yes. So, and also we can say this one is parallel G1, G2. We know is parallel to MN, right?
Yeah.
Because all three sides are parallel, so the angles are same. So again, 60 degrees, right?
Yeah.
Okay, now we can remove centroids, and it is so much easier to work with if you work only with midpoints, right?
Maybe. Yeah.
It's because what G was a point intersection of medians, and we should draw medians. But here we don't need to draw new lines. It's only midpoints of the two sides and the diagonal, this diagonal, right?
Mm-hmm.
Okay, this one is equal to this one. This one is equal to this one. We know CD is 6, BC is 2, and also this one, 1, 2, 3 is equal to this. So now we know NLM is equilateral triangle, right?
Yeah.
So by using NLM, all angles are 60, all of them are equal, so try to find maximum area. Try.
Let's see.
C by C.
I mean, I just made it like a function. I set BCD to theta, and then I wrote the area as a function of theta, and I just took the derivative, and I got C.
So you found the area in terms of theta.
Yeah.
So the area of ABD in terms of theta is what?
So first I find first I know ABD is an equilateral triangle.
Exactly. Because
And then
this one is similar, okay? So this
I
is
find
length
BD.
is A, this length is A, this length is A. Then what?
So BD squared, I wrote it as 40 minus 2 times 2 times 6 cosine theta. So it's log.
BD squared is what? Can you say it again? Is
40
4
minus
plus 36, 40 minus 4 times 6, 24 cos theta. Then what?
then times square root of 3 over 4 is the area of ABD.
Okay, so A squared root 3 over 4, or we can say BD squared root 3 over 4, 40 minus 24 cos theta times root 3 over 4. Is this area plus 6
Plus 2
sine
times.
theta?
Yeah, 6 sine theta.
Then what?
I just take the derivative.
Okay, so if we take the derivative, so here 40, 10, 6. So it is f of theta. F prime is what?
F prime is 6 cosine theta plus 6 root 3 sine theta.
6 root 3 sine theta plus 6 cosine theta is 0. Then we can say what? We can divide both sides by 6.
You can say tangent theta equals negative 1 over root 3. So theta is 5 over 6. 5 pi over 6.
3 over 3. We know tangent 30 is 1 over root 3, so it's tan 150 or 5 pi over 6, right?
Yeah.
Okay, so here you can plug in, right? We can say f of 150 degrees equal to 10 minus 6. Cosine 150 is what?
Cosine 150 is negative root 3 over 2.
Root 3 sine theta is what?
1/2.
Exactly. Okay, so it will be 10 Root 3 is 3. 6 over 2 is 3. So we can say 10 plus 9, right?
Yeah.
Plus 3. Let's check it out. Sorry, 10 root 3 plus 9 plus 6. So it would be 12 plus 10 root. Okay, choice C, good job.
Going in order from backwards, 2019 B 22 and then 25.
2019 B. Okay, so let's see.
I think I'm like generally like struggling more with like complex number problems. Because sometimes.
Okay, so you can bring those problems and see how we can solve it logically.
Yeah. Okay, but these ones are not just 22, 25.
Ah, 22. I remember this problem. It is one of the hardest problem of it. I remember. So let's try first 22. 22 and 25 is that?
Yeah.
Okay. I don't remember 25, but I remember. Let's try this. See my screen?
Yep.
Okay, it says define a sequence recursively by x05 and xn plus 1. Is this for all non-negative integers? Let n be the least positive integer such that xn is this. So this is least positive integer, means after some m it will be smaller and smaller. In which of the following terms m lies? Okay, we don't want, it doesn't want us to find exact m, right?
Yeah.
So in these types of problems, do you know how we should start?
Usually I would like find a few terms and look for a pattern, but
Yes, one way is that, but also you should see, can we, for example, rearrange these in many problems like this? This one can be useful. But for example, you rearrange and you will find a better recursive sequence, okay?
okay.
Have you, for example, it is xn plus 6. This one, you can factorize this one. It is what? The numerator?
xn plus 1, xn plus 4.
Exactly. xn plus 1, xn plus 4, and xn plus 6, right?
Yeah.
It is equal to xn plus 1. So can we, for example, use changing variables or something like this? And here, look, here you can say this one is equivalent, that xn minus 4 is less than or equal to what?
1 over 2 to the power of 20.
Exactly. Now, for example, can we define it as ym and find a better formula?
So
So in this
yn
case,
equals xn minus 4.
yes. So xn plus 1 will be what? Ym plus 1 plus 4, right?
Yeah, ym plus 5. Yeah, so ym plus 1.
Next one is ym plus 10, right?
Yeah.
Ym plus
5.
5, ym plus 8, right?
Yeah.
So can we simplify this? Can simplify? It will be good. Or can we, for example, find a better formula in terms of these things? This ym plus 10, for example, and divide by 2 or something like that. If we can find a better formula, then it will be so much easier to work. So if we want to rearrange this, can we reach a better value or not?
Oh, what do you mean better? What would be better?
For example, look, if we want to calculate, we can take this 4 to right side, right?
Yeah.
And if we use common denominator, then we can say what? Because 4ym, so it is ym squared plus 13ym plus 40. So we can cancel this 40. Minus 4ym minus 40, right?
Mm-hmm.
So
So
you
ym
can
squared
cancel.
plus
It will be a
9ym.
bit better. Plus 9m, right?
Yeah, ym squared plus 9ym over ym plus 10.
Yes. In this one here, we had 4, but by this case, that we subtracted This one is a bit better, and you can say ym plus 1 is ym times ym plus 9 over ym plus 10, right?
Mm-hmm.
And we want to see for which m, the least m that is less than or equal 1 over 2 to the 20, right?
Yeah.
Okay, so here, let's calculate, let's use the most useful idea can be what?
A small example.
Exactly, a small example. So how can we apply a small example here?
Just like on M, just like finding the first terms.
Yes, so here look, y0 is what?
1.
So y0 is 1. y1 is what?
10 over 11.
Here look, if it's instead of 9 it was 10, it was so much good, right?
Yeah.
So we agree instead of 9 you can write 10 minus 1, then it would be ym minus ym over ym plus 10, right?
Ym times ym plus 10 minus ym. Ym plus, yeah.
Okay, so y1, as you said, is 1 minus, you can also factor ym 1 minus, or you can use this one. 1 times 10 over 11 is 10 over 11, right?
Yeah.
So we want to find the least that is less than or equal to this. So it means it is when it says find the least that is less than or equal to this, it means it seems to be increasing or decreasing.
It's like decreasing and approaches 4.
Yeah, because it says least that is this for some value. You said 4? You said what 4?
Or xm approaches 4.
xm approaches 4. Here ym is near 0, right?
Yeah, ym approaches 0.
So first one is 1. This one is a smaller than 1, right?
Yeah.
So decreasing. Next one. And next one is what? It's 10 over 11 times 10 over 11 plus 9. It is 99 plus 10, 109, right? Over 11 ym plus 10. So it would be 10 over 11 plus 10, 110 plus 10.
120 over 11.
Over 11. So we can cancel. It will be what? We can cancel this one. 109 over 11 times 12, right?
Is there another 11 on the bottom?
11 here.
Wait. Oh. Oh, yeah.
Agreed?
Yeah.
It is y2. Check it. y2 is greater or y1?
Y1 is times 12. Well, 1 is greater.
Yes. So it is decreasing, and we should see the growth rate, or here decrease rate is what? Here, as you can see, we can subtract ym plus 1 minus ym. Because it is decreasing, let's say ym minus ym plus 1 is equal to ym over ym plus 10, right?
Mm-hmm.
So it is, for example, 1 to this one. When we reach from 1 to 10, 11, the difference is 1 over 11, right? Unlike this. So you can find the difference is around what? And we know ym is less than 1. That's not equal to 1. So, let me ask you something. y0 is 1, y1 is 1. When we decrease ym, the whole fraction will be decreased or will be increased?
When you decrease ym, it will decrease.
It will decrease the difference, right?
Yeah.
Okay. Can we find, for example, so this one is decreased and we don't know how small is it. If you write it as product, ym plus 1, here look, because we want to consider the two consecutive terms, one way is to subtract, one way is to divide, right?
Yeah.
It is 1 over ym plus 10. For this one, we can say this, because it is decreased, it is less than 1 over 10, right?
Mm-hmm.
Because the difference is decreased, so look, it is something like this. Decrease, then decrease, then decrease, then decrease. So we cannot say after how many steps it will be less than 1 over 2. Right? But for this one, the ratio, we can say this one is less than what, greater than what?
Less than 1. I'm not.
1 minus 1 over 10. The first
It's less.
y0 is 1.
Less.
So 1 minus
Be
1
less
over
than-
11, right? And let me check. If you decrease this, it means that you will increase this, right?
Yeah.
When you increase this, it means that you are decreasing this. So it is maximum happens when this one is 1, right?
Yeah.
It is 10 over 11. And minimum is what? Try to find minimum.
Oh, because aren't you subtracting?
No, at first I subtracted, then I divided. I checked both of them. For subtraction, because this ratio will be smaller and smaller and smaller, so cannot reach spatial thing, right?
Because when ym is a bigger number, isn't 1 minus 1 over ym plus 10 a larger number too?
Look, if you prove y is decreasing, then you increase ym, the denominator will be increased. Decreased, increased. So when ym is maximum, this one is max, right?
Yeah.
Okay, now find the upper bound.
Or the lower bound?
This one.
Yeah, okay. 9 over 10.
9 over 10, you consider ym is positive always, right?
Yeah.
So you should prove. Try to prove why ym is always positive.
I'm not sure to prove that ym is positive, other than assuming that assuming xm is greater than equal to 4.
It is so much easier to prove ym is positive. So much easier.
Is it? How? Is xm is greater than or equal to 4?
No. Don't focus on x. Focus only on y.
Okay. Can I just say ym plus 1 will always converges to like 0, so therefore from the positive side, so it's always like positive.
What do you mean?
Because ym plus 1 is equal to ym squared plus 9ym over ym plus 10, and since y0 is a positive number, so is all these terms in this expression.
If you use induction, ym is positive, this one positive, positive. So ym plus 1 is positive.
Yeah, basically.
Yes, so now we can say it's correct. And for one side, we can say it can be also equal. Which side?
The right side, the less than sign.
Yes. Okay. So because we could find a ratio of y0, we know is 1, right?
Yeah.
So by considering this, we can say ym plus 1 is greater than what, less than or equal to what? You should find a number, fraction in terms of m. Use only this one, and y0 is 1.
Not in terms of ym.
No, in terms of m only. These two question marks. Only use this one.
So ym is ym is greater than 9/10 to the m plus 1 times y0.
Ym plus 1.
Yeah.
Yes, or so we can say also ym is what we want to write for ym.
Okay, ym is greater than 9/10 to the m times
Yes.
y0.
Y0 is what?
1.
Yes, so we can ignore that. And less than or equal what?
10/11 to the m.
Exactly. So these are similar numbers near to close numbers. We want to find for which ym it is less than 1/2 to the 20, right?
Mm-hmm.
So we want to find 10/11 to the m. What's the minimum m? That it is less than 1/2 to the 20, right?
Yeah.
And we don't need to find m is exactly what. If you prove, for example, if m is for example in this range and we have this, we can satisfy this, then that m is good. For example, m greater than something, less than something. One thing for this part, want to try on your own. Okay, so let's use some small example. If m is 2, it is 100/121, right?
Yeah.
It is for m2. For m3, it will be what?
1000/1331.
1331, right?
Yeah.
We want to find something to find a better, for example, say, okay, it is less than, for example, 1/3. Okay, something like this. So, for which m, so let's try to do something. Let's try to reach 1/2 at least, okay? So this one is greater than 1/2. This one is a smaller, but it's still greater than 1/2, right? Agreed? Okay, so if m is 4, we can say it's what? 10,000/11 times this, right?
I don't know what you're saying right now.
Can you hear
I can't
me?
hear what you're saying right now. You're very.
Can you hear me? Let me change my.
You're lagging, I think.
Okay, so let me
Sounds
change
very
my
light.
name. Thank you. Okay, so I've changed my name. Is my audio better now? Is my audio better now? Hello? Can you hear me?
Yeah.
Okay, is my audio
Hello.
clear?
It's not that clear.
What about now? Is it better now or still not clear?
It's okay now.
Oh, okay. So 10,000, the denominator, I understood it here. What? If you find something less than 1/2, it will be good, right? Because then we can raise to the power of 20, right?
Yeah.
Okay, for M4, these two are greater than 1/2. For M4, it's 10,000/1 over what?
14641.
Yes, we can write this twice. So 1641. Okay. It is still greater than 1/2, right?
Yeah.
For M5, it will be what? 100,000 over what?
Is it 1/5? This is 1/5. There's a lot of carry now.
This one, right?
Yeah.
Okay, so this is still greater than 1, right?
Yeah.
So let's keep writing M6 10 to the 6 over this one.
Let me check. 1651711.
Look, but this one is so much better than this. Let's keep checking. M7 10 to the 7 over. We should write this twice. 1771561. 1771561. So it will be, let's write 17167 8 14 8 9 1. Now it is around 1/2, right?
Yeah, it's a little more than. Wait. Yeah, it's still a little more
It
than.
is still greater than 1/2, but near 1/2, right?
Yeah.
Okay, so can you approximate M is what?
Like 140.
You should multiply 1 by 20, 1 for around that number. But look, it is. Can you tell me which choice is good?
C.
Yes, and we agree 140 is not, for example, endpoints, right near the endpoints. Agreed?
Yeah.
If it was, for example, we had 140, then we should keep writing to find this exactly what. But because 140 is far from the two endpoints, we can say it's choice. Understood?
Yeah.
Okay. If you want to, for example, you can quickly find the answer like this, but if you want to, for example, make sure with more rigorous proof, here let's do something. Yeah, we prove. Let's if we calculate M8, if you want to prove. For M8, it is 10 to the 8, and we can write this twice, right? 194877171 1948771, right?
Yeah.
So the aggregate will be around 2 something, and it is less than 1/2.
Yeah.
So do you agree we can say 10 over 11 to the power of 160 is less than 1 over 2 to the 20?
Yeah.
And we know this one is greater than equal ym, right?
Yeah.
So by considering this, we cannot say the answer is C. We can only reject choices, some choices. Can you tell me by considering this, we can reject which choices?
The D and E.
D and E. Now, if we want to reject A and B, what should we do?
Find a lower bound.
Yeah, so if we consider lower bound, 9 over 10 to the m. So we should prove what is less than what? Or greater than what?
M is like greater than like 140.
We should prove 9 over 10 to the power of 80 is not good. Not good means we know ym is greater than this, right? So we should prove this one is greater than 1 over 2 to the 20. If we prove this, we know this one is correct, we should prove this. If we prove this, do you agree we can reject choice A and B?
Yeah.
Okay, so try to prove this on your own. It's so much easy, right? We should say it is equivalent that 1/2 is less than or equal to 9 over 10 to the power of what?
The power of 4.
So the denominator is what?
10,000.
Yes, 10,000. And the numerator is what?
729 times 9, which is greater than 5,000.
This is this, right?
Yeah.
The agree is correct if you cross multiply 13,000. Right?
Yeah.
Okay, so like this we can reject A and B, right?
Yeah.
So here it was more rigorous, right?
Yeah.
So each angle in a pentagon, each angle is what?
108.
108. So 5n minus 2 times 180 times 3 over 5. So 36, 108. So let's draw a pentagon. Regular pentagon. The length is 150. So let's calculate this one first. 108. 150. 8, 72. 150. Okay, something like this. And okay, so this one is 250, 108. It would be 142. So 142, 1.5, and this, right? Okay, it is A, B, C, D, E. And then it says the 5 vertices of the pentagon are folded into the center of the pentagon. Okay. If you want to find center of this pentagon, so here, for example, it is 70. We know it is, this one is 108. So half of that is 54. So it lies on this, and this one is, 72 with this one. So 108 over 2 is 54. 54 plus 72, 126. It will be something like this. So it is our center, right? Okay.
Yeah.
Can you tell me, if you want to create new pentagon, then the figure would be what? For example, it is A. How can I find A prime?
Into the center.
A goes to the center, right?
Yeah.
Okay, when A goes to the center, what happens to the, for example, new, if you want to create new pentagon, the figure would be what?
It would be like this pentagon rotated 180 degrees.
Yes, if we connect, for example, A to this one, so when A goes here, you should consider perpendicular bisector, right?
Yeah.
Let me copy a regular pentagon with center. Okay. One regular pentagon is, okay, copy. Let's try, let me copy the photo of the image. Okay, so let's try this one here. Okay. Now, if we consider this one, can you tell me the new pentagon? How can we create new pentagon? B, C, D, E. Okay. The center lies here, right?
Yeah.
Okay, let me make it bigger. Okay. A lies here. We can also say, okay, D is 54, 53, 54. Okay, our center is this O. So how can we create new pentagon? When A goes here, do you agree we should consider midpoint of this perpendicular bisector of midpoint of this, because we want to reflect with respect to that line? So if we consider that one, so look here, the length is 4. We should consider 2 around this one, and it would be this. Do you agree when you hold A to O, then we have this line as one edge of regular pentagon?
Yeah.
Okay, so if we connect all points to this O like this, so we should, let me erase this one, connect only A to O, this one to this. Okay, so here, if you want to consider this one, it is what? It is the gain 4. You consider 2, and the angle is what? 340, 90 to 50. Okay. So next line is this green line, right?
Yeah.
Again, this one is 4. It would be around 4. Let me check. It's around 385. Okay, 396 is around 2. Okay. So 198 minus 90 is 108. This one has 4. Then it would be 2. Okay. So 124, 90, 34. Okay, and last one would be what? Again, you can say it's 4, we can say around 2, and then this one is 53, 143. Okay, these are our new vertices, so it would be D, because we have DE, let's write F, G, let's write in this order, G, H, I, J, right?
Yeah.
Okay, so then it says what? It says, okay, we know a regular pentagon area is this, and now what's the area of new pentagon? So we should find the ratio of these two pentagons, right?
Right. Okay.
Because they are similar. So, for example, you can say side length is A or something like that. Then this side length is what in terms of A? Okay. So
Okay.
your figure is this or not? Your figure is this or different?
My figure is very different, but it's fine.
No, but the figure is this, if it's your exact figure. So you should consider, for example, AB is A, then this one is what in terms of A? One hint for this one, or want to try first on your own?
Can I have a little hint, please?
Okay, sure. So this one is A. What can we say about AO?
AO is equal to EO.
Yes, all of them are equal, but they are what in terms of A? Let me just tell you something. We know center of ABCDE is O, right?
Yeah.
So O is equal to O center of ABCDE. Can you tell me center of FGHIJ is what?
Of FG. Isn't it also O?
Yes, why?
Because they're similar?
Because of symmetric, we can say this, right?
Symmetry, yeah.
we can say this length is equal to this length by symmetry, so OI is equal to OH, similarly OJ. So this one is set. Now we know OA is radius of this one. So do you agree if we, for example, find OI over OA, the problem will be solved? Agree?
OI.
Because we want to find the ratio of these two similar figures, right? So
Right.
at first I wanted to find ratio of sides, but I saw that, okay, radius seems to be better. Do you agree OI is also equal to AI, right? So let's consider this one big R. Oh, so it is R over 2, R over 2. OI, this one a small r. So if you find big R over a small r, the problem will be solved, right?
Yeah.
Okay, want more hint or that's enough?
I'll try, but I probably will need more help.
Okay, related to the angles, okay? Find its sine of something or cosine of something related to it. Okay?
Okay. I don't know how to find like sine of 36 or 54.
Exactly. We should relate it something like that. This angle is what?
That's 36.
Yes, you should divide this by 10. It's 36. So here we know if you want to find this ratio, for example, cosine 36 is good, right?
Yeah, but I don't know. That's
Cosine 36 is what over what?
R over 2, big R over 2 small r.
Yeah, so it is r over r, 2r, so r over r is 2 cos 36, right?
Yeah.
Okay, so we should find r, big R over. The answer is big, let me tell you. The answer is what in terms of a small r and big R? Let me copy the problem. The answer is what in terms of big R and
The small r over big R. Wait. Oh, I don't. Small over big R squared times square root of 5 plus 1.
Exactly. Which is 4 times root 5 plus 1 times cos squared 36, right? Agreed? Sorry. It is in the denominator. So. A small r over big R is root 5 plus 1 over 4 cos squared 36, right?
Yeah.
How can we relate cos squared 36 to cos 72?
Cos 72 is 2 times of 36.
No, try again. Find this one in terms of cos 72.
No, it's like half of 70.
Half of, yes, half of what?
One plus cosine 72 over 2.
1 plus cos 72 over
2.
2, exactly. So do you agree? We should find cos 36, or if we find also cos 72, the problem will be solved, right?
Yeah.
Or what are the other things that if you find it would be okay? Cos 72 is equal to sine what?
Cos 72 equals sine 18.
Exactly. If you find any of them, it will be okay, right?
Yeah.
Okay, now for this part, let me tell you hints. Then when we find these, we can find all of them. For this one, we have an approach. It's famous. You can say alpha is equal to 18, okay?
We have got 5 alpha.
Alpha is equal to 18, then 5 alpha is 90, right?
Yeah.
Then do you agree sine 2 alpha is equal to sine 90 minus 3 alpha, right?
Yeah.
So it's equal to cos 3 alpha, okay?
Yeah.
So we have sine 2 alpha is equal to cosine 3 alpha. Then you can use these. You can use trigonometric formulas to simplify, and then you can find sine alpha is what? Okay, you should simplify both sides. Want more hint or that's enough?
I'm not. Okay, I'm not that good with.
For example, for this one, sine 2 alpha is what? Is 2 times what times?
2 times sine alpha.
Exactly.
Alpha.
Then for cos 3 alpha, write cos alpha plus 2 alpha, then apply for cos 2 alpha, then you can simplify and you can easily find sine alpha.
Okay.
Okay, try.
Okay. I got that sine alpha is -1 plus minus square root of 5 over 4.
-1 plus minus the square root of 5 over 4, right?
Yeah.
We should select minus root 5 or plus root 5. So which of them is our answer? Plus root 5 or minus root 5?
It's plus, right?
Why?
Because for plus, because it has to be positive. Because it's
Yes,
two
sine alpha
sideless.
should be positive because it is between 0 and 90 alpha, right?
Yeah.
Okay, and here sine is positive from 0 to 180. Okay, let's check. Here we write it as cosine alpha, cosine 2 alpha, minus sine alpha, sine 2 alpha. Then, what can we do here? We expanded cosine 2 alpha, right?
Yeah, I could expanded cosine 2 alpha and sine 2
cosine alpha squared minus sine alpha squared, right?
Yeah.
Then what? Here also you can write 2 sine alpha, cosine alpha.
Yeah.
So if you write, it will be 2 sine alpha. Cosine alpha is equal to, if we write this one first, it will be minus 2 sine alpha squared cosine alpha, right?
Yeah.
Then if you write this part, we can say cosine cube alpha minus cosine alpha sine. So let's write cosine cube alpha minus cosine alpha sine squared alpha, right?
Yeah.
Then we can do what?
I divided everything by cosine alpha.
Yes. So 2 sine alpha is equal to negative 2 sine squared alpha. And how here, if you consider both of them, it's negative 3, right?
Yeah.
Sine squared alpha plus cos squared alpha. Then what?
And then I changed cosine squared alpha to 1 minus sine alpha.
Yes, good. So if you take all things to the left side,
you get
it is
4
4
sine
sine squared alpha, right?
Yeah, plus 2 sine alpha minus 1 is 0.
Exactly. So sine alpha, as you said,
is x.
is equal to, yes, minus b plus minus 4 minus 4 plus 16 over 8. So sine alpha is equal to negative 1 plus minus root 5 over 4. And because it is positive, so sine alpha, as you said, is root 5 minus 1 over 4, right?
Yeah.
Okay, so sine 18 is root 5 minus 1 over 4. Now that you found this, you can find the answer of this problem, right? And you can memorize this one, okay, for other problems. Then you can use it quick. Okay, calculate the answer is what?
I made a calculation error somewhere.
Okay, let's try it. You know, sine 18 is this, so it is equal to cosine 72, right? Agreed?
Yeah.
So if you simplify it, the denominator is 8, the numerator is what?
Wait, is cosine... What's the relation between cosine 36 and cosine 72 then?
This one.
Okay. Yeah, okay.
Okay, so the numerator is what?
3 plus square root of 5.
Okay, so it is 4 minus 1, 3 plus root 5.
Wait, I can do the calculation again.
Okay.
Okay, I got B.
You got B?
Yeah.
Okay, let's check. This one 4 times is 2, then you can say 2 times root 5 plus 1 over 3 plus root 5. So we should rationalize it. It is 9 minus 5, 4. So we have 2 and root 5 plus 1. 3 minus root 5. So if we calculate it, it is 1/2. 3 root 5 minus root 5 is 2 root 5. 3 minus 5 is -2, so it's root 5 minus 1, right?
Yeah.
Yes, good job.
Yeah, simple case, right?
Exactly. Small example, simple case. It says n, we have n standard 6-sided dice are all. The product of the numbers or can be any of 936 possible. So there are 936 possible values, right? So let's check for n. We want to see, okay, if we have n1, the product
There's 6.
has how many cases?
There's 6, right?
Exactly.
6.
What about n2? Check n2, how many different cases are there?
Okay. I got 18.
18. Okay, let's check. Here we have 1, 2, 3, 4, 5, 6. Let's copy them again. So, let's concept power of 5. Power of 5, we can have 5 squared or 5 to the 1 or 5 to the 0, right?
Yeah.
So for 5 squared, how many cases are there?
5. Wait, what is 5 squared?
Let the product.
5,
the product is multiple of 25 or 5 or is not multiple of 5, right? 3 cases. Agree?
Right, okay.
Okay, suppose product is P, product P. So 5 squared is the maximum that divides, when we write 2 divides this, it means it's maximum power. 5 squared is the maximum power that divides P, or 5 to the 1 or 5 to the 0. It means that we don't have any 5. So in the first case, how many products are there that is multiple of 5 squared? Only 1, 25. What about this one?
3. No, 4.
5.
5.
Because we have 1 5 and the rest can be one of these 5 cases, right?
Yeah.
Now let's concept 5 to the 0. So it means that there is no 5, right? So we can erase these 2 5s. So we have this. Okay. Now here, let's focus on power of 2. In this case, case 3, 1. So what's the maximum power of 2 that can divide P?
Maximum is 2 to the power 4.
Good job. Next case 2 cubed, right?
Yeah.
Next case 2 squared. Next case 2 divides P, and last case 2 to the 0 divides P, right?
Yep.
Okay, so we should check all these cases. 3 to the 4, 3 to the 5. 3, 5. Okay, what about case 1? How many cases do we have?
1.
1. What about this case?
1. No, 2.
What are the 2 cases?
There's 2 cases.
Yes. Can you tell me those 2 cases are what?
8 and 24.
8 and 24. Good job. 2 cases. What about 2 squared?
4, 12, and 4, 12, 20, and 36.
Okay, let me tell you a better way, a good way for calculating these things. I want to concept power of 3, okay? Power of 3 can be what numbers? Because do you agree here we have only 2 and 3 in our product?
Yeah.
Okay, so power of 3 can be what numbers?
What do you mean power of 3 can be what numbers?
Look,
Like how
for
many?
example, power of 3 can be 3 to the 0, means 4 times 3 to the 0 is 4. 4 times 1, we can create 4, right?
Yeah.
We can also create 3 to the 1. 4 times 3, right?
Yeah.
Can we create 3 squared?
Yeah.
How?
6 times 6.
Exactly, but we cannot create 3 cubed, right?
Yeah.
Okay, so here there are 3 cases, right?
Right, okay.
What about next one? For this one, calculate how many ways are there.
It can also be 3 to the power of 0, 3 to the power of 1, and 3 to the power of 2.
Exactly, 3 to the 0 is 2 you can create. 3 to the 1, 6 you can create. 3 squared, 18 you can easily create. 6, 3 cases, right?
Yeah.
For this one also, again, 1 and 3 and 9, you can easily create them, right?
Yeah.
So it would be what the answer for N2?
12.
That's 12 and 5 and 1, 18, right? And good job, your answer is 18. Your solution was different, right?
Yeah.
You used what?
No, I just counted.
You wrote down all numbers that can be created, right?
Yeah.
Okay, so we want to use this way to find a pattern to find for general n. At the end, we want to find for general n how many possible cases are. So try n3, okay?
I think I have an answer, but I think it's wrong.
You reached what?
Because I think the answer is supposed to be 54, but I got 53.
Okay, let's check. Again, let's consider power of 5. Power of 5 can be what to what?
3, 2, 1, and 0.
So for 5 cubed, how many cases do we have?
For 5 cubed, that's 1 case.
For 5 squared, how many cases?
5.
For 5 to the 1, how many cases are there?
25.
How many?
25.
No. This part is wrong. Calculate this one again.
Is it 12?
Exactly, because when we have 5 to the 1, it is similar to this. 9 plus 2, 11 plus 1, 12, right? 1, 5, 12, right?
What?
Okay, now for 5 to the 0, we have 3 of this, right?
Yeah.
Okay. So split to different cases like this and calculate this one.
Yeah. I've done that.
It is what?
Well,
You will split it, you've used casework for solving this?
yeah, like if it's 2 to the power of 6 or 2 to the power of 5 to the power of 4 to the
Ah,
power of 3.
okay, good job. So let me check. We have 2 to the 6, 2 to the 5, 2 to the 4, 2 cubed, 2 squared, 2 to the 1, 2 to the 0. For this one, how many cases are there?
1.
What about next one?
2.
We can have 3 to the 0, 3 to the 1. We can say 4, 4, 6, right?
Yeah.
What about this one?
3.
3 squared. We can change 4 to 6. 4, then we have 3 cases. What about 2 cubed?
4.
This one.
4.
Yes, all of them will be 4.
Yeah.
So 1, 2, 3, 4, 16
1 case.
plus 3, 19, 21, 22, right?
Yeah.
22, 34, 37, 38, right?
Yeah.
Let me check it again. 18, oh no.
No, 40.
40, yes. So now we want to calculate it for general n. If you can calculate for general n. If not, take n4 and then general n, okay? Try.
Is that supposed to be like a pattern here? Like the
More than pattern, pay attention to this. Look, for example, again for next one we have 1, 5, 12, 22, and you need to only calculate one more case. And then you should split to these cases. For n also you can use same approach, okay?
Okay.
And you can find a recursive sequence, okay?
Okay.
Okay, try.
I think I have a recursive formula, but I don't know how to like I can't calculate.
You don't know how to find closed form, right?
Yeah.
Can you tell me your recursive formula is what?
An equals an minus 1 plus n plus 1 times n plus 2 divided by 2 plus n times n plus 1.
Plus what?
N plus 1 times n plus 1. No, times n plus 1.
This one times n plus 1, like this?
No. N minus 1 plus that plus n times n plus 1.
This one, right? Okay, let's check. A3 is A2 by the formula you said 4 times 5 over 2 plus 3 times 4. Which is A2 plus 20, 10 plus 12, 22. 22, that's correct. And if you check A2, it's A1 plus 3 times 4 over 2 plus 2 times 3. So it is A1 plus 6 plus 6, 12. Good job. I think this formula is correct. Let's check it together. As you can see, for an, we can say it is equal to an minus 1 if power of 5 is n or n minus 1 to 1, right?
Yeah.
Now, if power of 5 is 0, then we know that we have 1, 2, 3, 4, 6, right? For n times. Agreed?
Yeah.
This one, all the way. So then for this one, we concept power of 2. Power of 2 can be 2n, can be 2n minus 1. So this one is 1, this one is 2. All the way to, first, let's consider 2 to the, if we change all of them to 6. 2 to the n plus 1 we have, and 2 to the n. If we have 2 to the n, power of 3 can be from 0 to n, so n plus 1. And this one is n, right?
Yeah.
2 to the n plus 1, okay. So 2 to the n minus 1, n plus 1 to 2 to the 0, n plus 1. Then you considered 1 to n plus 1. You said n plus 1 times n plus 2 over 2. And from here to here, 0 to n minus 1 is n. N times n plus 1, right?
Yeah.
Okay, good job. But you can't find closed form, right?
No.
Okay, let's try to get it. Well, you can solve it by telescoping sum.
Yeah, but I know tennis, but like I don't know how to calculate.
Okay, so let me show you. Look here, because we have these, I want to write it as something, choose something. Can you tell me an minus 1? Instead of this, we can write what, choose what?
n minus 2 choose n.
This one, this
No,
one.
n plus 2, sorry. N plus 2 choose n, sorry.
N plus 2 choose n or 2, right?
Yes, same.
Plus, what about this one? How can we relate this one to something? Choose?
2 times n plus 1 choose 2.
Exactly. And do you agree we know an minus 1 is equal to n plus 2 choose 2 plus 2 times n plus 1 choose 2, right?
Yeah.
If we write an minus 1 minus n and an minus 2, it would be what?
M plus 1 choose 2 plus 2 times n choose 2.
All the way to a2 minus a1 is what?
A2 is a1 is 4 choose 2 plus 2 times 3 choose 2.
And if you add, you can cancel these. A1 is what?
A1 is 6.
Yes, the first column is what? You add all of them.
This is kind of the part I don't know.
Do you know hockey-stick identity?
Whose identity?
Hockey-stick identity.
Hockey stick. I heard of it.
Yes, let me write down. It's so much important. This one is R choose R plus R plus 1 choose R plus R plus 2 choose R all the way to N choose R. Remember it was what?
It was like plus R
1, choose R plus 1. Okay. Now, if you use this first column here is what?
It will be m plus 3, choose 3, minus 4.
M plus 3, choose 3. Good job. Minus 3, choose 2, minus 2, choose 2, minus 4. Exactly. What about second column?
Uh, 2 times m plus 2, choose 3, minus 2.
It's 2 times M plus 2, choose 3, minus, oh yes, minus 1 here, or if you expand, minus 2, right?
Yeah.
Okay, good job. Now check this formula that we've reached. If it is correct, then you can find for which n, an is 936, right?
Oh, right. Yeah, okay.
Okay, try, find correct choice.
I think it's E.
It's E.
Yeah, because I tried D and it was too small.
Okay. So let's check. An is equal to n plus 3, choose 3, plus 2 times n plus 2, choose 3, minus 4, minus 2, minus 6, minus
It cancels out.
It is this, exactly. But we should check at least for one case, for example, 8, 3, to make sure it's correct. 6, choose 3,
Okay.
plus 2 times 5, choose 3, which is 20 plus 20, 40. It's correct, right?
Yep.
Okay, now we can calculate A11. It's 14, choose 3, plus 2 times 13, choose 3, right?
Yeah.
So it's 14, 13, 12 over 6, plus 13, 12, 11 over 3. We can cancel, it's 4. We can cancel, it's 2. So 13, you can factor from 13. It is 2 times 14, 28. And 4 times 11, 44. 4 plus 8, 12. We have 1. 4 plus 2, 6 plus 1, 7. But here you can check 3 times 2 is 6. If it was not 6, we don't need to calculate it, right?
Yeah.
Okay, 13 times 72, 3 to 6, 21, 72. So it's 639. Good job, 936. So look, how could we solve this? By using a small example, right?
Yeah.
Okay, and this is a hard problem. I can say the difficulty is similar to hardest problem in BMO, BMO1, okay?
Okay.
So can you tell me this point is center of which circle?
C1.
At this point is center of C1, so let's call it O1. This point is center of what?
O2. It's C2 center. So yeah.
Can you tell me where is O3?
Right in the middle of the 1/2. I know that C3's radius would be 3/4. I'm just not sure how to put it in relation with C4 to find C4.
Okay. Let's call this construct this one. So, can you tell me R3 is what?
R3. Wait. Oh, radius of circle 3. Yeah, sure. That would be 3/4.
Yes, because this one is 1 minus 1/4, 3/4, right?
Mm-hmm.
So we should only calculate R4 now, right?
Mm-hmm.
Okay. Let's connect this one to center of C4, O4, okay?
Yeah.
You can calculate all these lengths in terms of R4 and write Pythagorean theorem and find the answer. Want
Okay.
more hint or that's enough?
Let me see. Okay, so if we want to write it in lengths in terms of R4, we're going from the center of R4. So that'd be 1 R4. Wait. I'm not sure how we would know. Like, we know that technically the C1 length is. How would we?
Okay, so let
How
me
do
tell
we
you
know
from easy to hard. O1, O3 squared plus O3, O4 squared is equal to O1, O4 squared, right?
Yeah.
O1, O3 is what?
O1, O1 to O3 would be, yeah, that would be the remainder. That would be, sorry, 1 second. I'm just trying to make sure. That would be 1/4.
Exactly. O3, O4 also is easy. This one is hard.
So that would be the radius of O, well, the diameter of O4, or wait, that would be 3/4 plus O4 plus the radius of O4. It's kind of hard to tell.
4 plus R4 squared, right?
Yes.
For this one, you use this point that when we have two circles that are externally tangent. So the distance is O1, O2. The distance is R1 plus R2, right?
Mm-hmm.
So when two circles are externally tangent, distance of the centers is equal to sum of the radii, right?
Yeah.
Because C3, C4 are externally tangent. What about the relationship between C1, C4?
O1 and C1 and C4 is touching C1 at one point, so it's internally tangent?
Internally, yes. When two circles are internally tangent to each other, then you can find the distance of the centers in terms of the radii. Okay, so try to find this, then you can find O1, O.
Okay, so that'd be 1 minus, well, the thing is from the center, it's not directly a radius away. It's 1 minus something of C4's part. Mm, 1 minus 2 R4?
Let's check it here. Suppose we have two circles that are internally tangent, okay?
Mm-hmm.
O1, O2. Here, O1, O2 is what in terms of R1 and R2?
Here, okay, so that would be R1, R1 minus R2.
Yes, because both of them are perpendicular to tangent point. They are collinear. This is R1 minus R2. Now you can use this to solve the problem.
Okay, so that would be 1 minus R.
Mm-hmm.
Right. Yeah, which would give us 3/28. Would the answer be D 3/28?
Okay, so let's check. It is 1 minus R4 squared. Right?
Mm-hmm.
So we can cancel R4 squared. 1 over 16 plus 9 over 16 is 1 minus 2 R4, right?
Wait,
7 over R4,
Yeah.
1 minus 10 over 16.
Yeah.
Right?
Mhm.
It's 6 over 16, 3 over 8. You can cancel 4. R4 is 3 over 20, right?
Mhm.
Okay. Now that you've learned this, let me tell you some points about circles. Suppose we have two circles that are externally tangent. And it is a common tangent, right?
Yes.
It is AB. Suppose this radius is R1, this one is R2. Calculate AB in terms of R1, R2. Try this one first on your own, okay?
We raise that circle higher. That would be, yeah, it would be R1 plus R2.
No,
No.
the centers O1, O2 is R1 plus R2, not AB.
Okay. So you can't modify data precision. I'm not exactly sure on how to set it up if I can.
Okay, so let me check. Here, we should consider the centers, okay?
Mhm.
We know if we connect it to center, it's 90, right?
Yes.
So if we consider like this, we have something
Mhm.
similar to this, right?
Yeah, it's not.
And this trapezoid, you know this one is R1. This one is R2. This one is R2. This one is R1. It is 90 degree, and AB is X.
Mm-hmm.
And we want to find X in terms of R1, R2. In this trapezoid, one more step is left. One more hint, or that's enough?
We need to find the height of the
Yes,
trapezoid.
exactly.
Okay, so that'll be 1/2 R1 plus R2. But then the height. I mean, should we try to maybe make a triangle and then find the height that way, or?
Look, when you see a trapezoid, we have also trapezoid in AMC 2022. When you have trapezoid, it's good to draw what? Altitude. Okay, it's so much useful. Here, you should only draw altitude and then you can easily solve. Want more hint for that, you know?
Sorry, what is the altitude?
Look, one altitude is here. The other altitude is, let me draw it. It's this one. Okay?
Okay.
Now you don't need to draw any other line. So, one more hint or that's enough?
Okay, so that seems it's not an actual rectangle because it's different lengths, but or is it an actual rectangle? No, it's not a rectangle. Okay, so if that's the altitude, I'm still not sure, sorry.
Okay, so we want to use Pythagorean theorem in this triangle.
Mhm.
This length is what?
R1 plus R2.
A square is equal to, that is hypotenuse. This one is what?
That would be
You can say this one is what in terms of R1 and R2?
R1 minus R2.
Exactly. This length is what?
H or whatever.
X.
I need to find. Yeah.
Because it's 90, 90, 90, 3 90s, it's a rectangle, right?
Mm.
Okay, so X is what in terms of R1 and R2? Calculate.
Okay, let me do that. Would X equal 2 radical 1 times radical 2? Wait, no. X equals radical of R1 times R2 is what I meant to say.
Times 2, right?
Yeah.
Okay. So in this case, it is this, and memorize this part. Let me memorize this. It's important, and also you should draw black box around them. This one is important. This one is important that you should memorize. This one. And alpha. Okay, this approach. This one is important. Okay. Let me. Now in this case, we consider the length of common tangents when two circles are externally tangent, right?
Mm-hmm.
Now sometimes the circles look like this, and then we want to find again length of common tangent, but in terms of what? It is similar. Again, look here, this length is x. You know, O1, O2 is D. This radius is R1, this radius is R2. Calculate x in terms of D, R1, and R2. Okay? It is similar to this one. Try this first on your own.
R1 squared minus plus 2 R1 R2 minus R2 squared. So would x equal the radical of d squared minus R1 squared plus 2R1 times R2 minus R2 squared?
Okay, let's check here. Again, if we connect to the centers, we have something like previous one, right?
Mm-hmm.
Again, we drew this one, and we created a right angle triangle. This one is R1 minus R2. This one is X, this one is B, right?
Yes.
X is the square root of B squared minus R1 minus R2 squared, right?
Yes.
Good job. Let me tell you, last one in these types of problems, sometimes we have two circles that are outside of each other, but we want to find length of these common tangents. Okay. Length of, so it would be, now it's good. Okay, again, this length is x, it is R1, it is R2, O1, O2. Again, you should create a right angle triangle and use Pythagorean theorem. Calculate the x in terms of R1 and R2. Try first on your own.
Okay, so that would go straight to the center of that. So would the answer be radical of r1 squared plus d squared over 4, and then plus another radical of r squared plus d squared over 4?
Let me check. Look again, like these things that we've connected in all of them centers. Again, we should connect the centers. We should draw these perpendiculars. This one, this one, this one. This one. This okay. 90 degree, 90 degree. 02, 01. Then for creating right angle triangle, we should extend these and we should draw a perpendicular. Okay, now let me ask you a step by step. This is 90, 90, 90, so this one is 90. This length is what?
That length would be, okay, r2 plus...
in terms of x.
That would be, yeah, okay, x is from there to there. So would that also be x?
Yes. This length is what?
Oh, 1.
This length is what?
That would be r2.
Exactly. This length is d, right? So x is a square root of d squared minus r1 plus r2 squared. Okay?
Yeah, I see.
So we've solved this, right?
You should draw the altitude.
Exactly. So you should draw, especially in isosceles trap. Altitude. Look, as you can see, there are some ideas like this. So, for example, drawing altitudes in trapezoid that are repeated in many problems. So if you saw, for example, 5, 6, 7 past papers, then there are lots of ideas that are repeated like this. So we had, and also this idea of double Pythagorean theorem, I saw this in also previous AMC problems, okay? It is famous. Now, let's do something. It says BC over AD. So I call this one x. If this one is x, this one is what?
X plus 2.
X. This one is x, right?
This one's...
Now consider this one y. This one is what then?
Y.
Exactly, because it is isosceles trapezoid, right?
Yes.
Okay, so BC over AD is what in terms of x and y?
It would be x over x plus 2y.
Exactly. So if we divide both numerator and denominator by x, this is 2y over x, right? So we should find y over x is what, right?
Yeah.
Okay. Now, if we use double Pythagorean theorem, let's draw something first. Let me draw this out to this one. I want to use double Pythagorean theorem. So let's do something. Because here I want to use A, let's use this one. For example, let's call this one A, this one B, and this one A, this one, okay? Then let's write BC over AD is what in terms of AB and Y?
BC over AD in terms of, that would be A plus B over A plus B plus 2y.
Exactly, good. Now, if we apply double Pythagorean theorem, PA squared minus PD squared is what?
That would be, okay, the hypotenuse is PA squared minus, okay. So that would be AY squared minus BY squared?
Yes, A plus Y squared minus B plus Y squared, right?
Yes.
Because PA is less than PD, okay, PA squared minus PD squared is what?
PA
Because of the assumption.
Yes. That would be 1 minus 16, negative 15.
Negative 15. Or we can say 15 is equal to a plus y squared minus b plus y. A plus y squared minus b plus y squared, right? Now, if you use other Pythagorean, double Pythagorean theorem, we can say y squared minus y squared is y squared minus y squared.
PB squared minus PC squared is equal to, well, A squared minus B squared?
Yes, and PB squared minus PC squared is equal to what number?
PB minus PC. 2, 4, minus 9, negative 5. Or 5, I guess.
Yes, negative 5. So we have these two equations. By using only these two equations, the rest is only algebra. By using these two equations, we can calculate this. Try.
Okay. 15 is equal to that. Negative 5 is equal to that.
Could you calculate?
Sorry, okay. Yeah, I got B 1/3.
Okay, let's check. From here, we can use that a squared minus b squared is negative 5, right?
Mm-hmm.
Y squared will cancel each other out, plus 2y, a minus b, right?
Mm-hmm.
Okay. So 2y, y times a minus b is what?
Mm-hmm.
It's 10, right?
Y times A minus
Because of
B. Oh, I think I might have solved it a different
differently. Okay, look, I expanded this and I will I've reached this. Agreed? Because a squared minus b squared is negative 5. Y squared will cancel each other out. 2ya minus 2by, right? If we take negative 5 to this side, it's 5. 5 plus 15, 20. 20 over 2, 10. So this one is 10, right?
Mm-hmm.
And from this one, we know that a minus b times a plus b is negative 5, right?
Yes.
Okay, so let's do something. Here, do you agree we can divide both numerator and denominator by a plus b? So it is 1 plus 2y over a plus b, right?
Yeah.
So if I divide, it would be what? Y over a plus b is negative 2. So I think in one part, we have careless mistake. PB squared 4 minus P6 squared minus 9 is negative 5. Negative 5 is a squared minus b squared, right?
Yes.
This was negative 15, sorry, because we didn't change. So it's negative 15. So now I can calculate it. So negative 5, when we take it to the left side, it's 5 minus 10 over 2 minus 5. So when we divide, it would be 1. So if you plug in, it's 1 over 1 plus 2, 1/3, and your answer. Understood my solution?
Yeah.
Oh, 2023 Amy 1.
Problem 8, right?
Yeah.
The problem that is related to rhombus, right?
Yeah.
I don't know what, for some reason, only I can some part of the problem. Let me copy the problem myself. The problem, I don't know what, something like this. Okay, now I can see the whole part. Copy. It is rhombus ABCD.
Yes.
We have Okay. $31. 131. 131. This is A less than 90. Point P on the inner circle of the rhombus such that the distance of P to the line DA, AB. Okay, so let's show the rhombus in circle. Is tangent to all sides. Since we have a point P such that from DA it is 9, it is 5, seen from this. It would be something like this. It should be 9. So let me. I think it's better to. It's this one. 150. 150. 150. 150. So if we draw in our encircle, so here it is A, it is B, it is C, it is D. Because from BC and DA it is 16 and 9, this one is 25. And this one is 5. So if I want to connect them, so in which position is better to draw? If P is here, do you agree DA should be 9? So I think some positions like this, right? P. Then this is 9, it is 16, and that one is 5, right?
Yeah.
So for example, something like this one. And this one also should be 90, so the length should be something like this and this one. Okay. So it is P, it is X, it is 9, this one is 5. For example, PY, Z is 60, right?
Yeah.
Okay. What can we say? And it wants what? Find the perimeter of ABCD. So we find side length and then multiply it by 4, right?
Yes.
Between these 3 lengths, if you consider 2 of them, it would be good. Which 2 of them?
What was the question?
Look, you agree if you consider PX and PZ, then you can find this altitude.
Oh, yeah.
XZ is what?
X 25.
Exactly. So one thing that we can say is that this height is 25, right?
Yeah.
Okay. And I am thinking of if we extend this. It would be better. Okay, px, pz, py.
Okay.
And
Wait, how do we know z is outside of the rhombus?
it can be outside because it says the distance, right?
Oh yeah.
Sure. Because if you want to consider inside, in this figure it's not possible. Okay, so we know this height is 25, right? And we
Yeah.
want to find this length. So, do you agree if we find, for example, sine of alpha or cosine of alpha, the problem will be solved?
Yes.
Constant of dl. So we want to find, for example, dc. For finding dc, suppose dc is equal to, for example, t. If you want to find t is what? If we find sine alpha or cosine alpha, then we can find. Because we know it's 25, right?
Yeah.
In radius is what in this rhombus?
Oh, wouldn't it be half the height? So 25 over 2.
Exactly, because if you consider this O, if you connect this, it is O center 25, right?
Yeah.
We are trying to find the lengths that are possible. We know it is alpha, we know it is 9, this one. So, do you agree? Because we know R is this, when we know it is 9, we know it is also, it has to be 16, right?
Yes.
But another important thing here is that this one is 9, this one is 5. And we know when this angle is alpha, this angle is what?
Also alpha.
And also we can, for example, consider that if we draw something like this, we know that this one is 25 over 2, this one is 25 over 2 with similar directions, right?
Yeah.
Okay, now here, for example, we have two intersections here. A, B, C, D, E, from this intersection. And we found this altitude to try to see, can we find alpha, 5, 9, all these things. Want more hint or that's enough?
More hint.
Okay, here can we find any similar triangles or something like that?
Oh.
Similar triangles, look, can, for example, a special case of similar triangles is that when you have a circle, let me show. And you have these and these and these. We have some relationships. For example, if it is A and you can prove it by similar triangles. Can you tell me what relationship do we have here?
Like PowerPoint, PA squared
Yes, PA
equals.
squared is PB times PC is equal to PD times. And do you know
Yeah.
that we can prove it by similar triangles or not?
Oh, yeah. Make it into division.
Yes. So here we can use this power of some points. Lots of things. ZE times, for example, ZE is equal to, let's consider this one, EF. This one, G. H. I. For example, you can find some length. Okay? For example, you can say XP times XE is equal to XH squared. You can find lots of relationships. You can try to find the side length or sine alpha. Want more hint or that's enough?
That's enough.
Okay.
Okay, I think I found sine alpha.
Okay, can you explain?
Yeah. So first, you can say xp times xe equals xh squared, and ze times zp equals zf squared. Yeah, and then you can say xhfz is a rectangle.
Yes.
And then, so that means xh equals zf.
Exactly. Then what?
And then, if you do that, you'll find that ze equals 9 and pe equals 7.
Let's check. XP we know is 9.
Yeah.
XE, so let's consider this length W is 9 plus W, right? Is equal
Yeah.
ZE, we know PZ or ZP is equal to 16. So it is 16 times Z is 16 minus W, right?
Yeah, so w equals 7.
So 25W is equal to 16 squared minus 9 squared, right? It is 7 times 25, so W is 7. Then
Yeah.
what?
So if w equals 7, ze equals 9.
We can also use this. It is 5, it is 7, and we know it is alpha. This one is alpha because it is 90 minus 1. You can easily find sine alpha. Sine alpha, right?
Yeah, yeah.
Your way is correct. It is 90 minus alpha, it is 5, so we know that this length is 5, W is 7, sine
Yeah. So cosine alpha
minus
equals 5 over 7. Hello?
Sine 90 minus alpha is what over what?
Oh, isn't that just cosine alpha equals 5 over 7?
And because we want to find this, so we want to find sine alpha, right? Sine.
Yeah. Okay. So that would be 20. Yeah, it's root of 24 over 49. So.
Or 7, right?
Oh yeah, yeah.
And CD is what then?
So CD is 17 square root of 89. So you can say EPY is similar to EAX.
We can say, let's say something here. In this triangle, yeah, it means sine alpha is 25 over CD, right?
Yeah.
So CD is what then in terms of sine alpha?
25 times 7 over square root of 24.
Yes, 25 over sine alpha.
Yes.
This, so CD is equal to 7 times 25 over 20, right?
Yeah.
Then we can say what?
So that means that's 175 over 2 square root of 6.
But yeah, had to kill this here. Because the answer should be integer, right?
Yeah.
So in which part we had careless mistake? We found W is 7.
Yeah.
Right? So
yes.
cosine alpha, we know it's 9. So sine 90 minus it was 5. It's 5 over 7. Cosine alpha. So what's the problem here?
Oh, I know, because E doesn't intersect the rhombus. It only intersects the circle.
Oh yes, here. Okay, so W is 7. Not the side. Okay, so it is 90 minus alpha. Okay, what's the rest of your solution?
So I
Here,
said,
we also we can find x edge.
yes.
X edge is what?
I got that. I got that to be 175. Wait, no. 12.
Yes, because it is 9 times 9 plus 7, 16. 9 times 16. You take its square root is 3 times 4 is.
Yes.
Okay, then what? Then
So what I did, I set another point called J, which is where XZ intersects AB.
This one, right?
Yeah.
You call this one what? J?
J. Yeah.
Then what?
So we can see that PJ is half of PZ because PYJ is similar to BZJ.
You should prove they are congruent, right?
Yeah.
If they are similar, prove that they are congruent. One hint.
Yes.
Okay, so let's calculate length. Good. Fine. Here we want to find sine alpha, right?
Yeah.
And we know it is 25. It is equal to this. And we know W is 7, right?
Yeah.
We know W is 7, and we know it is 9. EZ is what?
Easy 9.
9 plus 7, 16, right?
Yes.
Okay. And we know it is O, right? And the only thing, for example, here, we've not used P's. Here, by power of the rules, we use that P's on this circle, right?
Yeah.
Okay, if we want to find sine alpha, and we have O here, we know length of W. It's good to draw what?
30s? I'm not sure.
We can connect, for example, let's maximize this. Let me copy this here. Let's maximize this figure. Okay, something like this. Okay, so let me erase this 90 minus alpha. We can connect O to P. And we can draw perpendicular to this, right?
Yes.
Then do you agree we split into two parts this rectangle? We split this rectangle to two parts. Why it is good? Because look, if you draw this one, this altitude, it is parallel to this one, right?
Yeah.
I want to create alpha here. So for creating alpha, this one is parallel to this one. So the other, if I want to create alpha here, the other side length, the other length that I can draw is to draw what? Do you agree if I extend this and do the same thing similarly, then we can find?
Oh, yeah.
I draw with black. Then because this one is parallel to this one, we can say this angle is also alpha, right?
Yeah.
So we want to find sine alpha. So if you find sine this, the problem will be solved, right?
Yes.
Okay. So because we found it is 7, right? So this length is what?
Half. So 3 halves. I mean
7
7
over
halves.
2, right?
Yeah.
We know also OP is what? OP is what?
25 over 2.
Yes.
So OW is 12.
Yeah, so it
Well,
is
yeah.
O1. For example, let's consider O1. We can find sine O1 cosine all lengths. So for O2, what can we say? We should find this length. This length is what? Let me call this one M. Try to find PM is what? Okay.
Okay. Can I get a hint?
Sure. So, do you agree it is a rectangle?
Yes.
So this length is equal. This one is radius, right?
Yeah.
So do you agree you can say it is my minus py?
Yes.
My is what?
My is 25 over 2.
Py is
Oh,
what?
and py is 5. And py is 5,
what?
so 15 over 2.
Now the agree sine alpha is equal to sine O1 plus O2.
Yes.
Now in these two triangles, you know all side lengths. So do you agree you can find sine O1 plus O2?
Yeah.
Okay, one hint or one to try on your own?
I can try my own.
Sure.
Okay, I solved it.
Okay. Sine is what? Sine alpha.
Sine alpha is 4/5.
Okay, let's check. Here you use this, that's sine O1 cosine O2 plus cosine O1 sine O2.
Yes.
Okay, sine O1 is what?
7 over 25.
Cosine O2 is what?
4/5.
Okay, so let's write this. We know sine O1 is 7 over 25. Sine O2 is what?
Sine O2 is 3/5.
15 over 25, 3/5. Okay, so cosine O2 is 4/5, right?
Yeah.
Cosine O1 is what?
Cosine O1 is 24 over 25.
Okay, because 7 squared is 49, 24 squared is what? 576, right?
Yes.
625, right?
Yeah.
Yeah. Okay. So 7 over 25 times 4 over 5 plus 24 over 25 times 3 over, right?
Yes.
28 plus 72 is what? Is 100, 525. So 450. Now CD is what then?
CD is 125 over 4.
Yeah. Or 4 over 5. 125 over 4. So the answer is what?
125.
Yes. Good. What's your next question?
24.
24. 12A spring or 12B?
Let's see. 12A spring. Yeah.
Okay, let me copy the problem. The problem is this, right? The problem that you were
Yeah.
struck on. Okay. It's a
Yes.
semicircle. Gamma has diameter AB of length 14. Circle omega lies tangent to AB. So let's write first something like this. This AB. It is 14 lies tangent to omega to AB at point P and intersect gamma at point QR. So it would be something like this.
Yeah.
Alright?
Yeah.
QR is 3 root 3 and QPR. QPR is 60. Okay. Then the area. Okay, so let's try this problem. The problem is something like this. This one, okay. This one is AB. This one is B. This one is QR. And QR is 3 QPR. Okay. This angle is 60. So let me, okay. QR is 3. Okay, its diameter. It says the area of PQR equals this, so we should calculate area of PQR, right?
Yeah.
Okay, for calculating PQR, because we have different formulas for the area of a triangle, right?
Yeah.
Okay, so here, for example, if you know what, then we can solve it.
If we can find the other side lengths.
Or if we can find, for example, QPPR, it would be solved, right?
Yeah.
Because you say 1/2 sine 60 times this one times this, right?
Yeah.
There are different ways. Now let's pay attention to something. For example, it is alpha, so this angle is what? Calculate
120.
this. It is alpha, right?
Wait, why?
Because look, this one is tangent to this circle. It is half of this arc. Tangent
yeah.
for it is angle chase. So suppose, for example, this circle out of gamma is what radius of gamma?
Oh, 7.
It's 7. Now calculate out of omega. It's not hard. Try to calculate this one, okay?
Okay. Is the radius 3?
Okay, do you remember R was what I told you the formula, remember?
A over 2 sine A.
Exactly. So 3 root 3 over 2 times what?
2 sine 60. So just square root of 3.
Yeah, so it would be 3, right?
Yeah.
Okay. Now we found so this one is gamma, this one is omega. So we found circumradius of omega, right?
Yeah.
But still we've not used that this circle is tangent to this diameter, right?
Yes.
So if we're gonna say O1, we know, for example, both of them lies on this, right? Or perpendicular bisector of QR, right?
Yeah.
Okay. So, what are the ways to use this one?
What was the question again?
How can we use that? This circle, you said we should use what?
Oh, it's tangent. So the center makes a right angle with the tangent.
We know that, for example, one thing is if you draw perpendicular bisector, O2 lies on this, right?
Yeah.
And also O2 lies on perpendicular bisector, right?
Yes.
So if you connect this one, it is O2, right?
Yeah.
Okay, try a bit on your own. See, can you use this one and this one? We know two R's, and we know it is tangent. Try them. Can you find the area? Let me know if you want it. Okay.
Can I have a hint?
Okay, sure. So let's calculate the lengths that we can. O2P is what?
3.
Let's erase this one. Let's call this one M. O2M is what?
Oh, that's 3 halves. So it's 30, 60, 90.
It is 3, right?
Yeah. 3 squared 3
This
over
one is
2.
60, 120. These are. So this one is 60. This one is 30. So O2M is 1 half, right?
Yeah.
O1M is what?
Oh, 1M. 13 over 2.
$13 over 2, you said?
Yeah. From
Okay, let's count. This is square root of O1 Q squared, which is 7 squared, minus MQ squared. MQ is what?
MQ is square root of 3 over 2. I mean, 3 square root of 3 over 2.
3 root 3 over 2, which is 27 over 4, right?
Yeah.
Okay. So 4 times 49 is what?
196.
Minus 27 over 4. 196 minus 27 is what?
169.
Over 4, so it is 13 over 2, right?
Yeah.
So O1, O2 is what?
That would be 5.
It is O1M minus O2M, right?
Yeah.
It is 5, you said?
Yeah.
Okay. It is 13 over 2 minus what?
3 over 2.
O2M, here. It was not 1 over 2, 3 over 2, right?
Yeah.
3 over 2, 10 over 2, which is 5. O1P is what?
O1P. Oh, that would be 4.
Yeah, square root of 5 squared minus 3 squared, right?
Yeah.
Okay, so we found all these links. For example, one way is to calculate QPPR, or one way is to calculate HP. Means if we draw altitude, because we have this altitude on this edge and we found all these links. So if we find this altitude, the problem will be solved, right?
Yeah.
Want more hint, or that's enough?
That's enough.
Okay. Want hint?
Yes.
Okay, so I told you if we calculate pH, the problem will be solved, right?
Yeah.
Okay, so let me draw this one. It is something like this, right?
Yeah.
Okay. So it is P, it is O1, it is H, it is N, right?
Yeah.
It is a trapezoid, right?
Yes.
When we have trapezoid, it's good to draw what?
The height?
Exactly. So if we draw this perpendicular from P to O1M, then we know this pH is equal to, for example, this LM, right?
Yeah.
Okay. And we know O2 is some point here, right? We know O1M is what? So if we find O1L, then we can find this one and altitude, right?
Yeah.
So we should calculate O1L, right?
Yes.
This O2, let me show a better figure, because O2P is perpendicular to the horizontal lines. I want to find O2, it would be something like this one, then this one. It will be something like this: M, H, and O1, right?
Yeah.
Okay, so we found all these lengths. Let's copy. O1M was what? Remember?
Oh. 13 over 2.
O1, O2 is what?
5.
So here we want to find O1L. Look, in O1P is what?
O1P is 4.
Yes, O1P is O2P is 3, O1P is 4, O1, O2 is 5, right?
Yeah.
So you know in this triangle, you know all side lengths, so you can find O1L easily. So try to find O1L. Want hint or want to find it on your own?
I can find it on my own.
Oh.
Okay, I found O1L. It's 16 over 5.
Yes, we know O1L times O1, O2 is O1P squared, right?
Yeah.
Okay. O1L times O1, O2 is O1P squared. So it is 16, O1, O2 is 5, so it's 16 over 5, right?
Yeah.
Okay, so pH is what?
So pH. 13 over 2 minus 16 over 5. So 33 over 10.
It's 65 minus 32, right? Over 10.
Yeah.
33 over 10. So 33 over 10, we found the area. So the answer is 33 over 10 times what?
Times Oh, times 3 square root of 3 over 2.
Yeah, so it would be what?
99 root 3 over 20.
Okay, so the answer is what?
D. 1,
Take
2,
that.
2.
Okay, understand completely how we solve this?
Yeah.
Okay.
Yeah, yeah,
And sum of the divisors, right?
yeah,
And for each prime factors, we split each one for one prime factor, right?
yeah,
This idea is also useful in SUMaC. I think I told you a problem. It says unique factorization, something like that. It means that, for example, P1, P2, then we wanted to write it as product of primes. Remember that problem? For
yeah,
example, 12, you can write it as 2 times 6, 3 times 4. It was bad because you can write it in two ways. And
yeah,
it's fine, all of them. In those problems, you should consider prime factorization and split into different parts, which each part is only related to one prime. So let's see here how it works. It's at the end denotes, the number of positive integers that divide n. So the number of positive divisors, right?
yeah,
For example, 12 is 2 squared times 3. 3 times 2, 6, right?
yeah,
It says f of n is dn over root n. So if you can say n1 is p1 alpha 1, p2 alpha 2, to pk alpha k, how can I write f of n? I want to split
oh,
different
alpha,
parts. That each part, first part only related to p1 alpha 1, second part p2 alpha 1. So
yes, it would be alpha 1 plus 1
over
over p1 to the alpha 1 over 3.
yes, or cube root of p1 alpha 1, right?
Yeah,
Next one alpha 2 cube root of p2 alpha 2. Alpha 3 plus 1 over cube root of p3 alpha 3. All the way to alpha k plus 1 over cube root of pk alpha k, right?
yeah,
It says there is a unique positive integer big N such that f of big N is greater than f of a small n for all positive integers. And that would be open. Okay, what's the sum of the units of n? So we should find maximum, right?
yeah,
So as you can see, for example, for 2, for this one, do you agree each of them, this one is f of p1 alpha 1 times f of
yeah,
p2 alpha 2 times f of p3 alpha 3 to f of pk alpha 3. Then do you agree for each prime we should find the maximum one? For example, look for
yeah,
2, you say, okay, if you answer 2 to the 1, it would be what? Over cube root of 2.
yeah,
If we consider 2 squared, it would be 3 over cube root of. So for example, for 2 you should find maximum is what? For 3 maximum is what? For 5 maximum is what? Probably after, for example, a prime number, it's better not to use them, right?
yeah.
And you can find. Want more hint or that's enough?
That's enough.
Okay.
Okay, I got an answer. I got E.
Okay, for power of 2 you've reached what?
2 cubed.
Okay, how we can prove that 2 cubed is the best one?
So you just check. So if you just compare them, and then
We can take all of them into cube root, right?
Yeah, yeah.
So it is 4. This one is cube root of what?
That's cube root of 27 over 4.
Next one is cube root of what?
64 over 8, so just 8.
Yes, it is 4 over
Cube root of 8.
which is 64 over 8, which is 8, right?
Yeah.
Okay. So this one is 6 point something. 2 to the 4 is 5 over cube root of 16, right?
Yeah. So 125 over 16.
125 over 16. How
No
we
less
can
than 8.
it is around, it is less than 8, right?
Yeah.
How can we prove that all of them are less than 8? Or 8 cubed is the best one?
Induction, maybe?
Maybe. So if we focus on this, for example, f of x is x plus 1 over cube root of 2x, right?
Yeah.
Maybe induction, maybe differentiate, right?
Yeah.
Okay, so when you add 1, you are multiplying. So f of x plus 1, what happens? We say this one plus 1, this one times what?
Times cube root of 2.
Yes, or that's right. Cube root of 2. So you add plus 1 the numerator and multiply this. So it is what? It is, for example, a over b. Then you want to check it with this b, this one, right?
Yeah.
And we want to see under what case it is less than this one, right?
Yeah.
Here we can cancel b. It's equivalent that a cube root of 2 minus 1 is less than 1, right? So a is less than 1 over cube root of 2 minus 1, right?
Yeah.
So it would be what? It would be cube root of 4 plus cube root of 2 plus 1, right?
Yeah.
So this one is less than what?
That's less than...
Maybe we can say it's less than 5, right?
Yeah.
So if a is greater than 5, greater than equal 5, it is decreasing.
Yeah.
Right? So, for example, if you can check at most until 2 to the 5, right?
Yeah.
And in general, if you want to check it with a over b less than a plus 1 b cube root of b, then again we can say same thing, right? A cube root of b minus 1 is less than 1.
Okay.
A is less than 1 over cube root of b minus 1, right?
Yeah.
Which is cube root of b squared plus cube root of b, right?
Yeah.
And plus 1. If it is less than this, it is increasing. If it is greater than this, it is decreasing, right?
Yeah.
So we understood that if a is less than this, it is increasing, right?
Yes.
So, for example, how can we make sure that we should check until which prime?
If the value starts to be less than 1, then it's not good.
Okay, 3, let's see. 2 over cube root of 3, right?
Yeah.
It's greater than 1 or less than 1?
Greater than.
Yes. 2 over cube root of 5. It's greater than
Also,
1, right?
yeah.
2 over cube root of 7, because it's cube root of 8. And 11 is
Yeah,
2
11's
over,
not
this one is less than 1. So for all of them, for example, if p is greater than 11, we want to prove if p is greater than equal to 11, we want to prove alpha plus 1 over cube root of p to the alpha, we want to prove it is less than 1. Right?
Yeah.
So try to prove this, that y for p greater than equal to 11 is less than 1. Okay?
Can I have a hint?
Okay, sure. So here in the beginning we know for alpha 1 it's correct, right? 2 over
Yeah.
cube root of p. We want to prove it's less than 1, which is equivalent that 2 is less than cube root of p, which is equivalent that 8 is less than p, and because p is at least 11, it's correct, right? P is right? Agree?
Yes. Yeah.
Okay, so look, if we simplify this equivalent that p is greater than 8, we said p is at least 11, right?
Yeah.
Okay, and when we change alpha to alpha plus 1, let's see what happens. Alpha plus 1 to p to the alpha cube times cube root of p, right?
Yeah.
We want to prove y is less than 1. So we add the numerator by plus 1 and the denominator by multiplied by this, right?
Yeah.
So it is equivalent to what? Alpha plus 1 y is less than cube root of this one times this, right?
Yeah.
We know alpha by using induction, we know alpha plus 1 is less than cube root of p alpha, right?
Yeah.
So left hand side, if you consider, is added by 1, right?
Yes.
But right hand side, yeah, here, if we consider right hand side, we multiply it by cube root of p, right? Cube root of p is at least what? Is at least cube
2.
root of 11, which is 2, right?
Yeah.
It is greater than 2. And this one also is greater than 2, right? It's cube root of 11. So when you multiply by this, do you agree it's no? This one is greater than p alpha cube times 2. So we can say this one. Agree this?
Yes.
Do you agree it's greater than p to the alpha cube plus 1?
Yeah.
So do you agree also we can say plus? So it is greater than by induction alpha plus 1 plus 2. So we prove, right?
Yeah.
Okay, by induction we prove this, so you need to only check until P7, right? 2, 3, 5, 7. But for each of them, we should find the maximum power. So for the next part, we can say P is greater than 2, less than 7. And you want to find maximum of alpha plus 1 over cube root of p to the alpha, right?
Yeah.
So you want to say for 2, for 3, for 5, for 7, alpha is what for each of them? Have you found for each of them best power is what?
Oh yeah, for 2 it's 3, 3 it's 2, for 5 it's 2, 7 it's 1.
Okay, so try to prove it. Maybe you can use induction like this. Maybe you can use functions. Try to prove, for example, y for 2 the best power is 3, y for 3 2. Okay, try.
Okay. Okay, I think I proved it.
Okay, can you explain?
Yeah, so you can start with alpha plus 1 over cube root of p to the alpha and say we have a different exponent called beta. So greater than beta over cube root of p to the b. I mean, p to the beta. And then you will cross multiply and simplify. And eventually
Let me check. You want to say, okay, if it is not maximum, there exists another maximum that the power is beta. You meant this?
Yes.
So beta plus 1 over p to the beta, cube root of this is greater than alpha plus 1 for each of them. And cube root of p to the alpha. Then what?
So you expand, but you don't expand alpha plus 1 or beta plus 1. So you treat that as just one number. And then eventually you'll get
alpha plus 1 like this over beta plus 1 is greater than... You can consider beta is greater than alpha, right? Because checking before that is easier. So p to the alpha, p to the beta. So it would be 1 over p to the beta minus alpha cube root.
Yeah.
Then
so
what?
Then from here, cube and then reciprocal.
So it is equivalent that cube root of p to the beta minus alpha is less than beta plus 1 over alpha plus 1, right?
Yeah.
Then what?
Cube.
So p to the beta minus alpha less than beta plus 1 over alpha plus 1 cubed, right?
Yes.
Then what?
And then, so from here, p is a constant, alpha is a constant, and beta is the only one that will change. So as beta grows more and more, the left side looks like p to the x, and the right side just looks like x cubed. So the left side should be greater, but in this case it's not. So it's a contradiction.
Eventually this one will be greater, but maybe, for example, y alpha 5, alpha 6, alpha 7. Why those numbers are not better? Understood what I mean?
Yeah.
Yeah, you can prove eventually if you increase alpha, if you reach beta that is so much large, yes. But for example, y for 4, we want to find a general proof. For AMC, you don't need this, but it's good to know how to prove these things, okay? Because sometimes, especially in full solution exams like JMO, it's useful. So we want to find a way that y for example, 2 alpha 4 5, all those numbers are less than this. Y is the maximum. For this one, y this one is the maximum. Okay?
Okay.
So by this proof, we won't prove this, right? The thing is that, right?
Yeah.
Okay, so
yeah.
Try to prove the rest of these as homework. Rest of these, you solve these, but try to prove why these numbers are the best. Okay?
Okay.
And I don't think so.
Oh no, I couldn't do 23.
Look, for this one, we should do inequality. Let me tell you 2 important inequalities. Suppose x1 to xn are positive real numbers, okay? Then maximum of xi will be greater than equal, we call it qm. It is x1 squared.
Oh, qm, yeah.
Yes, xn squared over m. Am is what?
Pardon? x1 plus all the way up to xn divided by n.
Yes, x1 to xn divided by n. Geometric mean.
And
And
yeah, x1 times x all the way up to n.
yes, and harmonic mean.
This is a weird one. 1 over x1 plus 1 over all the way up to
Exactly.
xn.
And all of them are greater than or equal what?
0.
No, minimum of xi, because they are mean, arithmetic mean, geometric
Oh
mean.
yeah.
AMGM, HM, harmonic. And do you know equality holds for each inequality when what?
When they're all equal.
Yes, when x1 is equal to x2 is equal to xn. Okay, it is the first important inequality. Next one is Cauchy-Schwarz. That you should know. These two are the most important ones. Now we want to solve this problem by only using one of these inequalities. So let me copy the problem first. 20. Okay, problem 23. Copy. Paste. Okay. You should see which of them can be useful here. Want more hint or that's enough?
I'll try.
Okay, sure.
Could I have a hint, please?
Sure. You should use only AMGM.
Okay.
Want more hint or that's enough?
Let me try again.
Okay.
Could I just tell me the answer?
Okay, one hint?
Sure.
Sure. Use one AMGM here, one AMGM here, one AMGM here. Want more hint or that's enough?
Okay, wait, let me try one more time.
Okay, sure.
Is that 1? It's B.
B. Because you can say 1 plus 2a is greater than or equal what by AMGM?
Square root of 2a.
2 times the square root of 2a, right? And they are positive real numbers, so we can use AMGM. 2 plus 2b is greater than or equal what?
2 times the square root of 4b.
And 2a plus b is greater than or equal what?
2 times square root of 2ab.
Yes, and because they are positive, we can multiply. So 1 plus 2a times 2 plus 2b times 2a plus b is greater than or equal what?
8 times 4 times ab. So 32ab.
If you simplify, it would be what right hand side?
32ab.
Yes. 32ab. And we know because they are equal, so all these parts should be equal. So equality holds when what?
When they're all equal. So there's only one possibility.
And 1 is 2a, 2 is 2b, 2a is b, right?
Yeah.
So a is 1/2 and b is 2. B is 1, right?
Yeah.
So it is our answer, right?
Yeah.
Okay, good job. Let me first copy the problem. This one. Okay, before solving this, let Let's solve a famous problem. Problem is this. In how many ways can we select plus or minus such that plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6 is positive, okay? Try this problem first on your own.
Okay. I got 29, but I don't know whether that's right or not.
Let me tell you one way. This summation is always even or always odd.
Okay. I still don't get what's the
It
number?
is always even or odd.
Oh, odd?
Yes, look, because plus a is congruent to minus a mod 2, so sign is not important, right? So if you consider this one mod 2, you can write instead of all of them plus or all of them minus or some of them plus, some of them minus. So it is 21, 6 times 7 over 2, which is odd, right?
Yeah.
So it is always odd. And let me tell you something. For example, plus 1, plus 2, minus 3, plus 4, minus 5, minus 6. It is equal to what?
3?
Hmm?
No, what? No, minus 7. I have no clue how I got that.
Now, if we negate all signs, then it would be what?
9.
Oh, try again.
No, 7. Oh my god, 7.
Yes. So we've negated all signs. So do you agree? We can say they create a pair. So we have a one-to-one correspondence. You can correspond each positive to a negative by negating all signs, right?
Yeah.
By negating all signs, we can create this. So how many cases do we have in total?
2 to the power 6.
If we divide by 2, it's 2 to the 5. The answer is 30. Understood?
Why divide by 2?
Because look, each case can be paired up with a case that is negative of that. It says it should be positive. So half of the cases will be positive, half of the cases will be negative. Understood?
Yeah.
Okay. Now, try. Okay, let's try this one. Try this one first on your own.
I got 62.
62. Why?
Because there's 2 to the power 7 ways in total for the cross. But if you calculate the total, you know that it can be even. It has to be even. But that means that the total can be 0. So you have to minus the
Yeah,
possibility.
minus cases that we reach 0, right?
Yeah, and then divide it by 2.
Exactly. Okay, so you said it is what? Then it will be 62?
Yeah, because I got the number of possibilities of 0 was 4.
Okay, so let's calculate cases that are 0. We know 1 plus 2 to 7 is what?
28.
Yes. So if we want to reach 0, we should have 14 and negative 14, right?
Yeah.
Without lots of generality, suppose 7 is plus, okay? And then at the end, we will multiply by 2, because 7 can also be minus.
Oh, I forgot to multiply by 2.
Okay, so 7. Now for 6, we have 2 cases. We can say 7 plus 6. We want to create 14. So the maximum after 7 can be 6 or can be 5. So if after 7 we have 6, it is 13, we need 1. It is 1 case, right?
Yeah.
If after 7 we have 5, it is 2. Became 1 case.
Yeah.
If after 7 the maximum is 4, then it is 11, we need 3. We can have 3 or 1, 2, right?
Yeah.
And 1 case here, 1 case. If we have 7, maximum is 3 plus 2 plus 1, all of them will be 13, and it's not 8. So we have 4 cases, we should multiply by 2. 8 cases, so 1 to 8 minus 8 over 2, which is 6. You forgot to multiply by 2, right?
Yeah, wait, can I look at the option again? What about like 6 plus 5 plus 3?
What about what?
6 plus 5 plus 3.
6, yes, so look. When you have 6 plus 5 plus 3, is equivalent to which case? Plus 5 plus 3. This case. Agreed?
Okay.
Okay, so I consider all cases that we have 7, because 7 is in one box, plus or minus. I consider cases of 7, so the other box will be unique, right?
Okay. Yeah.
Okay, now, so this. Okay, so now that you've learned these, for this problem, let me first say this. The figure was what? Icosahedron. So let me copy the figure. Icosahedron. Do you know the properties of icosahedron for some number of vertices, number of edges, number of faces?
Oh, it has 20 equilateral triangles, and I assume it has 20 faces.
That faces. Do you know how many edges, how many, for example, vertices do we have?
No.
Okay, do you know Euler's formula?
You've told me.
I forgot. Okay, so let me copy the figure and let's analyze first number of vertices or what. So the figure is here. You can easily count number of vertices is what. So V is what?
Um, 12.
It's 12. Number of faces is what?
20.
And we have like 1, 2, 3, 4, 5. 1, 2, if we start from here. 1 is dot dot dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 here, 10 here, 5 here, 20. Number of edges equals what?
$30? $30?
Why 30?
Oh, because
You've counted all of them?
there's 5 at the top, and there's 5 at the bottom, and then like there's 5 as like a circle, like not a circle, but like circle, and then there's 10 in the middle.
9, 10, exactly. So it's 30. Or we have a formula, we call it Euler's formula. V plus F minus E is 2. Okay, for all these figures. And if you check 12 plus 20 minus 30 is 2. Okay?
Yeah.
Now it says find the probability that the distance of Q and R is greater than the distance of R and S. Without loss of generality, you can consider R is this. R is here, okay? You can fix R here because we are calculating probability, okay? For all of them will be the same. And then try to see how many ways are there here for Q and R, and in how many of them this distance is greater than this. Want more hint or that's enough?
Well then, so okay, I'll try, but I'll probably need help.
Okay, sure, try.
Is the answer A?
A, why A?
Well, that's the thing. I got 9 over 22.
Can you tell me total number of cases will be what for? Select
11 times 10.
What? 11 times 10, right?
Yeah.
Now, how can we calculate number of cases that this distance is greater than this?
It will be the total number of cases minus the case that the two are the equal distance divided by 2.
Minus the cases that they are equal over 2, right?
Yeah.
And the cases that they are equal is what?
Isn't it 2 times 5 choose 2?
Not 5 choose. Look, it is 5 times 4, 5 times 4, so 40, right?
What?
So number of cases that are equal will be what?
Why is it 40?
No, I have not said. This is what number of cases that the distances are equal. It is what?
Well, I thought it was 20.
No, look, because here you said 110, right? You said 11 times 10. You didn't say 11 choose 2. You said 11 times 10. Now, when you want to consider this Q and
I have
R,
to do that.
you should say for this level 5 times 4, for this one 5 times 4, right? So 40. Agreed?
Okay.
So 110 minus 40 is what? 70. 70 over 235 over 110, right?
Yeah.
7 over... It will be choice A. You said choice A, right?
Yeah, but I got my answer wrong. But I got 9 over 22, so the most logical answer would have been A.
So that it is near to A, right?
Yeah.
So this way we can calculate. Okay.
Yeah.
And here you can say any of these two, and you want to find closed form of AN. Do you remember we solved the BMO problem with this idea? That was similar to this?
Yeah.
Okay.
We use like BN, but I don't remember that method anymore.
We use BN. BN was what, remember?
AN over 2.
It was what?
AN over 2.
No, AN over?
Oh, 2 to the power of n.
Exactly. 2 to the power of n. So we have this. Then if you want to rewrite main equation, it would be what?
It would be a Bn plus Bn minus Bn equals Bn minus 1 plus n minus 2.
Plus n minus 2?
Yeah.
No, careless mistake. One of you should correct it.
What is it? At n minus 2?
No.
Why isn't it Bn minus 1 then?
Because it is n minus 2 over something.
Oh, over 2 to the power of n.
Yes. Say.
What was the question? I didn't hear.
Okay, then do you agree we can solve it easily by telescoping sum?
Yeah.
Okay, so try to solve this with this way.
Okay. I'm not really sure how I'm supposed to calculate like the sum of n minus 2 over 2 to the
Well, okay, so we write it as n minus 2 over 2 to the n, right?
Yeah, and then Bn minus 1 minus
Bn minus 1 minus Bn minus 2 is what?
n minus 3 over 2 to the power of n minus 1.
Yes, it would be n minus. It would be n minus 3 over 2 to the n minus 1, right?
Yeah.
All the way to, can you tell me B1 is what?
B1 is equal to a half.
Yes, 1 over 2. So we write until B2 minus B1 is what?
0 over 2 half. Yeah, 0.
2 to the power of 2.
2.
So we can cancel like this, right?
Yeah, so you get...
So Bn is equal to 1 half plus 0 over 2 squared plus 1 over what?
2 to the power of 3.
Yes, 2 over 2 to the 4 to n minus 2 over 2 to the n, right?
Yeah.
So for I can say every identities, if all coefficients were 1, it was easy to calculate, right?
Yeah.
And because we know 1 plus 1 over 2, for example, plus, or let's write like this. For example, 1 over 2 to the a plus 1 over 2 to the a plus 1 to 1 over 2 to the b is what? If all coefficients are 1 in terms of a and b.
It's 1 minus I have an answer, but I don't think my answer's right.
1 thing?
Well, I know you're supposed to factorize 1 over 2 to the power of a out, and then you use the geometric theories on the rest, right?
Yes. One approach is this, and then try to simplify this and find it in terms of a and b.
Okay. I got a half to the power of a minus 1 minus a half to the power of b.
half to the a minus 1 minus a half to the power of b. Exactly. Yes. One approach is to factor from 1 over 2 to the a, right?
Yeah.
And then it will be 1 plus 1 half to 1 over 2 to the b minus a, right?
Yeah.
And you can say it is 1 over 2 to the a, 1 minus 1 half, 1 minus 1 half to the b minus a plus 1. Then it is 1 half, if we simplify, it's 2 to the a minus 1, 1 minus 1 over 2 to the b minus a. So it would be 1 over 2 to the a minus 1 minus 1 over 2 to the b minus a, right? b over 2 to the b, right?
Right. Yeah.
But let me tell you another approach is good. This approach is better because it's more general. But let me tell you also another approach. 1 over 2 to the a, 1 over 2 to the a plus 1. To 1 over, for example, 2 to the b minus 2 plus 1 over 2 to the b minus 1 plus 1 over 2 to the b, okay? Then I add 1 over 2 to the b and I subtract 1 over 2 to the b, so it has no effect, right?
Yeah.
Now 1 over 2 to the b plus 1 over 2 to the b will be what?
It will be 1 over 2 to the b minus 1.
Exactly. 1 over 2 to the b minus 1 plus 1 over 2 to the b minus 1 is what?
1 over 2 to the power of b minus 2.
Exactly. 1 over 2 to the b minus 2, 1 over 2 to the b.
1 over 2 to the b minus 3.
And this plus 1 over 2 to the a is what?
It will be 1 over 2 to the power of a minus 1.
1 over 2 to the a minus 1. So all of them 1 over 2 to the a minus 1 minus 1 over 2 to the b. Okay? Like this. Now, here all of them have coefficients, right?
Yeah.
So we want to get rid of these coefficients. Do you know triangular method is what? For calculating this.
Do I know what?
Means you write all of them with coefficient 1. So let's forget about 1 half. I write 1 over 2 cubed, 1 over 2 to the 4, all of them with coefficient 1. I think we solved, have we solved problem with this idea 1 over 2?
Yeah. Yeah.
Yes, all the way
Yeah.
to 1 over 2 to the n. And then you can find n and then an. So try this way.
Is Bn equal to 1 minus n times a half the n?
1 minus what?
N times 1 times a half to the power of n.
This?
No, n minus 1 times a half to the power of n.
This?
Yeah.
And it has also 1 minus this? This? Ah, okay. Yes, now it's
Well, I
working.
think I don't know.
Let's check here. It would be 1 over 2 squared minus 1 over 2 to the n, right? It would be 1 over 2 cubed minus 1 over 2 to the n. It would be 1 over 2 to the n minus 1 minus 1 over 2. And also we have 1 half. So Bn is 1 half plus 1 half squared to 1 half to the n minus 1, which is 1 minus 1 over 2 to the n minus how many 1 over 2 to the n do we have? N minus 2. So it would be 1 minus n minus 1 over 2 to the n. Good job. An would be what then?
An would be 2 to the power of n minus bracket n minus 1.
Exactly. Okay, so we found an and then we can solve the rest, right?
Yeah.
This way is easier than this way, I think, right? Or they are. Here also you use triangular method, right?
Yeah.
Okay.
Yes, yes.
Okay. It says 4 regular hexagons surround a square with a side length 1, each one sharing an edge with a square as shown in the figure below. The area of the resulting 12-sided outer non-convex polygon can be written. Okay. So we should calculate the area of the whole part. Now let's see what can we do. Here we can connect this and by symmetry it passes through this. Also, we want to split into smaller cases. If we connect the center, it will be this, right?
Yeah.
And this length is what?
1.
Yes. So, do you agree we can calculate this area, right?
Yeah.
Now, if we calculate this one, then the answer is what times this one?
8.
Yes. So we should calculate this area. This part is okay, so we should focus on this, right?
Yeah.
So the answer is 8, for example, A. And A is area of this part is what?
1/8.
Exactly. Now, how can we calculate this area? We agree we can extend this one and it passes through this, right?
Yeah.
Can you tell me this angle is what? This angle is what?
90 and 30.
Exactly. Okay, so you can also tell me this area is what? This area is what? Okay, can you tell me this area is what? So this area is easier than this area. Try to find this area first, okay?
Okay.
Look, you can find this area and then this area, and they are not hard. Want hints or want to try on your own?
I'll try my own.
Okay.
The rectangle is √3 minus 1 over 2.
Is what?
Square root of 3 minus 1 over 2.
Okay, let's see. Square root of 3 minus 1 over 2. Because we know this length is 1. If you draw this, it is 60. So it is a square root of 3 over 2. So the whole part is a square root of 3. I should subtract 1, then it is a square root of 3 minus 1, right?
Yeah.
And then it is 1/2. So square root of 3 minus 1 times 1/2, which is this. Good job. So if you find this area, then the problem will be solved, right?
Yeah.
One hint for this, Paul? Want to try on your own?
I'll try on my own.
Okay.
For the triangle, I got 1 over square root of 3 plus 1.
For this one, you got what?
1 over square root of 3 plus 1.
This?
Yeah.
Okay, so let's check. For this one, I connect this. If I find this height, the problem will be solved, right?
Yeah.
So, can you tell me this angle is what?
60.
And this angle is what?
45.
Yes. And why this one is 45? Because this one is 45, right?
Yeah.
So this one is x, this one is x. So this one is what?
X square root of 3.
X root 3. So we know x root 3 plus x is what?
Square root of 3 minus 1.
Exactly. So is this right?
Yeah.
And if you rationalize, it would be what?
2 over 4 plus 2 root 3.
But it would be
Oh,
this
wait, no.
times itself, which is 3 plus 1 minus 2 root 3.
Or 2.
So last one is 2 minus root 3 times root 3 minus 1 over 2. Agree?
Yeah.
So it would be what? 2 at first. Minus 2 root 3 plus root 3, 3 root 3. Minus 2 minus 3 minus 5, right?
Yeah.
Over 2. So is it this? You had careless mistake? In which part you had careless mistake? One of us has careless mistake.
I'll try.
Okay, try to see. You have careless mistake.
Oh, I found my mistake.
Okay, so my answer is correct, right?
Yeah, I think so.
Okay, so if we add these things, it would be what?
16 root 3. And then
3 root 3 plus root 3, 4 root 3 over 2 root 3, right?
oh yeah, 16 root 3 over 8.
Minus 5 minus 1 minus 6 over 2 minus 3 plus 1 over 8. And for the answer, we should multiply it by 8. Yes, 16 root 3, which is minus 24 plus 1, right?
Yeah.
So the answer will be what?
Negative 4.
So check the answer. Is it negative 4 in B?
Yes, it is.
Okay. Understand completely how we solve this?
Yeah.
Okay, great. Now let's try this. What's the first problem that you want to solve for from AMC 12A Fall 2021? I told you the most useful idea is what in AMC, AME, AMO, JMO, IMO?
Small example.
Exactly. And here we should solve it only by using a small example. So we should use a small example on what?
Instead of f sub 50, f1.
Yes, we should calculate for example f50 of 1 or something like that. So let's first see this. The 1 goes to what if you take f1? And we know f50 means that you should take f1 for 50 times, right?
Yeah.
So 1 goes to what by taking f1? 2. 2 goes to what?
4.
4 goes to what?
6.
6 goes to what?
8.
8 goes to what?
8.
So do you agree we can understand 1 to 4, 6, 8? These numbers are good or not?
Not good.
Not good, because f50 of each of them is what?
Just 8.
Yes. Now 3. 3 goes to what?
4.
Yes, do you agree 3 is similar to 2, right?
Yeah.
So we can generalize which numbers go to 4?
Prime numbers.
So prime numbers are not good. Also, for example, p squared are not good, right? Because of 4.
Yeah.
Because of 6, which numbers are not good?
PQ.
Yes, because of 8, which numbers are not good?
P cubed.
Yes, so the first number we should check is what?
PQR.
Yes, number. So we check 1, 2, 3, 4. Check the first number that we should check is what?
12.
Yes, 12 goes to what?
12.
Yes. So which numbers are good?
12 works.
So p squared q, right?
Oh yeah, p squared q.
Okay, like this, you should keep checking to check all 15 numbers. Want to try the rest on your own?
Yeah. I'll do
Okay, so look, the most important part in this problem is to not miss any of the cases, okay?
Okay.
Okay, try.
Okay. I think I solved it.
Okay, the answer is what?
10.
Yes, I think it was this. So let's check. So we have 12, we don't need to check 13, 14, 15, 16. 16 goes to what?
10, which goes to 6.
Yes, which is similar to PQ. Next number that we should check, 17, 18. 18 is good, right?
Yeah.
19, 20 against 2 squared, it goes here, right?
Yeah.
21, 22, 23, 24. 24 is the first number, p cubed times q. 24 goes to what?
P to the 4, which goes to PQ.
Yes, this forms itself, right?
Yeah.
25 p squared, 26 pq, 27 p cubed, 28 again is good. 2 squared times 7, right?
Yeah.
29 prime 30. 30 is the first number, PQR. 30 goes to what?
P to the 4.
Exactly. 31, 32. 32 goes to what?
12.
12. So P to the 5 is good, but we have only one P to the 5 because 3 to the 5 is larger than 50, right?
Yeah.
So we don't need to write P to the 5. 33, 34, 35, 36 is first P squared Q squared. 36 goes to what?
P squared Q, which goes to 12.
Goes to 18, right?
Yeah.
37, 38, 38, 39, 40. 40 is 2 cubed times 5. It's similar to 24, right?
Yeah.
Okay, so we check 40, 41, 42. 42 is similar to 30, 37. 43, 44 is good. 45 also is good, right?
Yeah.
46, 47, 48. We should check. 48 goes to what?
20.
Yes, I'm just. 49 is not good. 50 is good again, right? 2 times 5 squared. So 1. Let's write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 4, 6, 8.
Yeah.
10. Okay, good job. So we solve this only by using a small examples, right?
Yeah.
And this structure is so much useful that you consider a small example is not only a small example on numbers. We use a small example on a structure of the numbers when we prime factorize. For example, p squared, right?
Yeah.
We have also other problems in AMC that can be solved with this idea. Let me write a homework in SUMaC problems. We have one problem that you can solve exactly with the same idea. It's problem 2. Let me copy problem. Problem is this one. So try to do it as homework one, okay?
Okay, yeah.
So the roots are R1 and R2. R1 plus R2 is what?
Negative B.
Negative B. R1 times R2 is what?
C.
Exactly. And it says P of X has exactly 3 roots. 3 roots. So, can you tell me, because of this, if we consider delta of P of X, what can we say about delta of P of X?
It would be positive, yeah.
Positive. Because, look, when this one is 0, we can conclude P of X is what?
P of X. Oh, are the roots of P of X.
P of X is what?
R1 and R2.
Yes. And if delta is negative, so this one, we don't have any root here, right?
Yeah.
If delta is 0, we have 1 root here, so 1 root here, we have at most how many roots?
2.
Exactly. So delta should be positive, right?
Yeah.
So we conclude B squared minus 4AC or 4C is positive, right?
Yeah.
Okay. Now, P of X is R1 is X squared plus BX plus C minus R1 0. X squared plus BX plus C minus R2 is 0, right?
Yeah.
And we know R1 and R2 are not equal, right?
Yeah.
Okay. Now, because we have 3 roots here, what can we say here?
One of them has 1 root, the other one has 2.
Exactly. With all loss of generality here, we can say we have 1 root. Here we have 2 roots, right? Because here we have 1 root, we can say what?
The discriminant equals 0.
Yes, discriminant 0. Here, discriminant is what?
Greater than 0.
Yeah. Want more hint, or that's enough?
That's enough.
Okay, sure, fine.
Can I have a hint?
Okay, sure. So, we said R1 is not R2, and delta 1 is 0, delta 2 is positive, right?
Yeah.
Because delta 1 is 0, what can we conclude?
B squared minus 4 times C minus R1 equals 0.
Yes, and because delta 2 is positive, we can say what?
B squared minus 4 times C minus R2 greater than 0.
Now, V is what in terms of R1 and R2?
R1 plus R2. I mean,
Yes.
minus R1 minus R2.
V is R1 minus R2 whole squared, right here.
Yeah.
C is what in terms of R1, R2?
R1, R2.
Now, the rewrite this equation, you can find relationship between R1 and R2.
I tried that, but...
We tried that, okay, so let's calculate together. So R1 squared plus R2 squared is plus 2R1, R2 minus 4R1, R2 is what? Plus 4R1 is 0, right?
Yeah.
So we can conclude what?
R1 minus R2 whole
Whole
squared equals negative
4R1. Then what can we conclude? Now one thing, R1 is positive or negative?
Negative.
Yeah, so that's not equal to 0, right?
Yeah.
So we can conclude R1 minus R2 is what?
2 times the square
Plus
root
minus.
of negative R. Oh yeah, plus or minus 2 the square root of
Okay,
negative
and you
R1.
can reject one of them. Want me to tell you? You can reject plus or minus. I remember you can reject. Want to try it on your own or one thing?
Reject minus.
Why?
Because R1 is greater than R2.
Why R1 is greater than R2?
Because by the second equation, the inequality, you see b squared minus 4 times c minus R2 is greater than 0.
If you do the same thing for this, it would be R1 minus R2 all squared plus 4R2 is positive, right?
Yeah.
Then what?
Substitute R1 minus R2 whole squared into the inequality.
So R1 minus R2 squared is negative 4R1 plus 4R2, right?
Yeah.
So R2 is greater than R1. So this one is negative, right?
Oh, yeah.
So you should cancel plus sign, right?
Yeah.
So you found R2 in terms of R1. R2 is what?
R1 plus 2 square root of negative R1.
Yes, and the problem says sum of the roots is maximum, right?
Yeah.
Okay, so want to try the rest on your own or want more hint?
I'll try the rest of them.
Okay, sure.
Okay, I solved it.
Okay, can you explain?
Yeah. So we need to maximize R1 plus R2. So that's 2R1 plus 2 square root of negative R1.
Yes, then what?
And then I said R1, square root of negative R1 equals K. So now it's 2K squared plus 2K.
Negative R1 is K squared, you said?
Yeah.
So it is 2K squared plus 2K, yes. Then what?
And then to maximize that, K would be negative 1/2.
And you take derivative. You can take derivative or you can say K times K plus 1. Right?
Yeah.
And this one is something like sorry, this is negative 2K squared, right? Let me correct it. You said R1, negative R1 is K squared, so it's negative K squared plus 2K, right?
Oh, yeah.
So it is 2K times 1 minus K, because the sum, it opens down and it is 0, 1, the vertex. Or you can say the sum is maximum. The sum is 1, constant. When they are equal, it would be maximum. So K is equal to 1/2. Or you can take derivative and you can say, okay, negative 4K plus 2 is 0. So K is negative, let me see, negative 4K plus 2 is 0. So K is 1/2, right?
Yeah.
So R1 is what then?
So R1 would be negative 1/4.
R2 is what?
3/4.
Negative 1/4 plus 2 times 1/2, right? So 3/4. Good job. Now, B is what?
B would be 1/2.
Negative 1/2, right?
Oh, yeah.
C is what?
Yeah. And then C would be negative 3/16.
Good job. So P of X is what?
X squared minus 1/2 X minus 3/16.
The problem says P of 1 for this is what?
So, 5/16.
Yes. So it's 16. 16 minus 8. 8 minus 3. So it is 5/6. choice A, right?
Yeah. It wants maximum possible value of C when you take the points Z1, Z2, and whatever Z2.
Right. What 12 A 2020. It's a Z1, Z2 maximum. It wants maximum area. Okay, it is loaded now. Do you know that if we have a root Z conjugate is also a root?
Yeah.
Okay, so is it C is a real number, Z2, Z1, Z2 are roots of this. Can you tell me Z1, Z2 are what?
Conjugates. So you can say Z1 and Z1 times Z2 is Z1 squared.
No. Separately. Not product. Z1 and Z2 are equal to what? In terms of C.
In terms of C. Like using the quadratic formula?
Yes, correct.
Oh. C plus or minus the square root of C squared minus 40 over 2.
Right?
Yeah.
Okay, so what can we say about delta here?
It should be less than 0.
Yes, why? If it is greater than or equal to 0, we have problem.
Then those would be Z1 and Z2 would be real numbers.
Yeah. So what's the problem?
Then it wouldn't get maximum value.
Yes, area would be what?
0 would be 0.
Exactly, because real numbers are also complex numbers, right?
Yeah.
So because of this, we cannot say because it's a Z to Z1 are complex numbers, then we have to, because the area is 0. Now, can you tell me what's the relationship between Z1 and Z2?
Oh yeah, complex conjugates.
They are conjugate of each other, right?
Yeah.
Can you, so lengths of them are equal, right?
Yeah.
So lengths of them are equal to what?
Square root of 10, because of Vieta's formulas.
Let's see. C squared over 4, it's real number, right? But because it has I, right? I times something. So you should write minus, right?
Yeah.
So it is 40 over 4, which is a square root, right?
Yeah.
And good job, it is a square root. And then we should try to draw the diagram. We should determine z1, z2, 1 over z1, 1 over z2 in the diagram, the complex plane, and then you can calculate the area in terms of c. Then you can maximize. Want more hint, or that's enough?
That's enough.
Okay, sure. Try. Want hint, or wanna keep trying?
Hint.
Okay, sure. So, for example, suppose z1 is something like this, okay? Okay. z1 is something like this, right? And z2 is something like this, right?
Yeah.
So z1 is this, z2 is its conjugate. 1 over z1, where is 1 over z1?
1 over z1, I got that to be conjugate. I got that to be z2 over 10.
Yes, but when we want to calculate 1 over z1, suppose this angle is theta, okay? z1,
Okay.
for example, is REI theta. z2 is what? Polar form of that.
RE negative I theta.
Good job. 1 over z1 is what?
1 over r times
EI.
e to the negative I.
Negative. So 1 over z1 is here, right?
Yeah.
And the length of 1 over z1 is what?
1 over r.
Yeah, so it is equal to what number?
1 over square root of 10.
Exactly. So z1 over z1, the angle is negative and it will be something like this, right?
Yeah.
Because this is root 10 around 3 point something. This one is less than 1, right? Agree?
Yeah.
Okay. This one is 1 over z2, right?
Yeah.
Now we should calculate this area in terms of c, right?
Yeah.
It is a trapezoid, isosceles trapezoid. Want hint for calculating this area in terms of c, or want to find it on your own?
I'll do it on my own.
Okay, sure.
Okay, I think I got the answer.
Okay, can you tell me how you calculated the area?
Yeah, so it's a trapezoid. So I said z1 equals a plus bi and z2 equals a minus bi.
Uh-huh.
Then using a and b, you can express the two bases and the height.
Yes. So this one is what? Can you tell me this one is what?
That would just be a. If
Yes, but
z1
in
is a
terms
plus
of
bi.
c, it is what?
C over 2.
Exactly. And if c is negative, we should consider this on the left side of y-axis, right? And similarly, we reach same area. So this c over 2, and this is what? This length.
C C over 20?
Yes, exactly. C over 20. So, now this length is what?
Oh, 10 minus c squared over 4. I mean, square root of 10 minus c squared over 4.
Why 10?
Because the magnitude of z1 is square root of 10.
So this length is the square root of on. We want to calculate this. We can also use it is imaginary part of z1. So it is 40 because we said discriminant is negative. It is square root of 40 minus c and over 2, but because we consider this agreed or want me to explain?
Yeah.
This part is this
I
one
agree.
over 2. Agreed?
Yeah.
On, you said a square root of 10 minus this inside the square root you consider like that, right?
Yeah.
Okay. So it is this. This length is what?
That's over 10.
Exactly. 40 minus. Okay, we don't need to calculate it. So area of this one is what?
C over 2 times square root of 40 minus c squared over 2.
If we want to calculate this area, we should multiply it by what?
9/10.
Exactly. So it would be 9c over. And it wants to find only c, right?
Yeah.
So 40, this one. We should maximize this, right? And we consider c is positive, right?
Yeah.
Okay, so maximum of, we can ignore the coefficient, this one, and c is positive, so c is what? So here, how can we calculate maximum of this?
I think AMGM.
AMGM?
Yeah.
Okay, so by AMGM, this one is less than or equal what?
40c cubed minus c cubed over 2.
C cubed?
I mean c squared over minus c cubed.
C squared plus 40 minus c squared over 2 square root of this, square root of this, right? This is 40 over 2, which is 20, right? So maximum is 20. Agree?
How did you get c squared plus 40 minus c squared?
The x squared plus, or let me write like this, x plus y over 2. Do you agree is greater than or equal to square root of xy?
Yeah.
So it is x, it is y over 2 square root of this times this. You can take it outside the square root of
yeah.
It is 20.
Okay.
So c is what?
C is
Equality holds when what?
Oh, when they're equal. So
C is equal.
c squared is square root of 20.
So c squared is 40 minus c squared. So c squared is 20. So the square root of 20. And if you see the choices, which choice is the answer?
A.
Yes, but now I want you to find a square root of 20 with 2 decimal digits. Okay? It is what point? So obviously it is 4 point, what? I told you the algorithm before, right?
Oh yeah.
Okay, so calculate.
I forgot the algorithm.
Okay, let me tell you, pay attention because in some problems we need. Here, I think you can calculate it fast. So when you want 2 decimal digits, you should add how many zeros?
2.
4 zeros. For each decimal digit, 2 zeros, okay? Then from right, you should split 2 digits 2 by 2. Then you say 4 times 4 is 16. Then 4. Then you should add next two digits here, 0, 0. Then we should write what here?
6?
No. Then we have 4. If any number that you have here, you should multiply it by it.
Okay.
Then we should place what in the circles?
5. Oh, no, 4.
84. For 4, 4, 16. We have 1. 4 times 8, 32, 33. So then you place this 4 here. 40. Then here I should 400 minus 336 is what?
64.
Exactly. Then I should add what here?
The 2 zeros.
Then I should place what here?
1 6.
No, look, we have 44 here. You should multiply by
88.
80. Then we should place what in the circles?
7.
Exactly, 7. So if we place 7, 7 times 7, 49, we have 4. 7 times 8, 56 plus 4, 60. We have 6. 7 times 8, 56 plus 6, 62. And then 10 minus 9, 1. Here it is not important to calculate because we wanted for this one, but you can calculate 4.46. Check it with the calculator. Is it correct?
Okay. Yeah, it is.
Okay. So we solved this one, problem 22. And also we could solve it from here. We used AMGM here, right?
Yeah.
Do you know derivatives? Derivatives, for example, taking derivatives here.
Yeah.
Okay, so we can say because c is positive, we can take it inside the square root. So we should maximize 40c minus c, 40c squared minus c to the 4, right?
Yeah.
Okay, so if you take derivative here, it would be 80c minus 4c cubed is equal to 0, right? Yeah. Then you can divide by c and you can divide by, so 80c is equal, let's write 4c cubed. If you divide by this 20, so c squared is 20, so c is the square root of it, right?
Okay.
Okay, so we solve this one. What's your next question?
Sir, you're below, like below homework 2. You put homework 1.
Below homework 2. Okay. So could you prove this?
Yeah.
How?
So if you square it, then you can say that's equal to z1 times z2 times complex conjugate of z1 times complex conjugate of z2.
Yes, you use this, yes. We can also say it is r1 ei theta 1, z2 is r2 ei theta 2. So
Yeah.
z1 z2 is equal to r1 r2 ei theta 1 plus theta 2, right?
Yeah.
So both sides are, this one is r1, this one is r2, this one is r1 r2, right?
Yeah.
Okay, good job. Homework 2, how could you solve this problem?
I tried it, but I couldn't solve it.
Okay, no problem. Let's try together. So here, by homework 1, we could prove it, right?
Yeah.
Okay. Now we have these two. Let's consider. Let's consider this one. And so let's erase all the things that we don't need. We know omega 1 and omega 2. And we have, for example, a straight line. So it says z minus omega times z minus omega squared. The product is 4, right?
Yeah.
And it says the maximum value of the imaginary part of z. So, for example, suppose z is here. And z, this distance, this length times this length is 4, okay?
Okay.
Now, if I consider, if I change this z to this point, so suppose it is z1. Can you tell me, suppose this is, can you tell me, do you agree z1 minus omega, and let me write these two lengths, which of them is greater?
Z minus omega.
Exactly. Suppose it is L. We want to prove z belongs to L. If z doesn't belong to L, this is greater than this. And what about z minus omega squared and z1 minus omega squared?
Z minus omega squared is
Exactly.
greater.
So the agree from here, we can conclude z1 minus omega times z1 minus omega squared is less than, we can say it's less than what?
Less than z minus omega times z minus
Yeah,
omega
so
squared.
this product is what?
That's 4.
Exactly. So this is a concept. Suppose z is the best point. If z is the best point and z doesn't belong to L, then if you consider z1, it is less than that. So because it is less than that, do you agree you can move z to z2 to satisfy this condition? Because when you move upward, then we can say, for example, this distance and this distance, this one will be increased, right?
Yeah, yeah.
So we can reach z2 such that z2 minus omega times z2 minus omega squared is equal to 4, right?
Yeah.
And now, do you agree if we consider imaginary part of z2 and imaginary part of z1, which of them is greater?
Z2.
Z2. And imaginary part of z1 and imaginary part of z, what's the relationship between?
Equal.
They are equal. So do you agree that's a contradiction? We said suppose z is the best point.
Oh, yeah, yeah.
So we found a better point, right? And do you agree we can say
Yeah.
these points are on top of this part because if it is here, instead of that, you can consider this because it is symmetric about the x-axis, right?
Yeah.
Okay, so now and at the end, the point that we find is on top of here. So now we can say that because we reach contradiction, so z belongs to L, right? Z lies on this line.
Yes.
Want to try the rest on your own?
Yeah.
No, try. Want hint?
Yes.
Okay, sure. So, look, do you agree z belongs to L? And this point is what? It is real value.
Hmm.
Do you know how to calculate real value of this?
Yeah.
So it is what? Tell me.
Minus 1/2.
Minus 1/2. Let's check. Because W is, also you can say it is 60. It is, yes, minus 1/2. So we know z belongs to L. So if we consider new figure, because z belongs to L, then we can consider this one as z, right?
Yeah.
Okay, so z is negative 1/2 plus, for example, y coordinate, right?
Yeah.
Z minus omega times z minus omega squared is 4. Z minus omega is what in terms of y?
Y minus the imaginary part of W, which is
It is z is yi, so z minus omega length is what? Want me to tell you it is y minus what, or want to find it on your own?
Y minus square root of 3/2.
Exactly. And z minus omega squared is what?
That would be y minus 3/4.
No.
Oh, y plus 3/4. No, y plus square root of 3/2. Yeah.
Yes. So want more hint, or that's enough? And then we should find y is what? Okay. The problem, let me check
yeah, that's
just,
fine.
it says the maximum value in the form is root m over n. It is root m over n, and you should find y. Want to try the rest on your own?
Yeah.
Okay, sure, try.
So y is square root of 19 over 2.
So the answer is what?
21.
Yes, so 21, let's check. Y squared is equal to 4 plus 3 over 4, which is 19 over 4. So y is positive, is square root of 19 over 2. And yes, the answer is 21. Understood how we solve this?
Yeah.
Okay.
Yeah, I did 12a.
Okay, and yeah, is there any question you got stuck on?
Let's see. 23.
Problem 23
Yes.
of 12a, right?
Yeah.
Do you know AMGM?
Yeah.
Okay, so if you apply AMGM, you can reach some good results here. Want more hint or that's enough?
More hint.
Sure. So, can you tell me by AMGM 1 plus 2a is at least what?
Square root of 2 times the square root of 2a.
For all of them, you should write and then solve. Want more hint or that's enough?
Oh, that's enough.
Okay, sure.
Would it be 1?
1 is that?
Yeah, because if you
Can you explain?
yeah, so if you do AMGM on all of them and then multiply together, you get it's greater than or equal to 32ab.
Exactly. 2 plus 2b is greater than equal what?
4 times the square root of b.
Good job. 2a plus b is greater than equal what?
2 square root of 2ab.
Yes, and if we multiply because they are positive, we can multiply the problems that they are positive. Each term also here positive, so 2a plus b greater than equal 2 times 4, 8 times 2, 16, root 2, root 2, 2, 32, root a, root a, root 3, root 3b, so 8. Then what?
And then it also says that it's equal to 32ab.
Exactly.
So that means only 1.
So we know equality holds. So for each of them, equality holds, right?
Yeah.
Okay, so because of this one, because it is equality, because equality holds here, we can conclude what?
Only one solution.
No. Here, only focus on this. Do you know in AMGM equality holds when what?
I forgot.
When terms are equal. Okay?
Oh, yeah.
So from the first one, we can conclude what?
A equals negative 1/2.
Why negative?
No, never mind. 1/2. Yeah.
Yes, 1 is equal to 2a, so a is 1/2, right?
Yeah.
From this one, what can we conclude?
B equals 1.
1/2. Well, no, sorry, it's 1. From this one, what can we conclude?
A is 1/2 and B is 1.
No, they are equal. 2a is big.
Oh, yeah.
If we combine all these, 3a is 1/2, b is 1, right?
Yeah.
So we have only one solution, right? So
Yeah.
let me just check two inequalities that are important. Suppose x1, x2, and a to xn are positive real numbers. Then we can say maximum of xi is greater than equal square root of x1 squared all the way to xn squared over what? Over n. It is QM, quadratic mean. Next one is AM, arithmetic mean. X1 to xn over n. Geometric mean is what?
Multiply and then take the nth root.
Square root of n, x1 to xn, it is geometric mean. You know hm is what harmonic mean?
Yeah, 1 over a plus 1 over b, and then yeah, n over that.
N over that. Yes. And greater than equal minimum of xi, okay? And for
Okay.
each of them, this one, if this one is equal to this one, or this one is equal to this one, any of them, for any of them, equality holds when x1 is equal to x2 is equal to xn, okay?
Okay.
And you should memorize this. Next one that is important is Cauchy-Schwarz. Have you heard that?
Yeah.
It is what?
Like x1 squared plus x2 squared plus dot 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 plus xn squared, and then multiply by y1 squared plus y2 squared plus dot 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 plus yn squared, and that's greater than or equal to x1 y1 plus x2 y2 plus dot 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 plus xn yn, and that squared.
Let me write plus yn squared is greater than equal, yes, x1 y1, x2 y2 to xn y. And equality holds when what?
I think it's when x1 over y1 equals x2 over y2.
Yes, over y1 is equal to x2 over y2. Is equal to xn over yn. And xi, yr are belongs to what numbers?
Positive real numbers?
No, real numbers. Because it is a square, this one should be greater than equal to 0. x1 can be positive or negative, okay?
Okay.
So here I told you these two and you should memorize. It was problem 20. Okay, what's your next question?
Sine.
Sine,
Sine
yeah.
over cosine.
Over cosine. Okay, so this part should be related to sine. This next one cosine, probably. Okay.
Okay.
How can we calculate sine of 2023x?
Using identities.
We should work on which complex number to calculate these two things. E to the power of what?
E to the I times 2 pi over 1.
No, 2023x, because we want to calculate sine of that, right?
Oh, yeah, okay.
And we have two formula for it. It is equal to what?
E to the ix.
No, I mean, you can say
cos. Like cosine of 2023x plus I sine of 2023x.
Exactly. Also, we can say it is equal to e to the ix to the power of 2023, right?
Yeah.
So by this approach, we can write it as what?
So we can say
cosine what to 2023? There is cosine
of
x
plus I sine of x, yeah.
Exactly. Now, if you compare this part and this part, you can find a formula for this. So related to this, a formula to this, and you can write it and then try to make it similar to this. Want more hint or that's enough?
More hint.
Okay, sure. So, the agree cosine of 2023x is imaginary part of this.
Cosine.
It is imaginary part. It is real. It is real part. It is imaginary part, right?
Yeah, yeah.
Okay, and can you tell me this is equal to what? You can say this is equal to cosine x to the 2023.
Plus
2023. Choose one.
Yeah.
Cosine of x, the power of 2022. I sine x, right?
Yeah.
Plus, and then next one will be minus 2023. Choose 2 cosine x to the power of 2021 sine x squared, right? And so
Yeah.
on. So we know this part plus this part, all of them are related to cosine x, right? And these
Yeah.
parts related to this. So do you agree for each of them you will find a sigma like these things?
Yeah.
And then you should write, for example, look for numerator, for denominator. Do you agree it would be cosine x 2023 minus 2023, choose 2 cosine x to the power of 2021 sine x, right? Sine squared x. And for numerator, you will write 2023, choose 1 cosine x to the power of 2022 sine x, and so on, right?
Yeah.
Next one is 2023, because I cubed is negative I, so it would be this. Cosine 2020 sine cubed, right? Times
Yeah.
I. So it would be minus 2023. Choose 3 cosine 2020 x sine cubed, right?
Yeah.
And so on. So you should write all terms, and pay attention to here and solve the problem. Want more hint or that's enough?
That's enough.
Okay, try.
I think I solved it.
Okay, can you explain?
Yeah. So if you divide all terms by cosine to 2023, and then you can turn them all to tangents, and it looks
You
like
want to divide all of them by cosine 2023, right?
yeah.
Then let's see what happens. This one will be 1. This one will be tangent squared, right? This one with tangent x, tangent squared x. This one tangent cubed x, right?
Yeah.
Okay, so a 2023 would be what then?
I think -1.
Negative what, choose what?
Negative 2023, choose 2023.
Yes, and as you can see, for 4k plus 1, it is plus. For 4k plus 3, it is minus. 2023 is 4k plus 3, so it's -1, right?
Yeah.
Okay, good job. What's your next question?
So the first one is 0, 0, then 0, 0, and then 5, 0.
O1 is 0, 0, and radius is what?
2.
O2 is what?
0, 0, 8.
O3 is what?
5, 0, and square root of 3.
And radius is. And it says we should find circles that are tangent to all of them, right?
Radius of the third one is square root of 3.
Ah, sorry. Square root of 3. And we should find the circles that are tangent to all of them, right?
Okay.
Okay, so if we draw x, y axis, so the first circle is, for example, 2. Next one is 8. 2, 4, 6. So let me make it larger. 2, 4, 6, a bit larger. It will be something like this. And the next one is 5, 0. So this is 8. Let me minimize it. 8 is 2. And the next one is 5. There's midpoint here. and the radius is √3. So it would be something like this. Okay, now we should find circles that are tangent to all. Could you find any circle that is tangent to all of them?
Yes, I didn't know how to like calculate it.
How many circles could you find?
I found 4.
4, you said?
Yeah.
Okay, let's check. One of them is this one and this one, right? It would be 2.
Yeah.
Next one is what? So let's do something. Let's do something. Let's first focus on this, and let me draw it with pink. And this one is tangent, like this. Okay, can you tell me? So the radius of these. So here we have 2 of this type, right?
Yeah.
So area 1. 2 times the radius of this. Calculate the radius of this circle. Okay.
Would it be 3?
It's what?
3.
3.
Yeah.
Because you connect this one.
Yes.
And you say, okay, it is 2, it is 8, so it is 6. 6 divided by 2 is 3, right? So it would be pi times 3 squared. So it is 18 pi, right?
Yeah.
Okay, now what's the next circle? Tangent internally or externally?
Internally to the
Internally to
smallest-
large one. What about these 2 circles?
Externally to the medium circle and outside of the second one.
Outside of both of them?
No, outside of the first one. But outside of the second one, but inside the first.
Look, we have this is, for example, suppose it is circle 1, circle 2.
Yeah.
So
Okay,
externally to C1 or internally or what?
It'll be externally to C2, and then it'll be like around C1.
Like this, right?
Yeah.
Okay. Internally with C1, externally with C2, right?
Yeah.
A bit smaller. So it is this, right?
Yeah.
So again, we have 2 of these, right? Area 2, 2 pi. The radius is what?
I think radius 5.
It is 5 because look, it's easy. You can connect this one to this one. Do you agree? All these centers are concurrent centers and these points, right?
Yes.
Okay, so let me check to make sure. Not necessarily this one, but if you connect these 2 centers, they are concurrent. And the reason is this: if you have 2 circles like this, if you draw this common tangent, if you draw perpendicular, it passes through centers, right?
Yeah.
That's the reason. Centers and this point are concurrent. And if you connect this center and this center, right?
Yeah.
They are concurrent. And you can see what I am thinking of. So let's consider this circle is C1, C2, C3. This center is O1 and O3, right?
Yeah.
Because it is O1 and O3, suppose this circle is C4. Do you agree O4 and this point and this center are collinear, right?
Yeah.
And do you agree this center and this common tangent are also collinear, right?
Yes.
So all of them lie on the same line. So this one is 2, this one is 8. Sum of them is 10. If you divide it by 2, it would be 5, right?
Yeah.
So 25, 50 pi. You could find only these 4 circles?
Yeah. I think I found
If you pay attention to internally, look, C1, we said C1 is the first one. Here for C1, C2, both of them were externally, right?
Mhm.
Externally. Here for C1, C2, they are tangent, internally, externally, right?
Yeah.
Then in the next case, we should consider what?
We can do internally.
Yes. So the radius would be what in this case?
Let's see.
Draw it and calculate it.
Okay. I think it's also 5.
It is also 5. Okay, let's check. It is something like this, right?
Yeah.
And again, like previous one, you can connect this one and say 5. So it is 2 pi, 25, 50 pi, right?
Yeah.
Area 3. And last one would be what?
Internally. Oh wait,
You can't say internally, externally, right?
Yeah.
So if you consider this one, C1 externally, C2 internally, the radius is what?
I think 3.
It is 3, exactly. C2 internally, C1 externally.
Yeah.
Like this, and then you can connect this. It is 2, it is 6 over 2, 3. So area 4 is 2 pi, 9, 18 pi. So the answer is what? 18 pi, 50 pi, 50 pi, 18 pi.
Yeah, so 136 pi.
Yes. 136 pi. Understood?
Yeah.
Okay, what's your next question?
So then I get the answer is 50.
It is 50. So, for example, here, if we can say it is 0 by 1/2, it is 50, right?
Yeah.
Then this one should be 0. Then from this one to this one, we go to what?
Negative 50.
Negative 200, right? But do you agree if we want to consider from this one, we cannot reach this?
Yeah.
So you used how you reach 50?
So I did if you go from 900 to 800, you get the y-axis is the y-coordinate. I think
let me just check something with you. For 800 to 0, do you agree we can consider it is 0 and the slope would be what from 50 to 100? Here slope would be what? Can you say?
Negative 1/8.
Negative 50 over 400. Negative 1/8. And it's good because the slope is better than 1. So you can reach 0 and then we can say okay. From here we can consider constant, right?
Yeah.
Okay, so By this example, we could reach 50. So the answer is greater than or equal to 50 or less than or equal to 50.
That's greater than or equal to.
Now, if answer is 50, you should prove that y is at most 50. Understood?
Yeah.
Okay. Okay, try to prove it.
Can I have a hint?
Okay, one hint.
Yeah.
Sure. So we know f of 300 is equal to f of 900, right?
Yeah.
So for example, one way is this. We can say f of 800 minus f of 400. This one is, let's see, can we use something like triangle inequality? Do you agree we have this?
Yeah.
So we can say what? We can say
Let's assume f of 800 absolute value minus f of 400 absolute value.
f of 800, for example, minus f of 900, okay? Plus f of 300 minus f of 400. Agreed this?
Okay, yeah.
Because look, it is A, it is B, this one is A plus B, because f of 300 is equal to f of 900, right?
Yeah.
Now by considering this, try to prove it's at most 50. What more hint, or that's enough?
That's
Okay.
Oh, it gets 50. 50.
Okay, how?
So f of 800 minus f of 900 absolute value is equal to 25.
S is less than 1/2 times 1/2 times difference 100, right? Plus 1/2, 120. So 50. So we prove it is at least 50, at most 50. So the answer is 50, right?
Yeah.
Okay.
So I tried finding S1 and S2.
Do you know induction?
Yeah. Like proof
Okay.
the base case.
Yes, and we can prove it at the end by induction, but let's first focus on x0. So look, Sn is what? Is x0 plus 2x1 to 2 to the n minus 1, xn minus 1, right?
Yeah.
So x0 here we have this condition. If you can say n1, it means that 7s1. S1 is x0. It's congruent to 1 mod 2, right?
Yeah.
Because 7 is 1 mod 2, so we can say x0 is 1 mod 2, and because xi's, it says, are either 0 or 1, so x0 is 1, right?
Yeah.
And then if you can say n2, n3, so try to find we found x0, try to find x1, x2, and x3. Find all these 4 x's, okay?
X1 equals 1, x2 equals 1, and x3 equals 0.
Exactly. So it is 1, it is 0, it is 1, it is 1, 1, 1, 1, 0. Okay, so let's check. For this one, it is 7x0 plus 2x1 is congruent to 1 mod 4. And then x0 is 1, so and 7 is negative 1 mod 4. So we can conclude negative 1 minus 2x1 is congruent to 1 mod 4. So we can conclude 2x1 is congruent to negative 2 mod 4. Then if we divide both sides by 2, we can say x1 is negative 1 mod what?
2.
Yes, and can you tell me if AB is congruent to AC mod M? It is equivalent that B is congruent to C mod what?
GCF of M and A.
M over GCD of
M
M.
over
Because GCD of 2 and 4 is 2, so mod 4 over 2 mod 2. So x1 is 1, right?
Yeah.
Now if you consider n3, 7x0 is 1, 2x1, 4x2 is congruent to 1 mod 8, right?
Yeah.
So 7 is -1, and we can multiply both sides by -1. So 3 plus 4x2 is -1, right?
Yeah.
So we can say 4x2 is congruent to -4 mod 8. So we can divide again both sides by 4. So x2 is -1 mod what?
2.
Exactly. So we can conclude x2 is 1, right?
Yeah.
Now n4, we can consider 7, 1 plus 2, 3 plus 4, 7 plus 8x3 is congruent to 1 mod 16, right?
Yeah.
So here we can say 56. Let's do something. Yeah, we can multiply both sides by 9. By -9. And
yes.
-63 is mod 16. What mod?
-1.
Is 1. 63 is -1. -63 is 1, right?
Oh, yeah.
So we can say it's -9, right? Mod 16. Agreed. So if you subtract 7, 8x3 is -16, mod 16. So if you divide both sides by 8, x3 is equal to -2 mod 2, which is 0. So x3 is 0, right? Now, can you guess which xi's are 0?
3 mod 4.
3 mod 4, yes, it can be, but let's consider something. You calculated x1, x2, x3, now calculate x4, x5, x6. Calculate these 3 x's, okay?
I got x4 is 1, x5 is 1, x6
x6 is what?
0.
Exactly. So now let's rewrite them. x0, 1, x1, 1, x2, 1, x3, 0, x4, 1, x5, 1, x6, 0. Can you guess which numbers are 0?
Mod 0 mod 3.
Exactly. And now let's do something. Let's calculate other cases together. For n5, you should say 7 times 7 plus 8, 16x4, right? Is congruent to 1 mod 32. Agreed?
Yeah.
Then for 7, we can multiply first by 5. So it would be 5 times 7 is 35. So it's 3. 7 plus 16x4 is 5, right?
Yeah.
Then we should multiply by 11. So if you multiply by 11, it would be 1. 16x4 is 55. 55 minus 32 is what?
40. I mean, 16. I mean, 13.
Yes, it's 23, right?
23.
So 16x4 is 16 mod 32, right?
Yes.
So x4 is 1 mod 2, so x4 is 1.
Yeah.
Now for x5, should consider n6. So 7 times 7 plus 16, 23, plus 32x5, right? Is congruent to 1 mod 64, agreed?
Yeah.
Then we can multiply both sides by 9, or -9, right?
Yeah.
So it would be -9. And here 23, so 32x5 is congruent to -32, right?
Yeah.
Then you can divide by 32, and it would be 2. So x5 is 1, right?
Yeah.
Okay, and let me check. X5 is 1, yes. And 7, then 7 times 23 plus this is 55 plus 64x6, right? It's congruent to 1 mod 128, right?
Yeah.
Okay, so here, if we should multiply 7 by what near 1 to 8? 1 to 8 is what mod 7?
2.
Yes, it's 7 times 158. 8 plus 2. So because it is 2, so we can multiply it by 8. It is not good to multiply by 18. But let's do something. Why it's not good to multiply by 18? Look, it's important because it is even. When you multiply by 18, you will miss some informations. Understood?
Yeah.
But we can, for example, multiply it by 19. If we multiply it by 19, 7 times 19 is what? 133, right?
Yeah. Okay.
19. And 133 is 5, right?
Yeah.
Mod 128. Then you can multiply it by 130 over 5, right? 130 over 5 is 130 over 5 again is even, so let's multiply it by 25, okay? So
Okay.
we agree it would be -3.
Yes.
So it's 19 times 25. Mod 128. 128 mod 3 is what is 11, right?
Yeah.
129 is multiple of 3. Oh, now that's good. So if we multiply by that, it would be -129 times 55 plus 64x6 is congruent to 19 times 25 times, I think I made a mistake. 5 is not negative. No. 5 times 25 is 1 to 5, it's -3. No, that's correct. So this one times 43, right?
Yeah.
And we know that you can add 1 to 8, it is negative. So 55 plus 64x6 is congruent to -19 times 25 times 43, right?
Yeah.
Okay, now we can simplify this. You can say it is equal to 5 times 5 times this. It's 215, right?
Yeah.
215 mod 1 to 8, you can subtract 256, right? So it is
Yeah.
negative what? 41, right?
Yeah.
So it would be 19 times 5 times 41. Agreed?
Yes.
5, it is 19. 5 times is 205, right?
Yeah.
205 is what?
77.
Yes, or -55. -51, right?
Yeah.
Okay, so here we can do what? We can also do something instead of that, because it is multiple of 5. We can do something. We can say that 64x6 is congruent to 5 times 4 times 19 minus 11. Agreed?
Yeah.
4 times 19 is what?
76.
But here we have one problem. It shouldn't be odd. Look, it is odd. Also, this one should be odd. This one is 41, not 4, right?
Yeah.
Okay, 41. 19 times 41 minus 11, right?
Yes.
19 times 41 is what is 19? 4 times 9, 36, 76. So 977, right? 779 minus 11 is what? 867, right?
Yeah.
And if you divide by 64, is 5 times what?
1, 2. 12. 16.
Mod 2, right? 0. Agreed, because 7, 6, 8.
Oh, yeah.
If you divide by 64, if there's 1, 64. to 1 to 8 times 2. Okay, so we prove x6 is 0. Your solution was different for finding x6?
Yeah, slightly different.
You used what?
Instead,
Your solution was easier. Your solution was easier, or my solution?
I think your solution.
Okay, there are lots of ways that we can try. Let me tell you also one more thing. Let me tell you another way. Look here. If we can get rid of this 7, it would be good, right?
Yeah.
1 is not multiple of 7. If you add 1 to 8, 1 to 9, is it multiple of 7 or not? Not, because 70...
So 1 to 6 is multiple of 7.
Okay, so 70, 59, it's not multiple of that. If you add 1 to 8, it would be what? 257, right?
Yeah.
Is it multiple of 7? No, right?
Yeah.
If you add again 1 to 8, it would be what? 8 plus 7, 15, 8, 3, right?
Yes.
385, is it multiple of 7? Yes.
Yeah.
So 55 plus 64, x6. If you divide it by 7, it would be what? 50.
55.
Mod what?
1 to 8.
And then 64 x6 is congruent to what?
0.
Do you agree this one also is easier?
Yes.
Okay, look, there are lots of ways. It's good to know all of them to see which of them is better. So we found these things, and you guess, okay, x submultiples of 0 is 0. So the first one, x2019, is what?
That's 0.
This one is 1, 1, 0, right? So the answer is what?
6.
6. If you want to make sure that it's correct, we should prove it by induction, right?
Yeah.
And do you know here how we can use induction?
So we say we could say for n equals 3 to the k, 3k plus 1, it'll equal x k equals 0. And then we do it for k plus 1, and then k.
Yes, our claim is xn. If 3 divides n and n is at least 3, is 0. Otherwise, it is 1, right?
Yeah.
And for base case, you can say, okay, n 0, 1, 2, 3, right? You should write them. And then you should consider, okay, for n 0, 1 to 2, 2, for example, n, or for example, k, you know it's correct. You want to prove for k plus 1, okay? Or until k minus 1 it is correct. It's satisfied. You want to prove k, and k is at least 4, right? Then you should consider 3 cases. K, if k is 3q, k is 2. If k, you should prove here why x3q is 0, right?
Yeah.
If k is 3q plus 1, and here we know it is at least 6 because we proved 3. Here you should prove x3q plus 1 is 1, and we know it is at least what?
At least 1.
4, because 1 is in our base case. Okay. And k3q plus 2, it is at least what?
5.
And x3q plus 2 is, we should prove it's 1, right? Now let's prove one of them together, and then you can prove the rest as homework, okay? It is important. This part, especially full solution exam, like what? You want to prove each of them?
The first.
Okay. So try to prove first case by induction first on your own, and then we try together, and then the rest as homework. Okay, so focus on proving this.
Okay.
One hint or want to keep trying? Okay, sure. So we know that for 1 to k minus 1, that's correct, right?
Yeah.
So we should consider n what to find this n 3q plus 1. Agreed?
Yeah.
Then 7 times x0 plus 2x1. So we know x0 is 1, right?
Yeah.
So, or we can say x0 plus, let me write first like this, to the 3q minus 1 x3q minus 1 plus 2 to the 3q x3q, right?
Yeah.
It's congruent to 1 mod what?
2 to the 3q plus 1.
Exactly. Okay, so if we consider this part, we know we can write it as 1 plus 2 plus 2 squared plus 2 cubed. 2, let's write 2 3q minus 1, 2 3q, okay? Let's write all of them. Then minus, we don't have 2q, we don't have 2 to the 6, to 2 to the 3q, agreed?
Yeah.
Can you tell me 1 plus r to the m is what?
1 over 1 minus r times 1 minus r to the m plus 1.
You can write it also like this or this, right?
Yeah.
Okay, usually when r is greater than 1, we use this. So, can you tell me this part is what?
That would be 2 to the 3q plus 1 minus 1
Finish over 2
yeah.
minus 1, which is 1, right?
Yeah.
What about this one?
That one would be 2 to the 3q. No. 2 to the 3q plus 3 minus 1 over 7.
Over 7, but minus 1 because it's not started with 1. Right? Because we should start with 1. Agreed?
Yeah.
Yes. Or you can say we factor from 8. It is from 1, 8 squared to 8q minus 1. So it is 8q minus 1 over 7, right?
Yeah.
So 7 times 2 to the 3q plus 1 minus 1. And 7 times this is plus 8 times 8q minus 1, right?
Yeah.
Plus 7 times 2 to the 3q x3q is 1 mod 2 to the 3q plus 1, right?
Yeah.
Okay, so here, directly we can cancel this. It is 0 because 2 to the 3q plus 1, right?
Yeah.
And also this one is 0 because you multiplied by 8, right?
Yeah.
So minus 7 plus minus 7 minus 8 plus 7 times 2 to the 3q x3q is 1 mod 2 to the 3q plus 1, right?
Yeah.
So we can say 7 times 2 to the 3q x3q. It is minus 15. When you take it to right side, 15, so plus 1, 16, right?
Yeah.
But I think we divide it by 4. And it's not what's what. I think we had a careless mistake, so let's check here. We said this one is 1, 2 to the 3q minus 2 cubed minus 2 to the 6 minus 2 to the 3 cubed plus this one. So this one is 2 to the 3q plus 1 minus 1, 7 times this minus this one, 8 times, it is 8 to the q, 8q minus 1, 8q minus 1 over 7. So when you multiply by, it is not plus, here it's minus, right?
Yeah.
Because look, it is minus, we have minus here. So it would be plus 8, so 8 minus 7 is 1, right? So
Yeah.
this part is 0, right?
Yeah.
And then you can divide by this coefficient. So x3q is 0 mod what?
2.
Yes, because GCD of this and this is 2 to the 3q is 2. So x3q is 0, right?
Yeah.
Okay, so try to prove this one as homework 1 as homework 2, okay?
Okay.
Coefficient, if you consider, are symmetric. Agreed? 2, 2, 1, 1, and 3.
Yeah.
And for these types of
Yeah.
problems, you can divide both sides by x squared, okay? And
Okay.
to reach something like, let me tell you, it is x squared plus 1 over x squared, right? Plus x cubed. So if you divide by x squared, it would be x plus 1 over x, right? Plus 3, 0, right? Now if you divide the concept, define this one as y. This one is what in terms of y?
What? It's y squared minus 2.
Yeah, so it would be 2y squared plus y minus 4 plus 3 minus 1 is 0, right? And then y is negative 1 plus minus square root of 1. 4ac 9 over 4, right? So negative 1 plus minus 3 over 4. So minus 1 and 3 minus 1, 2 over 4, 1 half, right? So we should check each of them. X plus 1 over x is negative 1. So case 1. So then what can we conclude if we change it to quadratic equation?
So x squared plus x plus 1 equals 0.
X squared plus x plus 1 is 0. So x is what?
X is
Negative 1 plus minus I root what?
minus 1 minus 4 root 2. I root 3.
Over 2, right?
Yeah.
And second case, x plus 1 over x is 1 half. So what can we conclude?
X squared minus
2x
x
squared, let's write, plus
x squared minus x
2
plus 2 equals 0.
is equal to x, yes, 2x squared minus x plus 2 is 0, right? So x is what? 1 plus minus square root of what?
Is my 1 plus square root of 1 minus 4 times 4 again. So 1 minus 16 over 4. So 1 plus minus root 15i over 4.
Plus minus 1 minus 4 I root 15, right?
Yeah.
Over 4. Good job. So we found 4 answers, right?
I thought about like transformation. So you start with absolute value of x and then shift it 1 to the right.
Or let's do something. Let's consider intervals. Absolute value of x is what? For which x's?
Absolute value of x is 0 for what?
No, it's x and negative x. For which x's it is x?
Yeah. Greater than x, less than x.
Greater than equals 0, x less than 0.
Yeah.
And look, it is not important. You can also say less than or equal to 0. Because for 0, both of them are 0, right?
Yeah.
I usually write like this, but if you want, you can write like this. Okay. So, we want to get rid of these absolute values. If we had only these, we should consider 0, negative, 0, positive, and negative. But I want to get rid of these two absolute values. So what can we say? Under what case it is what? Under what case it is
what? If it's greater than or equal to 0, you can just say it's x.
If x is greater than or equal to 0, let's write like this. Then it is absolute value of x minus 1, right? If x is less than 0, it is what absolute value of?
Minus x minus 1.
Yes. Now here again, we want to split two values. We can say what?
if x minus 1 is greater than or equal to 0,
Yes, or if
then
x
it's
is
just
greater
x
than
minus
equal 1, it is x
Oh, yeah.
minus 1. If x is less than 1, greater than equals 0, because here greater than equals 0, it is what?
1 plus x.
Minus x, right? Negative of this.
Oh,
Okay.
yeah.
What about this one?
That one, if it's negative x is greater than 1, so x is less than negative 1,
If x is less than negative 1, what happens?
then it would just be minus x minus 1.
If x is greater than equal negative 1 less than 0, it would be what?
It would just, it would be x plus 1.
Exactly. So we have these 4 cases, right?
Yeah.
So this part, what happens? This part, right? And now we have similar thing for y, right?
Yeah.
So before this, let's draw a figure that is easier to draw. Suppose x plus y is equal to 1. So can you draw this one? Try to draw this and see the figure as well.
It would be it would hit 0, 1, 1, 0, 0, negative 1, and negative 1, 0.
Yes.
And it would be a box.
It would be something like this.
Yeah.
And then 1, 1, negative 1, negative 1, right?
Yeah.
So now let's consider, let's focus first on this part, okay?
Okay.
Try to see, can you figure out this function would be what in first quadrant, okay? Try.
Would it be a square?
Yes,
it would be
could
a
you draw?
square with side length square root of 2.
Okay, let me draw this to show you how we should draw. If your answer is this, then it would be the same. So, therefore, let me it is for 1 because 1 is important for us. Then this point, okay. So let's see what happens. When x is greater than equal 1, it is x minus 1. This one is also y minus 1, so x minus 1 plus y minus 1 is less than or equal to 1, right?
Yeah.
So x plus y is less than or equal to 3, right?
Yeah.
So we should consider it is 1, 2, 3. Something like this. And we should consider this part. Agreed?
Yeah.
Okay. Now, if one of them is less than 1, for example, here. Okay, so first quadrant, second one, third one. It is for first one. For second one, x is here. So you can say 1 minus x. But y is greater than 1. So you write y minus 1. Less than or equal to what, right?
Yeah.
So y minus x is less than or equal what? You can cancel 1, right?
Yeah.
So when x is 0, y is 1. So what? We should draw something like, and when x is 1, y is 2. So this one was what line? For this one, x plus y was 3. So when x is 1, y is 2. So do you agree that it would be this line?
Yeah.
Because look, 2, 1 satisfies this one, also this one. But y minus x for this one is 1, it should be less than or equal 1. So you should consider this part, right?
Yeah.
Similarly, for this one, you should connect 1 to this one, and it is this part, right?
Yeah.
And if both of them are here, then 1 minus x for region 3. 1 minus x plus 1 minus y is less than or equal to 1, so you can cancel. So x plus y is greater than or equal to 1, right? So
Yeah.
we should connect this part, and we should consider this region. Agreed?
Yeah.
Okay, so we found our region is what in first quadrant, right?
Yes.
Okay, now this area is what?
A square.
Yes, the area is what?
2.
2 times 2 over 2 is 2. So the answer is what?
8.
We can guess 8, but let's draw one more quadrant to see it would be what, okay? So try to see how we can figure this part, okay? How we can graph this function here, okay?
Okay. Yeah, I got that same.
Okay, so let's check it. For this part, again, we can extend this red part. We can consider this one. And here, both of them, x is less than negative. X is here, right? X is
Yeah.
less than negative 1, y is greater than 1. So let's consider for some of this region as 4, this region as 5, this region as 6, this region as 7. So for 4, because x is less than negative 1, it is negative x minus 1. Y is greater than 1, so plus y minus 1 is less than or equal to 1. Right?
Yeah.
So y minus x is less than or equal to 3. So for y minus x less than or equal to 3, y is 3x is 0. So we should consider, for example, 2 from here. It would be, let me connect something like this, 2, 2. For this one, it would be something like this, right?
Yeah.
For region 5, x is from negative 1 to 0 here, x plus 1. Y is what? Y is greater than 1, so y minus 1 is less than or equal to 1. So x plus y is less than or equal to 1. So it would be exactly this line below that, and the rest will be similar, right? So the answer is 8. Understood?
Yes.
Okay, what's your next question?
So the 21, you again write it. You again write it in prime factor form.
Yes, and only power of what prime is important?
Power of 2.
Yes, power of 2 is what in 21 factorial?
1 over 18, C.
Power of 2 is what?
Oh wait, no, 1 over 19. So it's 2 to the power of 18.
Exactly, good job, good job. Completely correct. Because we can write, because we want to only find power of 2, we can write only even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 1 over 18 plus 1, which is 19, right? Okay, good job. Let me tell you as homework 1, try to solve this. What is the probability that it is not multiple of 3? Homework 2, what is the probability that it is even? Homework 3, what is the probability that it is multiple of 8? Homework 4. What is the probability that it is multiple of 12? Homework 5. What is the probability that it is odd and multiple of 9? I think these 5 homeworks are enough. Okay, try these 5 homeworks and okay.
Can I get a hint?
Sure. So for this one, if you wanna use AMGM, do you agree A and B are positive real numbers, so we can use easily AMGM, right?
Yeah.
Okay, so if you use AMGM for first bracket, it will be what?
It's 1 plus 2a is greater than or equal to 2 root 2a.
Exactly. What about next part, next bracket?
2 plus 2b is greater than or equal to 4 root b.
And what about last part?
Greater than or equal to 2 root 2ab.
Yes. So one more hint, or that's enough? Want more hint, or that's enough?
Let me try it.
Okay, sure.
Is a equal to b then?
If we multiply these terms, it will be what?
32ab.
32ab. What we know, they are equal to 32ab, right?
Yeah, so like
So
equality.
do you agree on all in? Yes, we have equality for these 3 things, right?
Yeah.
So we said equality holds for AMGM when what?
When the terms are equal?
Yes. So here we have equality. So because we have equality, we can conclude with what is equal to what?
2 root 2a equals 1 plus 2a.
Yes, what about next one?
2 plus 2b equals 4 root b.
Yes. And this one, when we have equal, 2a equals b. So a is what, b is what?
2a. B is 1, A is 1 half.
B is 1, A is 1 half, exactly. And it wants what? It says how many orders, so one answer, right?
Yeah.
Okay, so for 12 we have 1, 2, 3, 6. And 1, 2, 3, 4, 6, 12. So we have 1, 2, 3, 4, 5, 6. Okay. Then it says like this one, there is a unique positive integer that this one is greater than all. Okay. So if we prime factorize n, p to alpha 2 to pk alpha k, we agree we can separate these in terms of primes means f of n. We can say it's d of n over root cube root of n. So do you agree we can say d of p1 alpha 1 over at first, do you agree d of n is d of p1 alpha 1 times d of p1 alpha 2? D of p alpha k agree. Also for this problem, for this one, you should use sigma, sum of positive divisors is sum of p1 alpha 1 times sum of p1 alpha 2. Agree this one?
Yeah.
Okay, for the promise problem, you should use these for sigma. For here, you should use for d and this. So you can say d of p1 alpha 1 cube root of p1 alpha 1, right?
Mm-hmm.
Times d of p2 alpha 2 cube root of p2 alpha 2 all the way to d of pk alpha k and cube root of pk alpha, right?
Mm-hmm.
So by this approach, do you agree f of n is equal to f of p1 alpha 1 times f of p2 alpha 2 times f of pk alpha k?
Yeah.
So do you agree these numbers are not related to each other, right?
Yeah, like they're relatively prime.
Yeah, so for each prime, you should see the max, for each power, we will reach maximum f, okay? And try to maximize each of them and find big N is best. Understand?
Kinda.
Okay, want more hint or that's enough?
I'll try from here.
Okay.
I got that the number was 2520, so the answer is 9.
So it's 9, okay. For each of them, you found maximum one is what, right?
Yeah, I just kind of like
After some primes, you shouldn't check, right? For example,
What?
your number has only what primes?
2, 3, 5, and 7.
From 11, it's not good, right?
Yeah, out of that, 0 is bigger than 1.
Yes, because for 11 to the 1, it's 2 over cube root of 11, right?
Mm-hmm.
Which is less than 1. Then if you add 3 for 11 squared, again, cube root is less than 1, right?
Mm-hmm.
So how can we prove this? Let's write m over 11 to the power of m plus 1, 11 to the power of m. How can we prove it's less than 1 cube root of this?
How to prove it?
Yes, for AMC we don't need, but for example, maybe this one is similar because in promise and SUMaC they were the full solutions exam. But here, for example, we want to prove that 11 is not good. Then similarly, other numbers are not good. So how can we prove this number is less than 1?
M plus 1 needs to be less than root 311 to m.
Yes, or m plus 1 to get rid of that. We should prove m plus 1 cubed is less than 11 to the m, right?
Mm-hmm.
So how can we prove this?
Well, the exponential function just increases faster than the cubic.
Yes, but in general, for large m, yes, for large m it is correct. That's the growth rate. But for all
so
numbers,
they intersect at 0, 1, or they intersect at m equals 0. Two functions.
well, you can use this, but let me tell you a rigorous proof. Okay, you can use induction for m1. M starts with 1. 2 cube is less than 11 to the 1 is correct, right?
Mm-hmm.
Now let's consider for m plus 1 1 proof. So m plus 1 cube less than 11 to the m, and we want to prove why m plus 2 cube is less than 11 to the m plus 1, okay?
Mm-hmm.
If we multiply both sides by 11, 11 to the m plus 1 is greater than 11 times m plus 1 cube, right?
Yeah.
So if we prove this one is greater than m plus 2 cube, the problem will be solved, right?
Yeah.
Okay, so here, how can we prove this? We can say this one is m cubed plus what?
Plus 2m squared. No, plus
6m
2
squared,
times.
right?
Yeah, 6m
Plus
squared.
12m plus 8 is less than 11m cubed plus 33m squared, right? Plus 33m plus 11, right? And if you pay attention, all corresponding terms are greater, right?
Yeah.
So we proved that it's a rigorous, okay?
Mm-hmm.
Similarly, for other primes also you can prove. Then for 2, 3, 5, 7, you should check because these are small numbers. You can see, okay, for 2, you want to see, again, 2 to the m over 11. Oh, no. M plus 1 over 2 to the m cube root of this. You want to find maximum of this, right?
Mm-hmm.
Okay, so you check the small numbers and then you found which m is the largest here.
For 2, then I found 3 was the largest.
3 is the largest. Yes, and you can use this also, you can prove again why, for example, 3 is the largest one. Okay,
You can prove it.
so let's try to prove this. So you check what? You check, okay, m1 2 over cube root of 2. Then 3 over cube root of 4, right? Then 4 over cube root of 8. And 5 over cube root of 16, right?
Mm-hmm.
You think this one is larger than this, right?
Yeah.
Because if you raise the power of 3, then 2 cubed over 2 is 4. But if you raise the power of 3 here, it's 27 over 4, which is 6 point something. And if you raise this one to the power of 3, it's 64 over 8, which is 8, right? And for the next one is 1 to 5 over 16. 1 to 5 over 16 is less than 8, right?
Yeah.
It's 7 point something. Okay, so by this way, but if you want to prove, for example, maximum one is this, let's write the function is what? X plus 1 over cube root of 2x, right?
Yeah.
Suppose, for example, it is g of x. And we want to find maximum of g of x. Or, for example, which x we will see maximum of this. So try to see, can you find, for example, this function in which part is increasing, in which part decreasing, local maximum is what? Try.
Okay. I take the derivative, I get x is like maximized at 3 over ln 2 minus 1.
Okay, let's check here. If you consider g of x is equal to x plus 1 over 2 to the x over 3, right?
Yeah.
So g prime is what derivative of these times?
2
to the x over 3, right?
Yeah,
Minus x plus 1 times, we should take derivative from this, right?
Yes, 2
If
to
you
the
take
x
derivative from ax, it is e to the x ln of a, right? If you take derivative, it will be ln of a to the x, right?
Yeah, e to
So,
the x ln a, yeah.
yes, so you should consider ln of 2, right?
Yeah, we have to divide
Times
by 3.
2 to the x over 3 times 1/3, right?
Yeah.
Over 2 to the 2x over 3.
Yeah.
So, we should
divide
consider...
Then divide the 2 to the x over 3.
Divided by... So, the derivative is this, right?
Yeah, and first you can simplify by dividing by 2 to the x over 3.
Okay. So if you divide it by that, it will be 1 minus x plus 1. ln of 2 over 3 over 2 to the x over 3, right?
Yeah, so now the numerator should be 0, so...
Yes, ln of 2 over 3. We want to see for which x is 0, so x plus 1. ln of 2 over 3 is equal to 1, so x plus 1 ln of 2 is 3. So x is 3 minus ln of 2 over ln of 2, right?
What? 3, oh yeah, 3 over ln 2 minus 1, yeah.
Okay, so before that, or we can say 3 over ln of 2 minus 1. So before that, you can check this one will be increasing, and then after that, it will be decreasing, right?
Mm-hmm.
Okay, and you can find this number is around what? So we can see, we don't need to calculate this number is exactly what, because look, we check for example, power of 2. It is increasing, power of 2 increasing, power of 3 increasing. Then power of 4 decreasing, right? It's something similar to this. After that, because it is decreasing, you can check that to the end it will be decreasing. So we don't have any other maximum, right?
Mm-hmm.
Okay, so it's a proof for this one. You've calculated the powers for 2, 3, and your last answer is 2520, right? This was okay,
Yeah.
and sum of the digits is 9. Oh, good.